Then we can have Arkis is already here. After Arkis is Marlon, and after Marlon is after Marlon is Paul Red. Oh, he's here. He's going to be in person. Yeah, and then it's Sarah is already here, and then it's the panel. Yeah. Oh, hi Matt. Good to see you. So now I should turn on the video, use the rear, otherwise it's not so interesting. Okay. Okay, now you start to see some people. Okay. Okay, now it's working. All right, let me just get it started. My part is really just to get it started. I don't even need to say anything. But hi Matt. I guess we'll wait for Martin and the other people. Yeah, so let me get it started just to stay on schedule. Good morning, everyone. Thank you for coming. Welcome to the second instance of our workshop. And last year, let me see, how can I advance the slide? It doesn't work. Please welcome. How do I advance the slide? Or tab.
No.
But now I'm not on screen.
Maybe because you are.
Now it works?
Yeah.
Okay, good. So last year, when we had the first workshop, this is actually how we motivated that. We said, content moderation is about both user-generated and AI-generated content, and it's by nature multimodal. And this year, we probably don't need to motivate this, any further because of all the particularly Gen AI developments. And it's interesting in that, content moderation work has been going on for many years, but generative AI does bring a lot of attention, also urgency to that. And in part, is because of, things like, these kind of statistics. I was just pulling up. Actually, this was done last August. That's pretty soon after our last workshop, after the DALL-E releases. You see the scale and volume of content, particularly multimodal content, really exploded thanks to the Gen AI development. Also, I think there are other reasons where, content moderation for user-generated, AI-generated content is becoming more important, particularly in the multimodal spaces that, you see that, this kind of, maybe I should bring this off. How do I get this zoom off? Minimize it. These kind of concerns will also, impact how the AI adoption among the consumers. And also more than that is that, there could be regulations, right, already cooking in different governments. In the US or in Europe, there are already a lot of inquiries about such technology and services. So I think all these really bring a lot of attention to this area, and which is good in that this year, again, we have an array of, very established speakers or experts in different fields. And also in this field, it's both technology and human. So we'll also hear about, both work in terms of using technology for multimodal content moderation, and also the human impact of it, and also how human in the loop, work together with AI to co-develop this approach. And so I actually put in all the abstracts and also from the submissions from our speakers and authors. And this is this year's word cloud. It seems like, AI, of course, is there, and image is the probably most frequent word, and generative. And you also see the, the very kind of both technology and human, elements there with the moderators, human, safety, etc., being a key theme. And I compare that to the theme from last year. Last year, actually, generative, maybe because, just after ChatGPT was the most frequent. And then actually, even though we call our workshop multimodal content moderation, last year there was still a lot on speech and fate and etc. And unlike this year, it's really moving on to the the image, and in the future probably audio and the video component of it. So we have a pretty full, pretty rich program. And last year worked pretty well, so we adopt the same approach that we have 2 sessions with roughly some theme. So in the morning, it'd be about AI and the human, kind of how they co-evolve and also collaborate in this space, and also the impact, on the society. And the afternoon will be more about the technology for, generation, moderation, and also measurement of multimodal content. And for both sessions, we'll have invited speakers who are experts in their fields, and then with a panel discussion, we prepare some questions, but really welcome questions from the audience to make it interactive, particularly since it's probably going to be a pretty intimate audience, to make it interesting. And also feel free if there are questions for the speakers. That's also a good time to ask, where we have a lot of time allocated. And also people were saying that last year's program was really packed. But then there should be more time for networking, because people are not coming just for lectures. So this year we have several breaks throughout the day. We have a coffee break in the morning and a pretty long lunch break. So I think for the lunch break, Seattle Convention Center has 2 buildings. Lunch break is in the other building. So it's good that we have an hour and a half to have lunch, and enough time to also network. And in the afternoon, we also have a pretty extended coffee break for half an hour, so people can have more time to discuss and also network. So that's pretty much the layout of the day. And I think without further ado, let me get the program started so that we have time for more discussion. Let me wrap up my part and introduce our first speaker. I'm 2 minutes ahead, which is good. So Akis, do you want to try to share your screen while I introduce you?
Yes, thank you.
Mm-hmm.
Can you see it in full screen mode?
Yes. Somehow, is it because I haven't stopped sharing?
To me, it looks like I'm sharing.
You are sharing? But
yes,
should
but
I?
You don't see it?
What am I not doing right?
I can stop and retry if you want.
No, it's my part. It's more my fault. Okay, I think it's working.
Yes, you can see it now.
Mm-hmm. Oh, it's even better. Yeah, even better. And we are recording, right? Okay. Yeah. Also, if I think some speakers or some discussions, people don't want to be recorded, just remind me, and I will take note of that. Okay. So let me introduce Akis. Akis is actually talking to us all the way from Greece, right? It's still light there. He's a principal researcher at the Information Technologies Institute Center for Research and Technology, Hellas, in Greece. And he's a prolific author and inventor for patents. And he's currently leading the media analysis, verification, and retrieval group. He's also a co-founder of the Infali, I'm not pronouncing that right, private company. It's a spin-out of the current research institution. So I'll let you get started. Please take it away.
Thank you very much, May. The pronunciations were very good. And first of all, many thanks for the invitation. It's an honor for me to give this talk to this very established workshop. And I would really like to be there. Yes, a few words first for the group that I'm leading the Media Analysis Verification and Retrieval Group. We are approximately 30 researchers located in Greece. quite hot these days. Our expertise is mostly on AI for multimedia analysis, verification, and retrieval. Also, we are very much interested in aspects related to AI fairness and countering online disinformation. We are coordinating and also involved in several research projects, collaborative research projects that are funded by the European Commission. And this means we collaborate a lot with many research institutes, but also industrial partners and civil society organizations across Europe. One of these projects that we're currently coordinating is called Vera.ai, and some of the material I'm presenting is quite related to this. In general, I'm going to concentrate on two recent works that we've done. And just to give a bit of a context, I consider a kind of mixed human AI system for content moderation, where a set of AI models process a stream of images, videos, in order to rank them and prioritize them in a queue. And then some of them are reviewed by humans, by a moderation team, but also it could be other kinds of professionals like journalists. And so the first part of the talk is going to briefly present what we've done to refine content moderation models using large data sets that are out there. And the second part is presenting a study that we did, testing a hypothesis that using AI filters could help mitigate the viewer impact. So let's proceed with the first part. What is the problem? Of course, I don't need to state the obvious that content moderation is an extremely challenging problem for AI, even though we've gone a long way with the latest generation of deep learning models. There are still some, not only some, but many cases where AI models fail either spectacularly or simply fail. For instance, you can see this image of an egg basket that until recently it has been misclassified as adult content by Google Vision AI. So those are the very obvious examples of failure. I mean, a human moderator would never fail such a case. At the same time, there are, of course, many more challenging cases that are borderline even for humans. For instance, when a human is asked to classify a nude picture that is a bit artistic in nature, they might, label it as soft porn. And there are, of course, depending on the context and depending on the local situation and terms of services, many cases where the decision is not clear-cut. So one natural thought that one might have is to tackle this problem is, of course, to put more training data to it. And by increasing the training set and the cases, then you simply, improve the model. There is, of course, a problem that this might be a very costly endeavor. And first of all, in the case of random failures like the egg basket, there are simply so many cases that might randomly fail that it's hard to manually identify them. While in the case of borderline cases of inappropriate content, maybe we are talking about disturbing content, and then we cannot simply ask people to continuously annotate such content. There are ethical implications on that, so we want to limit the exposure as much as possible. So our contribution there in a relatively recent work was a method that essentially is applied almost automatically to very large multimedia data sets that are out there, and can be used to automatically select appropriate training samples that, when combined with existing training datasets, they can lead to much better content moderation models. How does this work? First of all, we assume that we do have some training sets, some task-specific training sets that are annotated already for our classes of interest. And at the same time, we do also have access to a very large public multimedia dataset that is not annotated. And then we devised two strategies, depending on whether there is also a possibility to find many positive examples for the task of interest or not. So here in the depiction, you can see the red examples, the red plus signs are the positive class. So the class we want to moderate can be, for instance, not safe for work, or can be violent content or graphic content. And the black minus signs are the negative classes, so essentially the safe content. And in the first case, in strategy 1, we do have a relative abundance of positive cases from another source. And in strategy 2, we have a relative scarcity of both positive of positive class and the negative. We will see how we create such sets. So this is the setup, and the particular strategy depends, as I said, on the type of class that we want to moderate. Let's get into a bit more detail. An exemplary class for strategy 1 is not safe for work content. So, for instance, porn content. This is a case where there are really many positive samples available. There are public sites with tons of porn content. So the starting, we do have also, as I said, a task-specific annotated dataset, and based on that, we create a baseline model, F, positive class, not safe for work, negative class, safe for work. And then the first thing we do is we apply this F model, this simple model, to a very large dataset, DL. So you can imagine this can be ImageNet, it can be, for instance, YFCC 100 million, Lion 400 million, and so forth. The underlying assumption is that this big dataset, to a very large extent, is rather innocuous. So the examples that it contains are mostly negative. Of course, there has been prior research that showed that among these many millions of images, in such datasets, there are, of course, several cases that are problematic. But in this case, we consider that this baseline model, when we apply it to many millions of images and retain only the very confidently classified positive samples, we end up with cases that are mostly positives, but among those we will also have some misclassified examples. So we will have examples like the egg basket that I presented in the beginning. Those we call hard negatives because even though they are easy cases for a human annotator, for an AI model they are hard because in the initial model they led to very confident classification. So after running this over the whole dataset, then we end up with a set of such cases, which we use actually in the next round of training as negatives. So we end up with a refined model that hopefully performs better. Actually, we empirically found that it does perform better. And we can repeat this a couple or more times until we don't see any further gains in performance. So this is what can work pretty well in the case of not safe for work content. The second strategy is mostly suited for cases where we don't have so ample positive examples. And a prototypical class of this is disturbing content, graphic content. Again, we start with a baseline model because we assume, again, we have access to a small task-specific dataset to train such a model. Our positive class is the disturbing, our negative class is the safe images. And again, we try to classify images of the very large dataset that is not annotated. And in this case, we opt for a nearest neighbor-based classifier where we make use of the penultimate layer of the underlying model. The reason for this is that in that way we can control the level of similarity to existing annotated examples, and we can gradually increase the number of samples that we annotate in a controlled manner so that we get progressively more and more data from this very large dataset that are highly likely to be disturbing. So in this case, making a pass through this model gives us a few additional positive samples. But the problem there is how to also populate the negative class in this case, because essentially negative is everything else. We need a way to sample in a very diverse manner, and for that reason we generate really many random subsets of images and pick the one with the highest standard deviation in terms of feature values. And again, we can repeat the process to gain some further improvement over iterations. We empirically tested these two strategies. We used some existing publicly available data sets. So one data set for not safe for work detection, and another for disturbing image detection. In both cases, the large unlabeled dataset was YFCC 100 million from Yahoo Flickr. As a backbone, we used the FissioNet P1 because it was a very cost-effective choice for experimenting with it. And the first strategy led to accuracies in the range of 95.7% on images, individual frames of videos, because we used the video dataset for testing. And when estimating the accuracy on a video level, this was even higher. And importantly, it outperformed all state-of-the-art at the time, even methods that were much more sophisticated and complex, computationally speaking. And it led also to improvements compared to our baseline classifier. Strategies 2 also led to again, quite high levels of accuracy and also to gains over the baseline. So these gains that you see are quite modest, they are not spectacular, but still I think it's important that we manage to, gain them with a very simple approach without almost no manual annotation effort. So it's something that can be applied essentially for free. I mean, you do pay the computational cost of classifying a very large data set, but at least there are no major annotation costs involved. And here are some indicative examples that we could solve with the method. What you see is overlaid are GradCam activations to show where the refined model pays attention based on the GradCam method. And you can see that in the left cases, we have essentially safe images that were previously misclassified as not safe for work because they depict some parts of the body parts naked, but of course in a completely safe context. So these cases were correctly classified after the refinement that we proposed. On the right side, you see some other cases that were misclassified by the initial disturbing image detection models. The reason is likely because there was some marmalade on the first image on top of the dessert, and the marmalade was confused, I guess, with blood. And the second image was a piece of raw meat, and I think it's quite obvious why this was misclassified by the baseline model. But both cases were correctly classified after the refinement step. Of course, this is, a particular instance of a method that we tried, so we could do much more in the future. So first of all, the initial task-specific training sets were rather small, and we would need to investigate if we could gain similarly in performance if we started from more powerful baseline models, which I guess, for instance, large digital platforms possess. Also, we just tested on two very crude classes of inappropriate content. I guess future experiments could look into whether this is applicable and successful in more fine-grained content moderation classes. And of course, there are other interesting directions like investigating more sophisticated negative sampling methods during the training iterations, and also to check whether the cases that are misclassified are also cases where, by the models, I mean, are cases where there is high interannotator disagreement or not, which could shed further light in building better AI models. So that was it for the first part. So let's assume now that we have some good AI models to perform the automatic moderation. Then we want to see if we can protect people working in the human annotation tasks by using AI filters. The reason I think is pretty obvious. There has been a lot of research that repeated exposure to disturbing imagery can lead to excessive mental stress and long-term consequences to the emotional state of people. And of course, it's not only content moderators, even though those are likely the most affected by repeated exposure, but there are many other professionals working with harmful content, and this is important for them. And there are several, of course, interventions that can be made. Our little contribution there is that we thought of applying AI style transfer filters to mitigate the emotional impact of disturbing images. And to validate our hypothesis, we conducted a user study where we compared the effectiveness of these filters against the more traditional blurring techniques. Of course, this is a problem that has been quite comprehensively studied before. There has been mounting evidence from the literature that exposure to disturbing content leads to increased risk of secondary trauma and even post-traumatic stress disorder. And this affects a large number of professionals dealing with graphic content, like, for instance, journalists, fact-checkers, human rights investigators, and the like. And the most common technical intervention or mitigation approach that is currently deployed is to rely on blurring, image blurring. But this we believe has also some limitations, like, for instance, it's much harder to understand what the underlying image depicts. So it could slow down the work of people working with such content. So what we hypothesized is that using some AI style transfer filters could perhaps strike a good balance between maintaining the information content of the image, but mitigating the emotional impact. And here you can see the kinds of filters we proposed. At the top left, you can see the original image. And next to at the top row are the drawing and colored drawing filter, while the first at the bottom is the painting filter. And the two last examples are the traditional blurring filters. One is partial blurring, the last one is full blurring of the image. From a technical point of view, these AI filters, I mean, the ones we tested are based on what is called progressive attentional manifold alignment algorithm. It's an encoder-decoder architecture that tries to emulate the style of to transfer actually the style of an image, an example image, to a target image. So in this case, for instance, the original image is the target image, and there are three different styles that we tried out: the drawing, color drawing, and painting. So we wanted to test what is the effectiveness of this and generally understand how people that work with this type of content perceive such filters. And we designed a survey, and just, you know, an online survey with questions. that contained three parts. First was collecting, some basic demographics and some information related to the profile of the people that took the survey. The second part had two phases. This was also the main part of the survey. In the phase 1A, we showed 5 transformed images, one by one, and asked the respondents to rate their emotions after viewing these images on the so-called PANAS scale. So they self-reported their emotions like distressed, upset, scared, irritable, nervous, jittery, and afraid. Plus, they added a free text description of the image, and this was to test whether they really recognized the information contained in the image, even after the filtering. The second phase showed the 5 transformed images side by side and asked the responders to rate the overall level of disturbance when seeing each of them compared to the others. So in the first phase, we aimed at capturing the mitigation of harm compared to the original. So in each filter, we compared original image versus filtered image for the 5 different filters. In the second phase, we compared directly the 5 transformed images with each other. And in the last part, we just asked for some free text feedback by posing a question to participants. We distributed this survey to a wide network of contacts through our collaborator in the study, Jochen Spangenberg from Deutsche Welle. And additionally, we published an open call for participation through several social media channels we had. In total, we gathered 86 direct responses to the invitations from more than 42 organizations and 21 responses as a result of the open call. So 107 responses in total. And the backgrounds from people who responded included researchers, social science researchers working with sensitive and harmful content, journalists, human rights investigators, fact-checkers, editors, political scientists, documentalists, forensics analysts, and some other profiles. So very, very relevant and very diverse professional profiles. In terms of ages, we largely had people from mid and senior experience involved. So in the age groups 30 to 45 and 45 to 60. So these made up like 3/4 of our sample, while there was approximately 22% of people that were quite young. In terms of gender, we had mostly binary identifying people, 54% male, 41% female, and the rest non-binary. In terms of exposure, 34.5%, so approximately 1/3 of people are exposed multiple times per week to such content, 22% daily, and the rest were exposed less frequently. And in terms of reaction, about 40% have sometimes negative reactions, emotionally speaking, negative reactions to content, 36% rarely negative, while 15% regularly negative reactions. So we can see that those are experienced people that regularly are exposed to such content and can handle it, let's say, in most cases. Of course, we had also people who do experience strongly negative emotions frequently. And first set of results. So how do different filters mitigate the negative feelings? We found out that the painting style was the most effective in mitigating negative feelings, with an average 38% mitigations in this PANAS scale. So just to interpret this graphic, in the blue boxes, we have the filtered, the scores from the filtered images, while in the brown boxes, we have the original images. So the first two refer to the painting style. You can see there is a big drop between the average of the original versus the one in the filtered version. And then we have colored drawing, partial blurring, which also has very significant reduction, drawing style, and blurring. So you can see also here the average reduction in percent. Drawing and blurring and partial blurring are pretty effective in mitigating negative feelings. But as we said before, another dimension is how much of the information is preserved when doing this kind of filtering. And to do this, we also computed the so-called interpretability ratio. How we did this, as we said, we had asked people for a free text description of what the image depicts, and then we manually checked whether this free text description correctly described the image or not, and we computed the ratio. So in the case of, you can see this is in the y-axis, so the higher it is, the better the information preservation, while on the x-axis we have the mitigation ratio, so the rightmost the dot, the better, because it's more effective in mitigating harms. So we can see here that painting, as we said, is the best in terms of mitigation, but there is a certain reduction of information. So it's approximately, we see in 80% of cases, people could correctly understand the image content. At the same time, we see that the drawing style and partial blurring style strike a very good balance between mitigation ratio and interpretability, so the preservation of information in the image. So yes, we see that these are two particularly effective choices. And last, we directly asked people if they had the opportunity to use, in the context of their work, one of these filters, which one would they prefer to use? And we had a little surprise there that people still preferred partial blurring, clearly, compared to, for instance, the drawing, even though, as we saw before in the previous measurements, the drawing led to much better mitigation. People still preferred partial blurring. Maybe there is also a factor of, prior familiarity with this type of filters, but perhaps it requires more investigation why people still prefer this. And of course, we collected some very interesting qualitative feedback, like people really finding this useful and having this as one of these filters as a default filter would help them. They agreed that having this kind of AI style filters creates an abstract image that gives a symbolic understanding of the content that is still quite useful to understand without, being too explicit. And some other good suggestions were that to combine these filters with the localization, so to have partial AI style filters, like we have partial blurring, this could potentially be more effective. Following our research, we have also integrated these filters in an asset annotation and management tool that we have developed in our group. And here I provide a snapshot of this. So here you can see how this would look like in a more practical setting. Of course, if there is any interest, this is operational and we could provide access to people interested to test this. Of course, there are several limitations in our study and many more questions to be addressed. So, as I said, a potential to apply such AI filters locally could lead to even better reception by people working with these images. Alternative means in this area of foundation models and generative AI, we could perhaps ask such multimodal foundation models to describe the image they are viewing without us looking in the image, and perhaps this could be sufficient. Sometimes we have been told that there may be images that are disturbing without being graphic. And this is obviously a very challenging case because this perhaps is a bit personalized, what is disturbing to different people or context specific. And I think these will remain very hard cases, at least in the near future. And of course, moderating, and mitigating impact in audio and video is probably more challenging compared to mitigating it in images. And these are people that worked on these two works that I presented. I think I took a bit more time. I'm sorry for that. If there are any questions, I would be happy to respond.
I think we can have one quick question. Is there a question in the audience, also the Zoom room?
I have a question online if nobody in the audience. Sure. Can you go back to the interpretability results?
Yes, one moment. Yes.
Sure. So quick comment, everyone. Hi, Matt Leese, UT Austin. I'm one of the co-organizers and really excited to see work like this that's doing great stuff you guys all know how to do in computer vision, multimedia, but how we can sort of make this work less disturbing for the moderators we depend on. In terms of interpretability, was the question here that they could just, when you say guess the content of the image, it seems like that's different from what they need to do in moderation. So if the moderation decision is just, is this basically a problematic image or not? I don't necessarily need to know the details of what's in the image. So can you clarify what the question was in terms of interpretability that you actually asked?
Yes, you are pretty right that the question was, can you describe the content of the image? So it was a more demanding task than the actual task they would need to perform. Well, I think it's pretty accurate to say that this doesn't reflect the the real downstream task that these people probably need to tackle. However, depending on the particular moderation class, maybe, you know, in some cases it is important to understand the content, in others not so. We didn't want to restrict it to a very specific, you know, class description, so to say. Do you find this as a disturbing image? Because then we wouldn't be able to reason about whether this can be applicable to other kinds of harmful content. I guess that was our rationale. So you can perhaps this can serve as an indication of how much information moderators or human annotators can extract from an image when it is filtered.
Great. If I could ask one more quick one on the next slide. So one of the things we know from Firework is just simply giving moderators controls is valuable, whether or not they even use them, because it gives them a little more control over the work they're dealing with and many things they don't have control over. So the fact that they have a preference is really important. But I didn't see in your qualitative comments on the next slide, do we know anything more qualitatively about why they have this particular preference? For partial blurring, you know, for instance, you're saying, versus the other forms.
The only, I mean, in general, in most of the comments, we saw that they appreciated a lot these AI filters. There were, however, a couple of cases where they actually considered them as, you know, they considered that these filters detached them a bit from reality, so they created a kind of different meaning than the actual reality, which they thought that could be misleading or unsettling even in some cases.
But is that about filters or no filters, or comparing the relative filters to one another?
Actually, that was a more general, you know, question, like how we didn't ask them specifically to compare, to give us, you know, free text feedback on the comparison with the original images or with other filters. So we just asked them for free text feedback. But it became apparent that some of them appreciated, in the case of partial blurring, they appreciated the fact that they could see the original image for the non-blurred part. So this could help them better understand the context.
Wonderful. Really nice work. Nice talk. Thank you.
Thank you.
Thank you so much, Akis. And I guess you'll come back for the panel discussion.
Yes.
Yeah. Thank you. And yeah, shall we move on to the next speaker? Matt, you were going to, were you going to?
I can, if you want. I would just be looking at the abstract. It's easier for you there, either way.
Okay, yeah, I can do that. Yeah. Our next speaker is Martin. She actually will speak to us all the way from India. We are definitely a very diverse workshop, which is great to get different perspectives. So Martin, if you can start trying to share your screen, I will introduce you.
Right. Am I audible?
We see you. We see your face.
Can you hear me though?
Yeah. Yes. Hear you well.
Yes.
You're audible.
All right. Okay. So, and my screen is on. Is that clearly visible?
Yep, it's visible. It's perfect. Yeah. So Martin is a chartered psychologist with a PhD specializing in health psychology. In her current role as senior behavior scientist at TaskUs, right? Martin leads a global team of researchers focused on employee wellness and productivity. And prior to this, she also served in teaching and clinical roles in academia. Her research focuses on organizational people care, user experience, biopsychosocial. Am I pronouncing that? Biopsychosocial. Yeah, interventions. This is amazing. And also psychometric tooling and phenomenological. I'm so sorry.
That's very
and the cross-culture exploitations I would love to listen to more to your talk. And she's a prolific author, and also she's passionate about advocating for diverse HCI design and equitable and ethical technology for human augmentation. Yeah. So Marlene, please take it away. I'd love to hear what words mean.
Thank you. No, of course. Thank you, May. That was great. Thank you so much for an extensive introduction. Hello, everyone. I'm really delighted to be meeting you all across the world virtually. So I'm Dr. Marlene Savio. I'm from Taskus, a global business process outsourcing company. By training, as mentioned, I'm a health psychologist. So pretty clear disclaimer is that I do not have an engineering or tech background. But my passion to sort of work full-time in actionable research led me to my current company that offers digital solutions and services for leading platforms, right? And here in the last 3 years, I have been leading projects as well as my team with a mission to improve the wellness of frontline employees who are engaged in what we call the trust and safety upkeep of a variety of online spaces. And this includes work that involves content moderation, customer experience enhancement, and AI services. So today I'm really honored to be here on, through Matt and May to be meeting you all, to be amidst you wonderful technologists and innovators, to talk about opportunities in the commercial content moderation space where your ideas and solutions, I strongly believe, can make a pivotal difference to employees' well-being and productivity. So please bear with me for not talking in tech jargon, because I want to draw focus to the humans in the content moderation loop, the rapid evolution of content moderation in the last 2 decades, which has left and turned many things except the need for human oversight. And finally, the apparent gaps that we're seeing in moderation processes that you as tech experts have the power to fill and transform for the greater good. So really, to set context at the outset, I want us to look at the most popular currency in the world right now, which is digital content, and really fathom its scale. So within a minute, you can see a gazillion amount of content is being generated worldwide, with a majority of it emerging on social platforms. For many of you, this probably is not novel information, but what we don't often see and acknowledge is this invisible workforce behind the scenes that safeguards the online realm. I'm talking of content moderators who review content in myriad forms to ensure it aligns with platform policies and is also safe for end user consumption. And when you think of it historically, this task had very humble beginnings where people who worked in policy or in community operations for digital platforms would be tasked with reviewing any flagged content, right? But over the years, with the explosion of user-generated content, today we're seeing this task transform into a full-time profession for over 100,000 people across the world. And my talk today will focus on these moderators' work and experiences. And if you would like to know more about the history of trust and safety, I would highly recommend visiting this site because it has some fantastic literature on policy, on experiences of moderation, and so on. Right. So since we are talking of digital content, I must mention that unlike the yesteryears, content today is a lot more nuanced, and it is aptly captured in this acronym VUCA, which is that our digital posts or digital content is marked by volatility, uncertainty, complexity, and ambiguity. With almost every sphere of life being digitized, particularly since the pandemic hit, harmful content is no longer your once-in-a-while shocker video, right? There's large volumes of text and audio content as well that have a lot of risk for subtle violations and that take a lot more time and effort to review for moderators. Advances in virtual reality and gaming have also increased the scope and dimensions for online social interactions. and creating new spaces. But then this also calls for a lot more sophisticated checks and moderation. Also, on the other hand, you have bad actors who are fine-tuning their strategies, so much so that we're seeing a blurring of online and offline spaces, and also worse perpetrations of harm across these spaces. The immediate questions a lot of times that we get is, so what are enforcement authorities doing about this, and trying to keep a check on such kind of misuses? Interestingly, however, a lot of time their efforts inadvertently results in a lot more complexity and confusion to moderation processes, because regulations vary across the world. They pertain to different or very tiny details that sometimes is difficult to practically deploy within moderation settings. So imagine how dizzying all of this must feel for the everyday moderator to untangle and fix digital content. So which is why content moderators form a very niche workforce that must be supported and nurtured with empathy and also the right work tools. We have noted across our research studies with frontliners that very egregious or graphic content that, and here I'm talking about posts that involve abuse, gore, explicit materials, suicide instances, and so on, that tend to be naturally emotionally distressing for most moderators, particularly in the early days of them starting this kind of work. We nonetheless found that when we take a wellness-informed approach right from the point of recruitment up until their offboarding, right? And this includes being transparent about the job that they're getting into, conducting behavioral interviews, administering psychometric screenings, and inducting psychosocial skills training throughout their life cycle. We see that moderators' shock or startled response to egregious content exposure is reduced, and they achieve a kind of meaningful habituation to working with such content within a month of joining. And with this three-pronged approach, where we use wellness training, wellness tooling, as well as continual assessment or psychometric screenings, we have been able to bring down the secondary traumatic stress risk among these moderators, and also help improve their resilience. Even those working in very severely graphic content have almost similar well-being levels, which is favorable to those who work in more benign content cues. And this happens when they're offered this proactive wellness support, right? But this doesn't seem to be sufficient. And as I mentioned earlier, digital content is in constant evolution. And so our solutions as well for moderation work must in parallel keep pace and improve with such content. One of our research studies revealed that moderators find work that involves moderately graphic content, that is where harm is not explicit, such as in political posts, bullying instances, harassment, polarizing material, content involving minors, far more stressful. In fact, when we asked for a description of jobs that they had most misses on, it was surprising that we found that it was content involving, moderate graphic nature, right? And it was not harm that was outrightly hazardous. Because these kind of posts require interpretation based that is contingent upon culture, context, target audience, and so on. Content moderators spend so much more time and thinking in deciding the right action or the appropriate action for reviewing such posts. And there's also those blind spots or overlaps in content guidelines, which then increase the strain and risk of inaccuracies for moderators. And I'm going to quote here one of our content moderators whom we reviewed as part of our research study, who said, "Graphic content is easier to review because the violation there is explicit. You already know what action to do. However, moderators do not experience the same kind of clarity and ease of doing their review when they work with moderate content. And at times, such content, especially those involving political aspects, tend to also mean something to the moderators, or it could be an issue that they personally feel about, and this affects them more deeply. So, for example, one of our studies in collaboration with MIT and Google on the impact of disinformation was eye-opening. We initially observed that moderators are more likely to believe false information when they are repeatedly exposed to it. However, when we tried to induce an accuracy mindset through giving them a single prompt that encouraged them to evaluate the truthfulness or the accuracy of the information they were reviewing, there was at least a 15% reduction in their tendency to believe false information. These results definitely highlight that disinformation, although seems a lot subtle and inconsequential, does affect content moderators' worldview. And therefore, it's important for us to intervene and not let their discernment be downplayed. Also, an important learning for us during this particular project was that our solutions or our work support tools for content moderators need not be very sophisticated or hard to build and integrate. They can be simple tools that can fit into their workspace, fit into their workflow, and make a huge difference to their well-being as well as their worldview. Besides and looking beyond content, really, we also noted that content moderators tend to actually find a lot of pain points with their workflow aspects itself. They often need to toggle on multiple tools or keep active on several tools simultaneously when trying to review one post. And at other times, they lack the tools that are necessary to handle ambiguous content, such as good fact-checking or knowledge support mechanisms. And so we observed that among content moderators who are offered periodic wellness support, they did seek support from their trainers or from mental health staff like counselors for stressors that were related to workflow than to content itself. And this was quite startling for us because you would imagine that content is what deeply impacts them, but it's also workflow stressors that continually have an impact on them and therefore need to be addressed. Less than 30% of these respondents actually spoke of content as interfering or affecting their well-being. When we think of all this, it's also, we understand that definitely there's no iota of doubt in terms of how much algorithms are supporting moderators in terms of reducing their strains and improving their capabilities of working with scaled content. But we have hardly ever come across a content queue that is exclusively managed or overseen without human moderators. And I can give you a case in point here, which is based on the football event of 2022 World Cup. This collage here that you see is based on findings that was put out by the FIFA Social Media Protection Service. And this gives a summary of all that transpired on various social platforms in a way that was not exactly positive, right? Thousands of posts had to be passed on by AI queues onto human moderators and were ultimately pulled down for being harmful in very subtle yet consequential ways. And so very often we find that content needs to be vetted by humans to confirm or revisit the action. From all of this, we gain that, or we understand the insight that interpretation is a key aspect of content review, and it requires dynamic skill, knowledge, and worldly awareness to make sense of context and culture as relevant to the user group of that particular content. Second, even though content queues tend to be dedicated to specific types of content, it is not guaranteed and never clean. More often than not, people are needed to address ambiguity concerning those posts which are the odd ones out, right? And so in this vein, we notice that there are several unknown unknowns in the moderation workflow that cannot be resolved through applying simple or very sophisticated logic also, but call for human level creativity. It really seems like a futile exercise in trying to pit moderators and technology against each other. Human expertise and technological prowess exist, but they should not be siloed. In fact, in tandem, they can handle harmful content a lot more strategically and efficiently. So having established the value that humans bring to moderation processes, I want to touch briefly on what lies ahead for content moderators. These are new terrains that come through emerging technologies for content review, and this includes on generative AI platforms and in virtual reality spaces, right? So AI safety annotators, as the previous speaker had mentioned, are humans who train and secure Gen AI models through actively engaging with the model, generating or writing, first-hand writing prompt and response templates that can then be used to train or even directly used by the AI model itself. And also, importantly, performing adversarial training or red teaming. All of this work requires significant creativity, role-playing of bad actors, and and also a lot of critical and higher level thinking that annotators must demonstrate in this kind of work. There is, in fact, now a growing demand for talent in the annotator population itself, for those who are subject matter experts, even PhD level expertise, to train specialized AI models. Another instance is the expansion of virtual reality spaces. And moderating in this environment, as many of you would already know, tends to be an experience that's far more vivid, precarious, as well as immersive by nature. And so what we hear from moderators is that there is an overload on their senses, with the potential for a lot more impactful negative encounters. And some of them have even reported feeling depersonalized from their own body and self, after their review work. So all in all, a lot of these emerging technologies obviously, enhance user experience. They also simplify a lot of our mundane everyday activities. But we still need a workforce that stands behind and that is engaged in such cognitively and psychologically demanding tasks which power these emerging technologies. And I can assure you, from having worked with content moderators in the past few years, observing them side by side, that a lot of them, a majority of them, are driven by a strong purpose to serve and protect digital spaces, particularly vulnerable users. And so as employers and as a society, as innovators, as technologists, as problem solvers, we have a duty of care to offer resources and immunization to these frontliners. We propose this 3Cs framework that can guide innovators in embedding psychological safety into content moderation work. And this is regardless of content severity, novelty, content type, and so on. Clarity is a fundamental and critical aspect or element of the moderator's life cycle. We need better tooling that can streamline moderation work and help them adjust better to this, right? Change management is another area that needs to be handled better, not so much at the strategy level, but really at the micro level of doing moderation work. And this involves having tools and having workflows that can help moderators navigate and adjust to policy changes, policy ambiguities, queue changes, content changes, and so on. Finally, it's most important that we enable our frontliners to cope in a healthy manner right from the get-go. Right? A reactive care where we offer support and tooling after they've been exposed, after they start feeling traumatized, or after they reach out for help tends to be very delayed and also very expensive, right? When wellness is built into the moderator's job routine and workflow, they really transform into a resilient workforce that sees purpose and meaning in their work. And what I have understood from being in this domain in the last 3 years is that content moderation is not just about content and platforms, right? It essentially is a good fight that we're all fighting one way or another. But most intensely, it's fought by these frontliners who on a daily basis are vetting content and keeping our spaces safe. Of course, I'm not a tech expert and I cannot spell out what solutions will fit the scenario, but I hope that this talk has given you an idea or a snapshot of the human experience or the people perspective of doing this kind of work. And I'm confident that we can together co-create a thriving trust and safety production environment that is both people-centric as well as good tech-driven, right? So definitely looking forward to continuing this conversation with those interested in research and tooling that supports content moderators, benefits both their well-being as well as their productivity. Thank you so much for giving me this opportunity. I'm so grateful to Matt and May once again. Really, really excited to be here and to have this opportunity. Thanks, everyone.
Yeah, thank you so much, Martin, for the talk. And it's very educational. Are there questions in the audience on Zoom or in the room? I am so not proficient with Zoom. Let me see. The questions in the...
I can get us started if we
please,
don't have any questions already in the audience ready. Marlon, thanks again so much for being here. It's amazing for us to have access to somebody who's actually working with these workers on the ground, who has your background. So tell us, as technologists, what would you love to have us build for you? What are one or two problems that you particularly think technology might be able to help with, or any particular ideas for particular kinds of technology solutions you'd love us to do to make work better for you and your moderators?
Sure. I think one, firstly, guided by simple design that's user-focused and improves their experience. So anything that can be integrated into their workflow directly, because a lot of people come with solutions, but they cannot, they're so complex or they require a whole platform by themselves. That doesn't. Moderators themselves turn away from all of this, right? They prefer to it increases their average handle time, it reduces their performance and so on. So definitely tools that can support their work in terms of knowledge check, in terms of fact checking, and yet, can maintain the integrity of the platform. I think those are definitely key things that should be plug and play, that would be very helpful.
And for anybody who, has ideas after the talk and they want to, engage with you later, I saw that you shared your QR code and stuff. Can people just reach out to you with questions or kind of explore possible engagement with you?
Yeah, sure. Of course.
Wonderful.
Okay.
Thank you.
All right. Thank you so much again. Thanks, May.
Yeah, thank you. And our next speaker is Professor Paul Wright. You go by Paul Wright, right? Are you going to do through Zoom or in person? I thought you were going to be in person.
Paul had sent an email that he wasn't able to make it there in person due to a logistical issue, and he'd asked to present online. Is he with us online here?
Yeah.
Can you hear me?
Yeah. Can you?
Okay, sorry. I have some difficulties as I had flight challenges and then luggage not being here.
Oh, no.
So I'm going to be online and I'm going to try to do my best to control the slide maybe from my side. But in case we got any difficulties, I may need you to control the slides, if it's okay with you.
Sure, of course, we will. Yeah, thank you for still trying. Really appreciate that. It's a lot of the logistics.
Absolutely. I think my luggage decided to have a vacation much earlier, so caused all this headache.
And Paul, are you someplace where you'd be able to share the video for your talk today? Or is that not possible?
I am gonna. My connection is very bad. I'm sitting in a business center, and so I don't know if it's possible to share the slide from your side or May's side.
Yeah,
I mean, if either way, yeah.
You can try while I'm trying to download your slides. So you probably just send me, right?
They're on email to us. I could also do it if that would be preferable.
Yeah, why don't you do that? That'll be easier.
I put in notes so people, they know I'm presenting so they don't walk here. But in case you guys hear people walking.
I think
Great. So my PowerPoint is just starting up right now with Paul's slides.
Yeah, that's fine. Do you know where your luggage is taking vacation, Paul?
Yeah, God, I wish I knew. I think there's a delay. It should be here this afternoon. That's all they share with you.
Hopefully somewhere warmer.
I came from a warm place. I would prefer actually Seattle.
Okay,
coming
good.
from a 90-degree in Texas, this is much better weather.
Yeah.
So Paul, I've got your slides shared. why don't you go ahead and try video? And if for some reason, we can't hear consistent audio, we'll let you know and you can just switch back and turn it off.
Okay, let me give it a try. I'm not sure. I'm using actually my iPad. Does it work?
Not yet.
Okay, let me see. No?
I don't see video for you yet, at least. But ultimately, yeah, if the video won't work, we can certainly just proceed with audio.
And you can start sharing while, okay. No, it seems it's not cooperating, unfortunately.
Okay. May, do you want to just proceed with the introduction and we can get started?
Sure. Let me do that. So we have Professor, you go by Paul Wright. I want to know how that name came along. Professor Paul Wright is an associate professor in the Department of Information System and Cybersecurity, and also Electrical and Computer Engineering at the University of Texas, San Antonio. He's the founder and the director of the Secure AI and Autonomy Laboratory, also co-founder and assistant director of Open Cloud Institute at University of Texas at San Antonio. And he will talk to us about content safeguarding in the generative AI era. Professor Paul Wright, do you want to take it away?
Sure. Can you hear me, May and Tom?
Yeah, we can hear you well.
Okay,
and you
perfect.
to ask
Perfect.
Matt to help you advance the slides.
Yeah, thanks. Thanks for the introduction. After Merlin's presentation, actually, hopefully I could convince her that maybe large language models are a suitable approach to help some of the challenges that she discussed. So today I explored the idea of conditional vision language models for content moderation and content obfuscation strategies. These approaches enhance the detection and management of harmful content while preserving the integrity of the user generated content. Let's dive into the solution we put together and the exploration that we've done with large language models. Before going through the slides, I would like to take a moment to thank my collaborators and students that they work for the past year and a half with me and several agencies, including Homeland Security, on some of the projects that we worked in our lab. First, Dr. Nishan Vishwamitra, my PhD student Mozal Bhutani and his brother Ahmed, and Brandon from Periton Labs, and Dr. Nicole Bibi. Let's start with a quick introduction to content moderation. As we all know, content moderation is involved with the process of monitoring and managing user contents, billion of contents that gets uploaded every minute to ensure the consistency and making sure all the content follow the platform policy and guidelines. For example, if an image is tagged, if an image that is uploaded by a user is tagged as a nudity, the nudity is against the platform rules, the image can be automatically removed by the AI system behind the scene. But this is a case that the content moderator will review the content. And if, for example, if this is a person with bikini, may decide that this is not against the rules of the platform and allow the content to distribute and disseminate in the platforms. Next, please. Today, most of the content moderators, they are using a right-based, very judiciary style systems for moderating the content. As a result of this, when there is as a result of this, for every content, they evaluate the content accuracy. And also there is a appeal process, that the appeal process follows the judiciary in a fashion that if the content doesn't follow the process, the person that violated the content, his accounts may get blocked, or some cases the contents may be blocked, and now the person could follow a process of appeal. And regardless, this process is very time consuming and complex. In some cases might be able to actually win the case and allow the content to be distributed in the systems. Next, please. One of the biggest challenges, the scale of the content moderation, shows that the platform like Facebook, YouTube, TikTok, at any hours, they conduct this manual process of judiciary that I discussed, or right-based systems. At any hour, around 400 pieces of content in Facebook, or 200,000 pieces of channels in YouTube, or in TikTok, 35 videos will get blocked. Or also with Facebook, that they have an oversight board. The oversight board may oversee more than 100 appeals at any hour. As we all know, in our judiciary systems, it's not really it's not designed, that type of system is not designed to handle such a complex scenarios that we deal with social network. Next, please. So as a team of thousands of content moderators across the board work hard to enforce community policies, the main challenge is about applying rules consistently across the massive amount of content that we observed in the previous slide. While policies are very easy to, and is designed to tell the people that they are using these platforms to give them a guarantee and provide them the confidence that the platform is sufficient and it could help them with the activities. Unfortunately, translating these policies to a real action that is happening by the content moderator, it is very cumbersome task. Moreover, inherent mental limitation added to the challenge. As we all know, we have a short memory and a long-term memory. And as the content moderator, they spend hours and hours every day to clean up the content due to stress, due to the amount of content. Their accuracy as a mechanical torque system to clean up the systems start dropping. And that's basically subject to human factors. And it's impossible to solve this problem with the scale that we are looking for. For example, in our judiciary system, I think the First Amendment cases in court, we had only 200 cases in First Amendment that it went to Supreme Court. While, as we saw in the previous slide, this system has to deal with the scales that we discussed, which is really, the system was not designed for solving such a problems. Next. Another challenge, everyday moderators are exposed to a wide range of harmful and disturbing content, including cyberbullying, graphic violence, and explicit images, and also distressing news. This content may, as we have seen in the past, this content and the lawsuits we've seen with Facebook, this content provided, as Merlin mentioned in his talks, creates a lot of psychological stress on the people that they conduct this work. So from one side, the job is a task that is not really designed for human attentions. From the other side, also it's impacting the people, that the psychological impact and emotional tortures that provides to the people, that they are doing this job for us to save, to make this platform safe for us so we could use it every day. Next, content moderation also face another challenge, which is making subjective judgments. This task requires them to balance the enforcement of guidelines with the context and significance of the content. And we know, as most of these content moderators, they are distributed across the world. Sometimes for them, it is really hard to understand the detail and context of an image. The primary example is the Naple Gear photography, that it was the Vietnam War a spot news photography in 1973 was tagged and blocked by Facebook in 2016, which it causes a lot of challenges in European Union, which finally, after several appeals, they brought the content and distributed in the content. So understanding the cultural, understanding the context, also it's a very challenging task for humans that they are conducting this task of moderation. Next. What we have worked in the last couple of years was how to define a regulatory content moderation, the moderation systems, which is the principle is to provide systems that very clearly, rule-based, can convert policies to actionable rules that human or a machine or algorithm can conduct. Next, the system should have the capability of identifying harmful portion of the content and versus blocking the content, removing or obfuscating that portion of the content, so allows the content to distribute in the systems. And last but not least, system has to provide reasoning to user as why, as a transparency and the reason for blocking or obfuscating the contents. Next. So with that in mind, we defined the following research question for ourselves. And one research question was, can we identify a specific area in image using computer vision that we could, by obfuscating that area, we make the image, the unsafe image, turn it to a safe image with a high reliability. And also, the second question, can we use large language models to reduce moderators' exposure to harmful content? This explores large language models to pre-filter or identify the harmful content, and as a result, reducing the cognitive or emotional burden on moderators. In other words, can we build new eyes or algorithmic eyes for the content moderators? So content moderators, without dealing with the content in a high level, could provide questioning and answering to the system, so the system could follow the policy defined by the government's team or oversight team. They could identify the content and minimize the interaction that the content moderators could have with the content. And also, at the end, provide the explanation in case the content is blocked or obfuscated, provide the detailed descriptions to the end user as why the content has been obfuscated and subject to further investigation. Next, please. To tackle the first research question, we propose counterfactual subject explanation. This approach involves adaptive segmentation of sub-object regions within an image, coupled with an informed greedy search algorithm to find a safe counterfactual example. This method allows for precise modification of a specific unsafe area while retaining the overall integrity of the image. The solution to the second question is the conditional visual language models that we design. This model is conditioned on the decision made by the unsafe image classifier. And we use the prompting capability of the model to, based on the identify unsafe images, we use the prompting or in context as a way of forcing the visual language models to explore further in the area of the image that potentially could have unsafe or unharmful or unsafe or harmful areas. So the model could identify those ones based on the policy defined by the oversight team and provide the reasoning, the detailed reasoning that which area or which part of the image that violating the policies defined by the platform. Let's dive into each section. What is counterfactual explainability or explanation? In this slide, I introduced the concept of counterfactual explanation, which are crucial for understanding the interpreting decisions made by the AI system. The counterfactual explanation is slightly different from the correlation systems that we use in today's deep learning models. For example, considering a loan application, a counterfactual explanation might state you were denied a loan because your annual income was low. If your income had been slightly higher, you would have been offered a loan. This type of explanation is powerful because it not only tells users the reason for a decision, but also shows them a roadmap, what they have to do, what action they have to do to change the outcome of the decisions. This transparency is essential for building a trust in AI systems and helping users understand and potentially act on the feedback provided. Next, please. Now I focus on the concept of counterfactual object explanation for image obfuscation. The idea is to partition an image X into non-intersecting sub-object regions, representing as a set of K regions, Z sub 1, Z sub 2, and Z sub K. The challenge here is to identify the minimum number of regions that need to be obfuscated to transform an unsafe image into a safe one while preserving as much as regional information as possible. Imagine an image that may have to go to DOJ, and while the area of unsafe area has to be obfuscated, the goal is to keep the rest of the information, maybe a tattoo or other information, intact in the image. So our goal is to obfuscate the area with the minimality of the area of the obfuscation to make sure we are preserving the originality of the rest of the content. One solution involves using a counterfactual explanation, as I discussed. And in this case, our goal is to identify the regions that they have the highest impact and identify those regions for the counterfactuality. By toggling that areas, we could identify the areas that changing the nature of the classifiers from a unsafe to a safe regions. Next, please. This slide focuses on the method of sub-object region partitioning using adaptive segmentation, knowing that if we build a fixed region area of dividing the partitions, the algorithm may not give to optimality that we required. We are using adaptive segmentation, essentially for identifying and handling unsafe regions in image. The Gaussian mixtures model is particularly well suited for this task because it effectively captures the heterogeneity in pixel distribution across diverse images and coherence of those images, of those pixels. To implement this, we use a normal inverse Wishart distribution for the parameters phi, the probability of the theta sub j, and a Dirichlet distribution for the probability distribution of a lambda sub j. In this context, Z represent the K region segmentation where Z sub I denotes the label assigned to pixel X sub I, and J represent the label of an arbitrary cluster. The Bayesian GMM interface for calculating Z is performed using Gibbs sampling. This process alternates between updating the cluster assignments and the parameter based on the equation shown here. This iteration approach ensures that the region identified are optimally segmented, allows for precise modification of a specific unsafe area while preserving the overall integrity of the image. By leveraging these adaptive segmentation techniques, we can enhance the effectiveness of content moderation systems, ensuring that only the necessary portion of the image are obfuscated and the rest is preserved. Next, please. Here we define a minimum regions to be obfuscated to, we define the region attribution value. As we discussed in counterfactual explanation, toggling the number of small images in the image could be very time consuming because of the 2 power of n region that we could in the image as a result of partitioning. So to obfuscate the preserved safe information, we introduced the concept of the sub-object region attribution score, a critical metric for evaluating the significance of different regions within an image. Using the attribution map of a model fx and the sub-object region, the set of z sub 1, z sub 2 through z sub k, created by adaptive segmentation for the input image x, then we define the sub-object region attribution score, the set of s sub 1, s sub 2 through s sub k. The formula provided on the slide calculates the score. It involves summing the gradient weighted class activation mapping values for each pixel within a sub-region calculated by the Gaussian GMM region, averaged over the number of pixels n and m within the region Z sub k. This score helped to identify which region of the image contribute most to the model's decision, allowing for targeted obfuscation of unsafe area which preserve the integrity of the safe regions. Here's a visual representation or visual example on this slide illustrating the application of this method, showing different region of an image annotated with the respective attributed score. This approach ensures that most critical unsafe regions are modified first or explored first through the tree that we are building, enhancing the overall effectiveness of content moderation efforts versus looking at 2 power of n, flipping the sections or the regions. Next slide, please. Then we introduced the concept of sub-object region confidence reduction, and important metrics for understanding the impact of different regions on the model outputs. Given a model fx that takes an image x with sub-object regions, the set of z sub 1, z sub 2 through z sub k, and outputs a probability distribution y, we define the confidence reduction CR sub k of sub-object region z sub k. The confidence reduction CR sub k measures the change in the model's output when a specific sub-object region z sub k is masked, while the image is still classified as the same class. The metrics helps identify which regions are most critical to the model's decision-making process. For example, if a masking a particular region specifically reduce the model's confidence that region is deemed highly influential. This is a great example. In this example, the corner area of the image, they have low impact in being in the search tree algorithm. Next. Now, by putting all this together, we present a methodology for generating counterfactual explanation using an informed sub-object region search. The approach utilizes a greedy region search method where sub-object region attribution values guide the search space. By leveraging these attribution values, we can definitely have a guided algorithm that efficiently identify the most critical region within an image that needs to be modified to achieve a safe version. Next, please. Here's some of the quantitative results from our work tested on 3 datasets: sexual explicit content, cyberbullying, and self-harms. And our algorithm BAS using the Bayesian, we see in a very fast manner, we could explore the space in a 5.8 average depth of the tree with a counterfactual of 90% identifying the area of the region that by masking it optimally, we could get to an unsafe image. Next, please. This slide also presents the quantitative results of counterfactual sub-object explanation using various attribution methods that we used. We saw the attribution methods that they are more relaxed. They actually provide a better result. And my intuition is because of the greedy algorithm, a little bit of relaxation, while it may add a little bit to the depth of the search, but due to that, the uncertainty injection or relaxation of the problem probably is more complete or semi-complete to find the answers. Next, please. So now that we know how to optimally obfuscate the area, let's go and look at the LLM or visual language, conditional vision language models that we use. Here we introduce the conditional image instruction guided transformer or CIIT, an advanced method for handling unsafe content in images. The diagram outlines the process where a pre-trained large language model is integrated with an image encoder and an instruction guided transformer. The process begins with the input image X, which is analyzed by a policy defined as an unsafe classifier C. So you got class of classifiers or the actions from the classifiers. These classifiers determine whether an image violates platform policy. If the image is deemed unsafe by violating the policy, it is then processed by the CIIT, which receive a specific instructions on what to look for, such as does this image contains potentially offensive cyberbullying content. The CIIT uses the pre-trained image encoder Z to generate a conditional representation of the image. This representation combined with the guidance from the instructions, which conditioned with the policies and the classifiers, allows the transformer to focus on the critical area of generating the answers. This method ensures that content moderation is not only effective, but also efficient, leveraging the power of pre-trained models and a specific instruction to handle complex moderation tasks. The integration of the CIIT with pre-trained models allows for dynamic and policy context-aware moderation, making it a powerful tool for detailed rationale for generating the description without retraining the entire language models as the language models are getting bigger and bigger and bigger. So we find a way how to bring the information or the policies as a prompt in context to the language models. Next, please. Here's the method. We illustrate the integration of conditional vision language model and content obfuscation technique together to handle the unsafe image effectively. In the first phase of the, or on the left-hand side, the system automatically, based on the policies defined by the platform, search for the content and uses those policies and matches with the policies and explore the content in depth as it matches probabilistically with some of the policies. And as a result, it is start doing more query based in the image on the different regions to come up with a very detailed description as depicted on the top of the image. Then as the image identifies as the tagged image, it will go to the second phase, which is the obfuscation, and using the Bayesian adaptive model and the counterfactual explanation that I discussed, will try to identify the areas, the optimal area that if it gets blur, it enables the image to be actually safe. The next step, basically, this is the iterative process that the model goes through the second phase to make sure it gets to the mask image as depicted as an X prime in the bottom of the image. And then we run that image also through the LLM models to make sure LLM models guarantees that this new mask image is not anymore contains, according to the LLM, unsafe content, and they are not violating any of the policies defined by the system. Next, please. Here we represent the effectiveness of our approach on various data sets that I discussed before. The table, and we compare our result with some of the vision language models such as InstructLib, MPLOC, OFA large, evaluating by human evaluators. Our result is extremely above the prediction that they had. Similarly, in this case, we are saying the result for the sexual content with the human evaluation of a 94.5% accuracy, for the cyberbullying 99.5%, and harmful content 99%. This result underscored the effectiveness of integrating policy conditions VLLM with targeted content obfuscation strategy by leveraging the strength of conditional VLLM for precise identification and modification of unsafe regions. This methodology not only improves the accuracy of content moderation, but also enhances the overall user experience by reducing exposure to by reducing the content moderators' exposure to harmful materials. Next, please. At the end, we explored the challenges and innovative solutions for content moderation. We began by understanding the complexity faced by human moderators and the limitation inherent in rights-based manual content moderation processes. We then introduced LLM technologies, including conditional vision language models and sophisticated content obfuscation strategies as regulatory system to enhance the effectiveness and efficiency of content moderation. Thank you.
Thank you, Paul. Is anybody there in the audience who can help field questions? Sorry, you can't see because the camera is sort of looking at the desk.
Yeah, let me, oh, the camera is looking at the desk?
Half desk, and then I see some empty chairs.
Yes, because, oh, tilt the laptop. I see, this way. Oh, I see.
Wonderful. Much better. Thanks. Yeah, May, if you can field it.
Sorry, I don't think there are questions in the audience yet. Are there questions in the Zoom room?
Not that I see. So
Yeah.
just to get things started while people are thinking, Paul, so where do you see sort of the future work going next? What do you think is the most promising direction to sort of increase this work's effectiveness even further?
One of the things that we are spending more and more, time this year, as we all know, the retraining language models as they are getting bigger and bigger, with trillion parameters, it's getting impossible. So our goal is to find out if there is which is a technical and also a community work. Our goal is to see if it's possible. My great example is traffic systems has done this using a regulatory systems. We have very well-defined policies that violating those policies provides tickets, and more, if you look at it now, if you're driving a Tesla, actually Tesla automatically detects if you're violating the driving case. So one of the hope that I have is spending a lot of energy the next couple of years on defining a markup language for, common across multiple platforms for policy definition. And because right now the policy is defined by the lawyers, the action by the technical and the moderators, there is a big disconnect. So is it possible that we define a markup language for automatic definition of translating this to a rule-based execution in the system? Because as long as that disconnection exists, no matter if we use a regulatory systems, such as traffic, we're going to have a lot of headaches. And that requires more than just technical. It requires also a lot of dialogue between. But the good thing is, there are activities in the state of Texas. Actually, there are activities in European unions that more and more people, they are looking at moving from a right-based systems to a more regulatory system, which is these issues has to get resolved.
Yeah, it's fascinating. I've heard people working in formal methods who are trying to sort of do the intersection of formal methods and law to help us understand sort of really in details what regulations mean, particularly as the systems get so and so complex that are sort of enforcing or operating upon them.
Yeah, you're
So
right
really,
on. You're right on.
Yeah, really fascinating stuff. May, turn it back over to you.
Yeah, thank you. Yeah, I think since Professor Porter, you're still going to join us for the panel, right?
They promised me to bring the luggage the early afternoon. What time is the panel?
Panel, I think officially on schedule is 11:20 a.m. and we may run slightly late, but probably not too much. So before
I do my best. Unfortunately, when I was traveling, I came very casual. So I'll do my best, go double check to quickly to see if I haven't checked my cell phone to see if they texted me. Well, actually, it seems they did. So the luggage may be downstairs with the hotel.
It'd be great to have you virtually, if nothing else. And, computer scientists are a very informal community. So you can come in sandals and flip-flops and people would be happy to have you.
Yeah, you actually have nothing to worry about being casual. We are a very casual crowd. Yeah. Yeah, I look forward to seeing you there. I think at this point we probably, time for a break. People need coffee. And I think we come back at 10 minutes later, 10:45. And Sarah is here with us. Sarah. And but I think people will be more energized after coffee. I see people already.
Sorry for the extra headache that I caused for you and Matt, and thanks for all the remote help and guidances.
No, everything worked out fine. Thank you.
Thank you.
Okay, so we'll do a 10-minute break. All right, we are a little over time. The coffee station is really far from our room, so people are not yet back from coffee break. But maybe, Sarah, you can start checking your slide. Oh, people coming back, great. Even with coffee for me, I'm so grateful. Sorry, if you could.
Actually, it's a hike.
No. Oh, I so appreciate that. Thank you. Share your screen and we can see.
Sure. I'm just going to do a funny little trick so that I can keep seeing my notes. So you're probably going to see something. Wait. Where is it? Ah, there it is. Let's see.
Is the volume okay for people in the Zoom room? I'm not having it on. Is it loud
Sarah
enough?
sounds great to me.
Okay, then we'll just keep it like this.
Okay. And can everybody see my screen okay? I've done a little like share a portion of my screen so that I can still see my
Looks
notes.
good.
Yes, it's very interesting art. Can't wait to
Thank
hear
you.
more.
That's going to be a theme throughout the
Yeah.
throughout the presentation. Okay,
Yeah.
so shall I
Matt,
get started?
I think, Matt, do you want to do an introduction?
Yeah, I didn't know. Are we still waiting for people to come back from coffee, or shall we go ahead and get started?
Yeah, let's get started.
Okay. Hi, everyone. It's my great pleasure to have Sarah with us today. I've known Sarah for a number of years, and she's one of my favorite people. You'll see she's a great presenter and a great energy she'll bring to her talk as well as the content. Formerly, Dr. Sarah Gilbert is the research director at Cornell University's Citizens and Technology Lab. She's also co-leading the NSF project on community-centered design of automated content moderation. Her work focuses on understanding and designing healthy online communities. Using collaborative methods, she explores how volunteer moderators' labor impact community governance, factors and interventions that encourage participation and reduce norm-violating behavior, and she studies how online data can be used ethically. Her award-winning research has been published in premier conferences such as ACM CSCW, and journals such as Big Data in Society, Social Media in Society, and New Media in Society. So a quick last comment is, we've been hearing, I think, some bit about paid professional content moderators. Sarah takes a view more looking at volunteer content moderators, and so I think it's really complementary to some of the stuff we've heard about earlier today. Sarah, please take it away.
Thanks, Matt, for the lovely introduction, and thank you both for inviting me here today. I'm really excited to be talking to a whole group of people who do work that's probably a little bit different, but very related to mine. But we all have in common this sort of goal of tackling a lot of tough moderation problems and trying to figure out ways to support moderators who are on the ground doing this work. Like Matt said, my research primarily focuses on people who do this work voluntarily, so community moderators. And despite millions of people taking up moderation tasks across platforms and modalities, not because they get paid, but because they just want to help out, this group is massively underserved in terms of technical support. So I'm going to be talking about some of my research today, which uses primarily qualitative and community engaged methods to talk about how we might support community moderators, the role of AI, and how that fits into the moderation work that they do. So do they even want AI support? Oops, let's see. Come on, advance, there we go. So we're all here for a reason, and I suspect a big one is that we all share is that really moderation actually kind of sucks. There's this, oh, why is it not, hold on, come on, there we go. First, there's this problem of balance that we've talked about. So people get hurt when there's not enough moderation. It turns out that when you let people say whatever they want, they will, and that light doesn't actually provide a disinfectant for things like hate or disinformation or online abuse. But then on the flip side, too much moderation ends up hurting people who are often the least powerful in society. So they're the ones who are subjected to things like bans and removals at the highest rates, even when they aren't actually violating any rules or policies, which then ends up reinforcing existing power structures that we have in society. And so not only is it hard to kind of strike this balance, it's also really hard to strike anything at all. The scale of moderation, again, as we've talked about, is absolutely massive. So like a couple other folks, I was interested in quantifying this scale. So I hunted around for some statistics, and if anybody has not done, or anybody should do a study on transparency reports, they're all really different and sort of hard to parse. But this is what I found. So for each of these platforms, we're looking at hundreds of millions of pieces of content moderated in less than a year, except for a few cases you can see, like Instagram, there's missing data. And of course, this is just what's been actually removed. It doesn't say anything about the extent of policy violating content. So what can we do to make moderation suck less? One option is to change like how we moderate. So for example, beyond just things like bans and removals, a lot of researchers have proposed new moderation models. So for example, moderation that supports proactively addressing issues before they happen, or moderators that support more democratic processes and increase the transparency that comes with moderation. There's also models that focus on repairing harm, that center ethics, and that account for power. Another approach is not just changing how we do moderation, but also changing how we support moderation. So far, most of this work has been on developing tools to support moderators themselves. However, there's also a really cool growing body of work on tools and systems that actually can help users who experience moderation. So we've got alternate models of moderation, and we have tools. Another big hope that I think is probably one that perhaps we all share is that cutting edge technologies can be leveraged to help address this really wicked problem of moderation, that balance and that scale, especially what role automation can play. So for one thing, AI seems really well suited to address this problem of scale. It's very fast, which is important with certain kinds of content that can create a lot of harm when it's out in the world. It can also help with the kind of content that's really upsetting for a human to have to review. So we heard a couple presentations from folks who are working on just that problem. There's also some really big challenges with AI moderation, though. It's pretty well known at this point that AI systems can replicate biases in training data, which mean that biases that exist in society can then be perpetuated through these moderation systems, like the over-censorship of Black women, for example, who are often find themselves subjected to moderation when they stand up against racism, while the people who are making racist comments are allowed to keep making them, or they go unsanctioned. There's also questions that we've brought up already in this presentation or in this conference about how accurate it can be, and what happens when it's not. So for example, nudity detection algorithms that remove rule-abiding content posted by people who are fat or transgender. So one middle ground might actually be to keep humans in the loop, but to support their work through AI when necessary. But in these cases, is AI assistance actually going to help the people on the ground doing moderation work? Or is it one of those things that might kind of sound good on paper, but doesn't actually meet the needs of moderators? So the easiest way to make sure that any AI assistance is actually helpful is to make sure that we understand first, what challenges do moderators actually face, and then ask of which of these are suited to AI support and which things might be better left to humans. We can guess what challenges mods face through outside observations or by doing audits, doing surveys and things, but the easiest and most direct way to know is to actually listen to moderators and also collaborate with them on solution. So for example, things like qualitative interviews, participatory design methods, collaborative research, these are all ways that can help make sure that the needs of moderators are identified, and also that the solutions that we propose will actually be useful, work within their workflow and solve problems that they actually have. So I've been studying community moderation. As I mentioned, people who do this work voluntarily on platforms like Reddit and Discord and Twitch and Facebook groups for about 7 years now. My work has been primarily with Reddit moderators. I started off by doing qualitative interviews, but in this talk, I'll be talking about work from 2 interconnected studies. The first is a collaborative ethnography that I studied, or that I started in 2020 with moderators of a Reddit community called Ask Historians. Hence all the history pictures that I've been showing and that you'll continue to see throughout the presentation. And so in that study, I really wanted to learn about that kind of behind the scenes work of being a moderator, what it was like, what it felt like, what people actually struggled with. So I asked the moderation team if they would add me as a mod so that I could study them. And then in return, I would, help out however I could. I'll also be sharing some new and in progress work from a project with folks at the University of Maryland that uses value-centered design to learn about some of the challenges faced by moderators and to see if there are any natural language programming models that could help support moderation needs, and then explore also, what kinds of tooling might actually help, or if we can leverage large language models or NLP models in any way. So if you're interested in learning more about these two studies, I published the results from the collaborative ethnography at CSCW last fall. And we have the results of the first stage of that values-centered design project up as a preprint on archive. That study was led by our recently graduated University of Maryland PhD student, Trista Cow, who will be joining UT Austin as a postdoc this fall, which is really exciting. So because a lot of this work is coming from and is driven by this collaborative ethnography that I did, one of the more important parts of qualitative research methods that perhaps if you're not super familiar with these kinds of methods, that's really important is being reflexive about your positionality relative to the thing that you're studying, so that people know how that affects your interpretation of the things that you're observing. So there's a lot of things that I could kind of reflect on here, but I think it's really important to note that, over the course of this collaborative ethnography, I kind of transitioned from being a moderation researcher to a researcher moderator, if that makes sense. So once my data collection was done, I actually stayed on the Ask Historians moderation team and continue to actually moderate the community to this day. So just as a heads up, when I talk about Ask Historians, I'll be saying we a lot, and that's why. And it's also really important to note that because of this, it's a topic and a community that I care really, really deeply about. Also, as will become pretty transparent as the presentation goes on, is that moderation involves more than one party. It's not just the moderator, there's also the user who's producing that content. And so my research, really comes from this perspective, the perspective of the moderator, not of the user. And so, there's kind of half of it's kind of missing in that sense. And that's important to know as we are, as you're sort of thinking about sort of the things that I'm talking about. So I'm going to start off by doing a little bit of scene setting in case there's folks in the room who are not super familiar with Reddit as a platform. Because we're about to do a very, very deep dive into the content moderation of one community on one platform. So Reddit is one of the top ranked websites in the United States. It also very recently went public a couple months ago, banking on the profitability of selling its data to train generative AI models. And one of the reasons why its data is so valuable and why it's such a popular site is because, unlike a lot of the big social media sites, the primary connections that you have are actually topics, by subscribing to individual communities called subreddits rather than people. So you're not following individual users, you're following these kind of topic-based communities. Participation on Reddit is largely pseudonymous. Its content is submitted by users, and then the visibility of that content is largely controlled by users as well through Reddit's voting system. And so this influences what content is promoted in various feeds and what content is hidden or demoted. So if something is popular for a lot of people, it gets pushed up and a lot of people will see it. If it's not popular, it gets obfuscated from view. Reddit also has multiple layers of moderation. There's moderation that happens at the platform level. So that is typically paid content moderators, and a lot of it's actually AI. They used to call it the anti-evil operations, but I think they've kind of phased out of that as they've switched more into this AI model, but they're pretty opaque about what that platform-wide moderation is. Then there's moderation through an individual communities. That's all done by volunteers. It's, each community has their own sort of set of volunteers, although lots of people will moderate lots of different communities, whereas some people will just moderate one. It really depends. And then there's also distributed moderation, which happens through that voting system that I mentioned a little bit ago. A bit more important, though, is even though Reddit is synonymous, and even though it's comprised of all these different communities, for many years, Reddit had a rather distinct culture in that its users, oops, okay, there we go, in that its users tended to be fairly young, tended to be male, tended to be highly educated, tended to be white, and or American. So what ends up happening is that through this voting system, that distributed moderation system, the interests and values of this demographic end up getting promoted. And another thing that's important to note is that historically on Reddit, the site really highly valued free speech. So the idea was that users through voting should be the ones who determine what content is seen and what content isn't seen, rather than moderators through removal. So sometimes there's this tension between the work that moderators do and the expectations of the broader community or users of the platform. I would say that this has shifted somewhat since around 2020, 2021. But when I first started collecting data, this was very much still the case. Okay, so we have this kind of homogeneous community that expects certain things. Enter Ask Historians. This is a subreddit that operates a little bit differently. It's a community where people can ask questions about history with the intent of getting academically informed answers. It's founded in 2011 and currently has just over 2 million subscribers. It's also run by 45 human moderators, although not all of them are active. And we also have some bot support. Ask Historians users, like the rest of Reddit, also tend to be pretty young, pretty white, pretty male, pretty American. The results up on the slide here are the most recent census, although it's pretty out of date. I believe that's at least 5 years old now. We haven't done a new one since then. But I mentioned that Ask Historians is different, and that's because it has this very particular mission, and that's public history. So its primary goal is to make sure that people are getting high quality, accurate answers to their questions about history. So in order to realize its goals, it does a couple of interesting things. First, it's got this panel of experts known as flares. And so Flare is something that's available across Reddit. It's a little design feature that supports adding a little bit of extra information next to somebody's username, so you can see what that looks like up on the slide. On Ask Historians, it's used to denote somebody's area of historical expertise. And so this is something that's earned through participation in the community and then applied for. So you can't just give yourself Flare and denote yourself as an expert. You have to show that you know what you're talking about before you will be awarded that Flare. And so these flares are not moderators, but the new moderators are recruited from this Flare community, so that moderators in Ask Historians tend to be experts in history. The other thing about Ask Historians that sets it apart from the rest of Reddit is its rules. So in order to ensure that the answers to questions are informed by current historical practices, moderators have created this really extensive set of rules and actively enforce them. So this is a summarization of the rules up on the slide here, but each one is accompanied by an extensive description, what it all means, and also the rationale, so why we have each of these rules. And so the creation of really specific rules and their active enforcement, as I mentioned, makes Reddit different from the majority of communities on Reddit, who tend to, rely on that kind of upvoting model to really do a lot of the determination about the kind of content that people have seen. This quote from a former moderator named Commustar, I think, does a really nice job of explaining the moderation model used by Ask Historians. And he says, now, a major part of that effort has been to delete comments that are low effort or speculative or promote pseudo-history or bigotry. The Ask Historians moderation team sees the deletion of such bad comments as curating the sub akin to pulling out weeds so flowers can grow. And so, as I mentioned, the main way that this is done is through removals. So all short, pithy, wrong answers, these are removed to create space and allow the time that's needed to compose something that's well-researched and in-depth and comprehensive. It's also really important to the Ask Historians community to remove any kind of hateful content. And this is to create a safe space for people who are often subjected to hateful content. So I'm going to demonstrate this by showing a couple of examples to illustrate why these kinds of removals are so important to that public history mission, and why it's sometimes, probably seems maybe a little bit easier on the surface than it actually is in practice. So as a heads up, the examples that I'm going to show deal with anti-Semitism and colonialist racism. So one of the more common, probably one of the most common forms of identity-based hate that we see on Ask Historians is probably pretty predictably Holocaust denial, given the topic of the community and just its prevalence out there in general. So early on in the subreddit's history, it developed a pretty straightforward way to manage it. Just don't platform it. And there's a reason for this, which comes from historians' studies of Holocaust denial and the motivations for it. So a number of years ago, one of the moderators actually on the team wrote about the community's approach to Holocaust denial in the Slate article here. And so, oops, go back, there we go, sorry. And so, I mentioned that the mission of the subreddit is public history. So, teaching people. And so while it would probably make sense kind of on the outside to think that the best way to counter denialism is with education, because Holocaust denial isn't actually rooted in any kinds of like facts or real information, it's rooted in hate. So it operates a little bit differently. Any kind of information that you throw at people or the ways that you kind of try to teach people, they're not going to work. It's not going to help people change their mind or help them learn. And so, countering it in this way doesn't actually make a whole lot of sense. The other thing that's really challenging is that it's way easier and way faster just to lie and make things up than it is to call things into question or refute those things, even when you're kind of prepared for this. So if you are curious about what this kind of labor looks like or what it actually looks like to engage a Holocaust denier and to see what the futility is, I've got a QR code linked to a specific thread here. You don't have to link to it now or like check it out now, but it's really interesting because you can see like in the thread like how these expert moderators are putting out all of this information, and then the Holocaust denier is just they're not really engaging with it. They're just asking questions, trying to sow doubt, and like you can see that it doesn't actually get anywhere. So that's why that just don't platform it rule is really in place. But if facts don't matter to deniers, why would they bother posting here at all? And that's because they want their hate platformed. They're banking on this kind of inequitable labor to be able to sow doubt, that they can actually kind of really quickly throw a lot of bullshit out there, which, when it looks undisputed, while experts kind of scramble to refute it. So they're hoping that people will see it in the meantime, see it undisputed, and will kind of grab onto it. Okay, so the policy situation is pretty straightforward. There's this really, compelling rationale for that that's grounded in, research, history, like literally like historical studies. So, it should be pretty easy. Just get rid of all the Holocaust denial. In practice, it's a little bit challenging sometimes. This is an example of a really obvious removal that we got on the website. The title is literally referring to the Holocaust as propaganda, calls it fake in the first line. Then there's like a whole bunch of really common denialist talking points peppered in with some really extreme anti-Semitism. This is a really easy, quick removal. The next one is a little bit tougher. This is a little bit kind of question. Is this somebody who's just asking a question? Or somebody who's just asking a question, or jacking off, which is the term that the moderators use for when people are using question asking as a form of plausible deniability when spreading hate. So this one might be somebody asking in good faith. They've seen something on the news, perhaps about cremation, and it sparked, like a logical question or a logistical question about the Holocaust. Setting aside the point that there's that cremations are pretty common, very common denialist talking point, there's another clue that this is in fact Holocaust denial, which is in the username here. So the term Jannies is a derogatory term for moderators that's common on extremist platforms. and forums like 4chan and the .win communities, 8chan, all those kinds of spaces. So here you can kind of, use these sorts of contextual clues about the user to try to figure out what the intent is and help that make your, your decision about sort of, what to do. So in this case, it was removed because it's denied. The next one is a little bit harder. This one is an example that requires actual expertise. This echoes a lesser known denialist talking point, or sort of point that denialists try to make when they seek to humanize or minimize or downplay the responsibility of Nazis for the Holocaust itself. And so an interesting thing about this example is that you can see on the slide, I don't know if you can actually see my cursor here, but the number on the side in the pink there that says 130. So what actually happened here, that's the number of upvotes. At the time, we were participating in a program on Reddit where Reddit staff would work with mods to better understand what it's like to moderate. So they would kind of come on and do like a 2-week-long sort of stint with moderators of various communities, and we were participating in that program. And so this was a Reddit administrator who's more of a tech person rather than an historian. And he actually didn't catch this issue. He just saw the question, thought it was legit, and approved it. Later on, a moderator with experience in the Holocaust saw that this question was trending and immediately removed it. And so what was actually happening here is that because it was so hard to recognize, a lot of upvoters didn't really see it either. And so it was kind of promoting this more subtle form of denialism while it took an expert time to actually see it and catch it and remove it. And so this seems like kind of like an education issue, right? Like if you just provide people with the information that they need in order to moderate Holocaust denial as one example, then this problem will be solved, and we will have we will be able to successfully get rid of all of the Holocaust denial and ask historians. And it largely is. I'm not an historian. I'm pretty good at spotting Holocaust denial now. And when I'm not sure, I'm really lucky that I have this moderation community that's full of experts that I can ask. But sometimes we see questions that promote identity-based harms that we don't have a good solution for. So we struggle with what to do with questions like these that we get almost every day. So if it's not obvious, these kinds of questions are really harmful because they promote stereotypes that are used to justify racism and discrimination that aren't true and that reflect common assumptions about what it means to be, developed or versus, undeveloped. And so this is really damaging to both African and indigenous community members and also moderators, because they're seeing this over and over and over again. And like, it's just, kind of, it's not like, it's like just like kind of being exposed to this kind of thing. We talked about in one of the earliest, one of the earlier presentations talked about this kind of thing exactly, where it's not that like super extreme content that's hard to deal with. It's stuff like this, particularly for the people who about whom these assumptions and stereotypes are made. And then because of Reddit's default white male US demographic, we don't end up getting a lot of questions asking about African history. And then when we do, and the question looks like this, it makes it really demotivating for people to want to actually, kind of stick around and participate and answer these kinds of questions. So the easy answer is just to deplatform these too. But the problem is that it's different, right? Like unlike Holocaust denial, these questions are not trying to push an agenda. They're born from, kind of a shitty educational system. So to keep it that public history mandate, we end up leaving questions like these up. Although, we do have a lot of really good answers to them because they do get asked a lot. So we do have tools that we can use to push back against these kind of assumptions, but it still doesn't feel great to have to platform this kind of thing. And like I mentioned, for people who are affected by it, to have to see it over and over and over again and upvoted and promoted over and over and over again. So I shared these examples in particular because they illustrate a couple of points I want you to take away. First is that moderation requires human expertise. That last example of Holocaust denial that I'd never seen before. I haven't seen it look like that exactly ever again. because it's that uncommon, but it's really apparent to an expert who saw it right away in ways that like I, a non-expert, wouldn't necessarily predict. The other thing is that, that's pretty apparent is that context is really important, not only just, between different communities, but also within them as well. Even when they have these really clearly articulate goals and a pretty narrow topic area, we have two examples of what are both bigotry and discrimination, but they can't be promoted the same way. And they have very different effects on the moderators and the audience members who are confronted with them. So I started off by showing you a couple of examples, but I'm going to switch gears now and tell a story. And I'm going to tell this as a story because it's part of moderation that in all of the interviews that I've done with community moderators over the years, I've rarely gotten anyone to talk to me about this kind of thing. And that's what it's like to actually work with a group of people to make tough decisions and how fraught this work can actually be. Not all decision making is hard. Like some of it's, pretty clear cut. But decisions about like on Ask Historians, the answers that people give to questions and about what makes them, in-depth, comprehensive, informed by historical practices. The ones that are kind of on the borderline of acceptability to our rules, these ones can be really, really tough to evaluate, sort of like grading kind of like an almost good enough paper. Like, does it pass or does it not? So in the first few months of moderating, there'd been a few, relatively minor disagreements, but they always seem to be resolved, relatively amicably. And so this is a bit of a story. I'm going to just put up, there's not a whole lot of visualization, but I've got to have the details up on the slide here to sort of help ground it. So it all started when a moderator that I'm calling Becca dropped a link into Slack. And so the moderators use Slack to discuss moderation, decisions and things, that they're not sure of or they have questions. And she asked, if we had a macro which expresses, this answer is wrong. And so macros are these sort of pre-written statements that any Ask Historians moderator can select from to respond to a user whose comment is going to be removed. And it provides a little kind of a broad, very generalized explanation of what the issue is, but it's something that we can deploy like quickly and easily. So the question was about early university life at a particular university, which time period wise happened to fall within Becca's area of expertise. But since there wasn't information about the earliest days of that particular university, the answer that she had brought in to Slack that she thought was wrong provided information about that particular university life at the university at a later date. So there are a few things about this interaction or engagement that struck me as a bit odd, even as like a brand new moderator at the time. First is that Becca was highly experienced and highly active, so it was very strange that she would ask a question about these macros. Then there was the fact that the question was written by one of those expert flares that I mentioned earlier, who I'm calling Flare 1. And so using one of these public macros with a really generalized feedback is not something that we would normally do when we're removing an answer provided by one of these flares. So what we would normally do is send a detailed private message to that user explaining what the issue was and how to fix it, because we've determined that this is a way to maintain a good relationship with these flares who, we're invested in keeping around so that they can continue to provide answers in the community. So another moderator asked if we could do the regular thing, send a private message with a feedback, but Becca declined, saying that the topic was in her area of expertise. She knew it was bad. There was plenty of information about university life when that university was founded, even though there wasn't information about that particular university. However, for a number of conflict of interest reasons, she said she couldn't write an answer to the flare. There was a lot of back and forth after this. Becca's explanation for why the answer wasn't acceptable didn't really make sense to anybody. But since Becca was the expert, the team ended up going with her opinion. So the answer was removed, and one of the mods ended up writing a private message to the flare. So everything might have been fine, except a second flared user, Flare 2, creatively named, came along and answered the question in almost the exact same way as Flare 1. So talking about the earliest days of this particular university. And so this was initially removed, but then Flare 1 ended up responding to that private message, explaining why they had answered the way that they did. And it actually seemed like a really reasonable explanation. So after some more discussion, it was determined that both answers should be reinstated and reapproved. Becca wasn't there for that conversation. And when she ended up coming back later on and saw that her decision had been revoked, she wasn't happy at all. In fact, she was incredibly hurt that her expertise had been ignored. The problem was, though, that no one really understood what the issue was. Although some people argued that they didn't have to because they trusted Becca's expertise, they also weren't the ones who had to communicate the issue to this Flare. So the question seemed to die down at the time, but the next day, Becca brought it up again, wanting Flare 1's answer removed, wanting somebody else to write the message because of that aforementioned conflict of interest. But the problem was nobody knew what the issue was still. So at this point, the argument started getting really, really heated as the moderation team tried to understand what this issue was, and Becca desperately trying to explain. You know, I remember just kind of like staring at my computer screen as like the Slack was just moving super quickly, like basically like watching TV, you know, horrified, because at the time I didn't really understand why this was a big deal at all. You know, just let it stay up. Particularly because there wasn't the same kind of conversation about Flare 2's answer, and they seemed very similar to me. Finally, in a moment of frustration, Becca just told everyone, you know, just do what they wanted. She didn't care anymore. And then Molly, another Flare, calls out for her to wait, you know, explain that her motivation for not just taking Becca's word, you know, saying, you know, I want to be as supportive and as helpful when I try to tell people their answer was removed. For ethical reasons, I want to be good to people, and logistical ones. You know, Flare's melting down about how mean we are is a nightmare, which does mean I tend to err on the side of saying the post is fixable. And so this explanation for why it was important for the team to understand the issue seemed to finally kind of resonate with Becca. And she once again went through this list of issues with the answer, although this time a lot more comprehensively. When asked why she didn't share these details before, she admitted that she hadn't actually read the entire answer, because she knew it was wrong right from the start and didn't need to. This explanation was then used by one of the other moderators who wrote a response to Flare 1, whose answer was removed yet again. Oops. So this was Flare 1's response to that second removal, when they said, it's insulting that an answer that I worked hard on and which has been received positively by both readers and other Flares has been removed, reinstated, and removed again based on decisions that I am not allowed to participate in and where I don't have any input. I've been finding this community a very positive experience, but I'm now finding it very negative and anxiety inducing. And so I hadn't participated at this point in any of the discussions about the answer. Even as I mentioned, after Becca explained a lot of these issues, I still didn't really get it. So then reading this, you know, my heart just kind of sank to my feet. You know, the Flare was right and we were wrong. You know, they had worked hard on it. It was well received. And we did center Becca and her opinion and her expertise over the Flare's expertise when making this decision. And we never ended up making it better. That answer is still removed. And this whole fight took place over 2 days and ended up resurfacing again a week later. I'll spare you those details, but it involved another 2 moderators ending up having to talk Becca down again because she was so hurt by having her expertise undermined by the team. And then even again after that, you know, nothing was resolved. So I could have told you a lot of different stories about moderating Ask Historians, but I wanted to share this one, not only to kind of show you how the sausage is made and how kind of ugly it can get, but also because I think it highlights a couple of things. First is that having the team to collaborate with, you know, ultimately really improves this decision-making process, because not everybody is an expert in everything. You know, without collaboration, we would have missed that Holocaust denial that I showed you earlier. You know, so having a group of diverse moderators with diverse expertise is essential for successfully judging, you know, a wide array of content, even within a pretty limited subject area. But it can also get in the way, like as we saw in this story. There are these soft power relationships, you know, between the moderation team that can be really challenging to navigate. You know, nobody wanted to hurt Becca's feelings. And then we also have these hard power differences between moderators and between users that is just way easier to kind of use and exploit, especially when you're centering these kinds of soft power dynamics. It becomes really easy to just remove something. And so that brings me to the second point, is that when we talk about content moderation, it's so easy to forget where that content comes from, and how moderating that content affects people. And anything that we do to support moderators also, has to be mindful of the users who are on the other end of that content removal. Okay, so working with moderators through this collaborative ethnography, it becomes a lot more apparent about what kinds of support systems they might need. So systems that can support moderators making really tough decisions. Systems that treat humans, that treat content as humans rather than data. Systems that keep humans in the loop to take advantage of their expertise, and accounting for context even within communities. So I'm going to hone in on that first point. Is it possible to account for context with existing AI models or machine learning models? And so that was a question that my collaborators and I asked at the University of Maryland. So we decided to start off by looking at this through a review of existing NLP models on Hugging Face, because we wanted to see if that support was already out there. So we conducted this sort of like you would conduct a literature review. So first we selected 3 representative Reddit communities that had a range of rule types, and then tried to match those rules with the existing NLP content moderations models that were up on Hugging Face. Oops, I skipped ahead without looking at my notes. So first we looked at the description of each of the rules to see if they could address through rule-based solutions. So for example, rules like, no reposts might not necessarily need kind of sophisticated AI support. It could be easily automatable without that. We then looked to see if the rule could be addressed by a toxicity detector. And then from the remaining rules, we looked for keyword matches between the rules and some of the available models on Hugging Face. So looking at the search results, the most relative model, and this is what we found. Just in summarization, most of the rules could not be addressed through rule-based approaches. So they're a little bit more complex than what can be addressed through, really simple automation, which currently is what moderators only really have access to, at least on Reddit. There's not a lot of AI support in the tooling that is available to Reddit moderators. Most of the rules were also not necessarily already covered by toxicity detectors. And even when they did match kind of well enough, there'd be some changes that would need to be made. So for example, swearing was allowed in a lot of these communities, but you might have to adjust the toxicity detector to make sure that, it wouldn't just remove all of the swearing automatically or detect swearing. And then among the rules that don't apply to toxicity detection, only a few of these had matches. And then while most could be addressed with some changes, there was also a sizable portion that weren't addressed at all. So even though I would say a lot of the rules had some kind of support through existing automated models, but there were some that didn't have anything at all. So our next question was, well, maybe this isn't that big of a deal. At the time, OpenAI had recently started advertising itself for use in moderation. So we thought that maybe we don't actually need a specific model, because large language models might actually be good enough at detecting rule violations. So we decided to check to see if various of a couple of different large language models could be used to detect violations and ask historians rules specifically. So I created a data set that was used for the evaluation. And so this was really important to create a data set with people that actually know how the rules are enacted, so that you could have the sort of ground truth model that actually works with the rules themselves, and somebody with the expertise to be able to recognize when rules are being violated. So I went through all of Ask Historians rules to develop this, found 10 to 13 examples of clear and relevant rule violations for that particular rule, and then found a couple of examples of sort of borderline or non-violating content as well. We then use that data set to test the rules for precision and recall in Llama 2 and ChatGPT 4, using recommendations for building a good prompt. So for example, using the rule descriptions in the prompt itself, giving the AI like a role or a task, and then used whichever tactic had been found to be most successful for each of the two models. So few shot for Llama 2 and 0 shot for ChatGPT 4. And then after that, once we knew the precision and recall scores for each, we did a moderator evaluation. So we wanted to know if the large language model would be helpful given its performance, and also what kind of performance, what would be actually needed in order to be helpful. So these are the results. I'm sorry, this is so small. I've got the QR code for the paper back up there on the slide. So you can actually see which each of these rules are if you want to take a look. So the results are pretty mixed. Some of the rules have high precision and high recall for both. Some of them have either high precision or high recall, and some of the rules have neither. And neither of the two models really stood out as like clearly superior to the others. Like each one had kind of its strengths and its weaknesses. We also found in doing this moderator evaluation that moderators had really different perceptions about what was acceptable and what wasn't. And so we ended up deciding to use to like this categorization. So you can see there's the 2 different, like, or the 4 different colors on the slides here. So the blue is acceptable for precision, and yellow is acceptable for recall. And then not acceptable are those different shades of gray down there. So we ended up using majority rule in order to sort of classify one into one example or the other, which sort of mimics what we end up doing on the subreddit. In order to somebody makes a decision that somebody disagrees with, we will use majority rule in that case. So that's why we decided to go with that there, because there was quite a bit of variation again in what individual moderators would prefer. So again, this is not necessarily as clear cut, I think, as it might seem. Although in most cases, moderators would consider models with more than 70% precision and recall to be broadly useful. Among the 23 rules, both models were considered useful for 3 of the question rules and 3 of the comment rules. There are 6 rules, so about a quarter, for which neither model was considered useful, emphasizing that while current large language models provide possibilities for supporting moderation work, further improvement is needed to support like sort of broadly applicable rules. So they are moderation tools. So they might work for some rules, some tasks, but not others. Do mods actually want any of this though? We asked them to share their thoughts in some open-ended questions at the end of the survey, which provided us with some really helpful insights. So for example, this participant said, a tool that flags a lot of things but isn't right too often, well, it's still flagging things for my attention. A tool that doesn't flag a lot but is still frequently right, great. I don't have to think about whether or not to remove what's found. And so, this indicates, broad support, but like reading a little bit deeper into it, we can see how important model transparency was. So we can, echoing the last presentation, that if moderators are able to know what the limitations are and also what the strengths are, that can help them make decisions, about whether or not, they want to go along with what the model says, or whether they want to, just kind of ignore it. We also heard from another participant who said that a tool would be useful for assessing and filtering breaches of more complex rules like plagiarism, especially ChatGPT use. That's actually something that we've been getting a lot on the subreddit more frequently. It violates the plagiarism rule if they try to pass themselves off as like if somebody just posts like a ChatGPT generated answer. If you say that you're using ChatGPT, we'll just remove it. But if you're plagiarizing, trying to pass it off as your own, that's considered plagiarism, which is results in a ban. So poor sourcing, but even given the time it needs to assess those, claims that it would need to be correct the overwhelming majority of times, it flags something. So for simpler rules like clutter, depth, or no jokes, then I would like to see a tool which is able to flag the majority of comments that blame the rule or that break the rules. So the utility of the performance is going to also vary by rule. Like it really depends on what the rule is, depending on how the sort of it's going to matter how precise or the recall, and that's going to vary depending, even within these specific rules. So while the mods are generally fairly enthusiastic and flexible about having this AI supported help, even if it's imperfect, it's going to be really rule dependent and also require a lot of transparency. And so without taking those factors into consideration, anything that we try to build is just not going to be that helpful, even if the precision and recall seem fairly promising at the outset. And so just to sort of finish off, I know we zoomed way in there. And sometimes I think when we zoom so far into something, it can be hard to sort of see or feel the applicability to sort of these bigger, broader, big moderation challenges that I talked about at the beginning. But, even though this is just, for one community, one platform, working in one modality, I think this is really offers up a lot of really exciting opportunities for the future. Even if it is, one place, one platform, mostly text, it's still so deeply contextual and so complicated. There's a lot to learn and a lot of work to be done if we're going to be scaling this up. And so collaborating with moderators to really understand what they do and what they need, we can kind of figure out what these opportunities are to help. And what kinds of innovative tools and systems we can design that really get at what moderators need so that the public can freely and safely participate in online spaces. And I think that's it.
Thank you so much. And I think we should get, there are questions in the audience, or should we already get started with the panel? Matt and Arkis and Martin.
I'll defer first if there are questions anyone wants to ask of our amazing speaker. By the way, here's the applaud beyond the animation applaud. So.
Yeah, animation applause. Are there questions from the audience? I think, from the room, probably we're ready to move to the panel. Okay, maybe we can just flow right in. Do we have everyone here for the panel that we were expecting? Yeah, we have Xiang and Professor Porat. Since the camera is looking toward this toward the room, maybe we can have the panel sit there.
Great.
Or it's easier this way. Either way.
It's a good idea. So they sit like over here. Maybe you can.
Is that Paul? I see who's moving maybe to the front row.
Yes, and another chair here.
Great. Martin, do you want to get us started? Because I think you have the Google Doc for things today.
Yeah, that sounds good. Thanks so much for being here, everyone. And thanks for giving me and Maria the opportunity to moderate this panel, or this first panel of the day. And Sarah, I'm really glad I caught the latter part of your talk. This was really interesting. And I was looking up at your paper with the UMD folks. It looks really cool. Already sent it to a couple people. So so our first question that we wanted to kind of get a sense of, and so maybe feel free to like raise your hand if you're on Zoom, and then raise your hand in person, or Maria, you can help sort of moderate the in-person, like people who want to ask questions. But kind of related to some of the challenges, Sarah, that you were discussing in your work, how do you kind of balance this distinction between like, oh, sorry, go ahead.
Can you hear me?
Yeah.
Great. Maybe before we just do a quick round of introductions for our.
Oh, yeah. So sorry. Go ahead. Yeah.
Okay. So actually, I think we are all seated this way. Maybe you will just introduce yourself. So.
Sure. Good afternoon, everyone. I'm Payman Najafi Rad. I go by Paul Rad for simplicity. I'm an associate professor at the University of Texas, San Antonio. My focus is around, my area of research is around cybersecurity, safety, and AI. I've been working on my content moderation for the past 2 years.
with several agencies and companies. Thanks.
Okay, thanks. Hi everyone, my name is Xiang Hao. I'm a principal appliance scientist at Amazon. I joined Amazon for 10 years. In the last five years, I've been working on, understand what happens in reviews for content moderation use case, like for other, video assistant use case, etc. Essentially try to make sure, let's say, Prime Video at Amazon have the right maturity rating and the compliance requirement in different territories. Prior to joining Amazon, like I worked on medical image processing. I just studied how to use like MR, DPI image to help diagnose this disease. That's for me. Thanks.
So our panelists over there on Zoom. Would you like to?
Yeah, Maria, maybe you can just call on people so they go.
Yeah. Sarah, well, we just heard Sarah, so probably we don't need an introduction for Sarah. And I guess we also heard some talk before. And well, do we have?
Well, just I guess quickly, I guess we have on the moderators. So Matt Lease, University of Texas at Austin, one of the workshop co-organizers here with Martin. Martin, do you want to say anything?
Yeah, hi, I'm Martin Sapp. I should have introduced myself. I was just too excited to start the questions. I am a assistant professor at Carnegie Mellon University in the Language Technologies Institute, and I've done a bunch of work on content moderation, but mostly with text. So I'm really excited to hear about sort of the multimodal perspectives, but also some of the sort of more human-centered perspectives of things.
Okay, wonderful. Maybe Martin, get us started.
Yeah, cool. Okay, so go back to what I was saying earlier. So I'm really interested in this question of like how to balance kind of the needs of the users in the community that might be sort of in need of moderation versus kind of like top-down needs or rules that come from, for example, company policies or sort of subreddit policies or things like that. And specifically how we can respect kind of the cultural and societal contexts of the users and maybe the communities to ensure that diverse perspectives and norms are upheld. So if anyone has any thoughts on this.
Sean.
Yeah, I can start. I think there's like for the first point about the balance between top down and bottom up. Like first, I think we make sure, let's say, the decision making consider all different diverse thoughts and very inclusive about different opinions. Especially, I think creating the feedback from different thoughts very critical. Like if you just like the different if you only consider like thoughts from let's say one thought either top down bottom up, it's hard to have a balanced view.
The conference room. All right, let's get started. Thank you, Mike, for graciously agreeing to speak here. And yeah, Martin, do you want to kind of introduce? Let's get started.
Yeah. So thanks everyone for being here after lunch. Hopefully lunch was good. It's really my pleasure to introduce Mike Pappas, our first speaker of this afternoon session. He is the CEO and founder of Modulate, which is a company that tries to improve kind of the environments of gaming where people talk in sort of voice chat and trying to moderate kind of these voice chats. And recently, Mike has been thinking a lot about trust and safety from a legal perspective. Yeah, I was really interested in what he had to say last year in October when I saw him speak at a panel at the Eradicate Hate Summit, which is potentially of interest to some of y'all in the audience, given that you're interested in content moderation. And today he's going to talk about sort of the specific challenges related to moderating voice chats in games, because that's really hard because you have to act very quickly and there's specific challenges that go with audio. So yeah, take it away, Mike.
Thanks so much, Martin. I'm excited to be here chatting with y'all. I will say no pressure to anyone who doesn't feel comfortable, but I love being able to see people's faces when I'm talking and get as much feedback as I can. So anyone who's calling in remotely, please don't be shy if you want to turn camera on. But again, understand that not everyone feels up for it. Cool. So thanks again, Martin, for the intro. As you mentioned, I'm Mike Pappas, the CEO at Modulate. As again, Martin mentioned, Modulate does primarily voice moderation for online games. So we're working with Call of Duty, Grand Theft Auto Online, Riot Games, a number of others. And we help them identify everything from hate speech and harassment up to some of the most insidious harms that can happen on these platforms, things like child grooming, violent radicalization, all of that. So I'm here to talk to you all today about ephemeral chat moderation and especially voice. And to start off, I want to talk about sort of this landscape of content moderation and why I think it's worth talking about these differences. So I sort of see this very simple sort of 2x2 matrix of types of moderation. And I know that I'm leaving out tons of stuff here. There's no images, there's no video, there's all kinds of different detail. But just in terms of direct sort of conversational content, you typically see communications happening in either text or voice form. And you see on different platforms what I call sort of semi-permanent versus ephemeral versions of this chat. So semi-permanent is when you're posting something and it sticks around for a fairly long amount of time in a public or mostly public setting where there's a possibility for many, many people to see it. Examples here are Facebook, Twitter, sort of the conventional social media application. You can also think of things like message boards fitting into this category. There's also semi-permanent voice equivalents, especially in the streaming world. So you see something like Twitch or Spotify have sort of similar situations where if you upload a podcast to Spotify, you might have millions of people consuming it over a long period of time. There's an opportunity for lots of people to encounter it and have their own opinions about what's going on. Contrast this with ephemeral applications, where the point is that the communication is there only for a short period of time and is only seen by a very small number of people. In text chat, you might see this in things like SMS and certain in-app chats, especially the sort that do, disappearing text as you see nowadays in some encrypted applications. But in voice, frankly, this is the norm. Call of Duty, Zoom, whatever else. I know in some situations you might record things as we're doing with this webinar. But in general, the assumption is that most voice conversations aren't recorded. And there's a variety of reasons for that. Recording voice is very expensive, it's very complicated, and most of the time people lack the tools to even understand it anyways, so there's not a lot of value in storing it. But because of this, there's become a very strong assumption that when you're having a voice chat, it is entirely private. It is something that no one has seen. And as a consequence of that, we've seen in the games industry that even as text moderation tools became more and more prevalent and did their best to sort of stem the tide of toxicity in games and of course other applications as well, voice didn't really change too much. And anyone who's played online games in the last ever has probably experienced some of the toxicity that you might encounter in those voice chat ecosystems. And we hear from a huge number of people that they just don't feel safe. They don't feel excited to participate in voice chat because they know that they're going to be terrorized. So that's the problem that we wanted to stop. I have found in general, when talking to people about content moderation, most people's intuitions come from that upper left quadrant of the sort of billboard applications. Those intuitions include things like you are moderating content. Content moderation seems to imply that kind of comes from this assumption of it's posts, it's the content that you're generating, that's what's being moderated. When we get to something like voice chat, it's not just the content of what you're saying. There's other dynamics in play that word doesn't capture quite as crisply. Other intuitions that I see frequently come up are things like harm being done being tied to the number of people that see the post. If someone posts a really racist tweet and millions of people see it and are hurt by it, as opposed to someone with 3 followers posting the same tweet that almost no one ever sees. Most people would have an intuition the first one was worse, the first one was more damaging. And so generally, when we're thinking about content moderation with this sort of billboard intuition, we're thinking about content that is seen by tons of people. This also ties into how research is done, right? Research into content moderation assumes semi-permanent contents, because if you're a researcher going on to, say, Twitter and looking at, hey, how were these different tweets engaged with what's going on here, you need to be able to find them. If you're a researcher who wants to know, hey, what happens with voice chat in Call of Duty when something toxic happens, there's no real way to survey that. Your only option is to just be a player of Call of Duty and very slowly accumulate sort of real play hours to get that intuition. So as a result of that, we tend to see a lot of the research that gets published, certainly not all of it, but much of it tends to sort of stick to this billboard kind of assumption of how content gets produced. There's other assumptions that get baked into here as well, such as, the experience of text being very cheap to moderate, and how that leads to differences in the key metrics that we're thinking about when we're trying to decide if moderation has been done successfully or not, and even the kinds of harms that we're focused on. When you're talking about a billboard application, you're very worried about misinformation. You're very worried about large network effect harms like cancellation. You're probably a little less worried about quote unquote simple hate speech. That's not to say you're not worried at all. You might recognize it can do damage. But in a certain real sense, hate speech just doesn't hit as hard item by item on something like a billboard application. In a certain sense, because everyone knows that everyone's constantly posting racist things on Twitter, it's a little less offensive when you see one more racist thing. But as we'll talk about, in some of these more chat-based applications where you're building a really personal relationship with someone that you've come to trust, suddenly starting to say something very racist or starting to say something very hateful, that can hit in a very different way and cause a really disproportionate amount of harm compared to just seeing those same words written in text. So what I'd like to do here is walk through these sort of 4 major bullet points and talk about how things look different in the ephemeral world of voice chat and some of the lessons that we can take from that to think about moderating these ephemeral spaces more effectively. So let's start with this idea of moderating posts in the billboard world. In voice chats, you're instead forced to think about the audio that people are uploading. If you're breaking that up into little snippets, then you're thinking of that in terms of clips, but really you're thinking about the conversations that people are participating in, which is fundamentally a very interactive experience, right? The dynamics of a conversation rely on each of us having this sort of engagement with each other. It's part of why I suggested folks could come off camera if they wanted to, because being able to see different folks and interact with them, you get more feedback from them. You get the ability to build a deeper relationship with people than if you're just exchanging text chat and can't see those same sort of emotional cues. Audio is also fundamentally different because it's mixed. So if all of you started speaking at the same time, none of us would be able to tell what anyone else was saying, because we would all just hear a jumble of lots of people talking. But if instead all of you started typing in text chat at the same time, we would be able to read each person's post individually. In text, the posts don't get mixed. Right? Your post is there in a clear, obvious way. It would be completely ridiculous to mix your letters with the letters of someone else just because you were typing at the same time. But that's effectively what does happen in the voice ecosystem. It all gets mixed together, and that creates opportunities for new kinds of harms. One of the categories of harms that Modulate thinks about is what we call audio assault. And that's basically when someone decides to dominate the voice chat channel in a way that no one else can get a word in edgewise. You might do that in a variety of ways. You could do it by shouting. You could do it with a soundboard and just, if you're 5 years old, playing the fart sound over and over again so no one else can say anything. You can do it by playing a bunch of loud, raucous music. You can even do it by accident, by having a really bad headset that keeps making horrible static noises that no one can deal with. But one way or another, if you're doing those things, you're not just creating an unpleasant experience for people. You're actually making it impossible for anyone else to use that communication channel. And that's something that you can't really have an analog of in the text world. So this is a graphic that we use when talking about TalkSmod internally to just highlight the different dimensions of what you can see in voice. Of course, again, there is the content, there is the actual text of what's being said, but there's so many other elements as well. So prosody analysis. Prosody is the catch-all for everything from emotion to cadence and basically the performance of the speech. I'll give an example in a moment of how prosody can really transform a particular set of words. But some of you have surely had this experience as well. If you're texting with someone and they send you an SMS message, you might look at it and say, I can't really tell if they're being sarcastic or if they're being passive aggressive. I'm not really sure what's coming through here. But then you hear that prosody and it becomes very obvious what the intended meaning was when someone is speaking that. So there's a huge amount of depth in that prosody analysis. There's also conversational context. Again, we're focused in games thinking about what are the cues that something harmful has happened. And one example here is if someone new joins the conversation, says one sentence or one word, and then everyone goes into a stunned silence. If that happens, I don't really need to know what the one sentence was to know that something has gone wrong, right? That's a clue in and of itself that people are feeling harmed, people are feeling upset by what's happening there. And of course, you can also look at the relationship between the players. And this is something that exists in text chat too. But again, because voice is so rich with emotion, and there have been a number of studies on this, one of which I'll reference in a later slide, people have found again and again, you build closer connections in voice chat that can lead to really positive relationships. It can also lead to more opportunity for harm because someone uses that sense of closeness to deliver the insult just that much more viciously or that much more personally to you in a way that really impacts you. So I'm going to play a brief clip. There's no particularly foul language in this clip, but if you're anything like me, you will hear it and immediately feel unnerved. And the thing to sort of listen for is if you just saw the text alone, how much harder it would be to understand that this was harmful compared to hearing the vocalization. So hopefully this audio comes through.
Come back. I want you. Come to my private room. Come to my private room. Come to my private room. My private secret room. Come to the secret room.
Hopefully that audio made it through okay. Again, I hope it's sort of transparent. That feels pretty unsettling to hear that clip as it's vocalized. But the text alone, hey, come to my private room, is something that people say millions of times a day in perfectly innocuous manners. Just one example of many of how that prosody can really transform something and why it's important when you're moderating something like voice chat to not just reduce it to the text content, but to actually look at the voice holistically so that you can understand what's going on. The next sort of preconception that I want to talk about is this idea that harm done by a post is proportional to the number of viewers. In ephemeral voice chat ecosystems, this is of course not true. Most messages are only seen by a few people, typically less than 10. We've done studies with some of the top AAA games out there and found that less than 1 in 6 severe offenses ever gets reported by end users. And that's even fewer for the really egregious offenses like things like child grooming, where the victim might not even realize what's going on. And this is in real contrast to something like Facebook or Twitter, where because you know millions of people are going to see a post, it's inevitable that the post will get reported many, many times. Your concerns are around how do you assess once things have been reported, whether the report is accurate, and maybe can you beat the report and be a little bit faster in analyzing it. But when you're trying to validate and improve your systems, you have a very good ground truth because you've gotten all of these reports before. You know what the prevalence is of this kind of stuff on your platform. But in voice chat, when we went and spoke with all of these game studios over the last 5 years, most of them tell us we have no idea how bad it is in our ecosystem. How could we possibly know? Most things aren't reported, we know that. But beyond that, we don't have any real insight. We don't have any real ability to actually get a good understanding of the scale of what's going on without tools like Modulate has started introducing that allow that sort of collective insight. So when you're thinking about these ephemeral ecosystems, you need to worry not just about, all right, we got a report, how do we validate it? But actually, how do we find things that people might not be reporting in the first place at all? And that becomes a very different challenge. As I also sort of called out here, this is one of the studies that I mentioned that looked into the impact of harms done in voice chat compared to in text chat, and the positivity of voice chat compared to text chat. And again, finds you get much deeper relationships there. So where billboard applications have their harms relate to network effects, again, misinformation, things like cancellation, all that kind of stuff. In an ephemeral voice chat app, misinformation isn't that big of a deal. You know, at most you're misinforming 10 other people. That's not great, but it's not nearly as big a deal as you see on a social media application. But something like really targeted bullying or hate speech done in voice in a situation where you maybe built a faux relationship just to make it hit that much harder when you then try to exclude or insult the other party, that does really serious psychological damage and hurts much more sort of per insult than anything that you'd see in the text domain. And that's one of the reasons why it's so important to be more proactive in detecting and taking action on this kind of stuff. The next assumption is that text is cheap and therefore every post can be analyzed. In a billboard application, again, between the fact that every post is getting reported and every post can be analyzed easily, the only real thing that you need to worry about is the precision of your moderation. And for anyone unfamiliar, there's these terms precision and recall. Precision is basically your false positive rate. When you say something is harmful, how often are you right? Recall is when there is something harmful, how often do you flag it in the first place? So from the perspective of a billboard application, everything is flagged to them in first order. They can analyze every single clip. So they do have to worry about tuning precision and recall on their sort of second layer of analysis, but there's no concern about, are we even going to have the chance to analyze this particular post? In voice chat, though, it turns out voice is really expensive to process. I have on the slide here some really quick sort of napkin math just to give an understanding of how expensive it would be to try and transcribe every single piece of audio happening on some of the top social platforms out there. And that ultimately works out to hundreds of millions of dollars per year for some of these platforms, where that could be 10, 20, 30% of their annual revenue. That's not something that these platforms can afford to do, no matter how much they care about toxicity as a problem. So any attempt to moderate voice chat requires you to first say, what fraction of voice chat am I going to analyze? Since I can't analyze all of it, I need some kind of sampling strategy that allows me to choose which particular conversations am I going to analyze in detail. There's a couple different strategies you can use for that sampling approach. The most obvious is uniform sampling. If you can only afford to process 10% of the audio, just randomly grab 10% of the conversations. The good news is, kind of by definition, there's no bias in that. The downside is it misses a huge amount of harmful content. If you're randomly sampling 10%, you're missing the other 90%. If you're trying to get more specific and focus more on where the harms are actually happening, you might think of something like user report sampling and saying, hey, Let's only analyze things that the users are reporting to us and use that as our prompt to investigate. But of course, as we talked about before, users don't report all of the harms. So again, you're going to miss a large number of harms there. You could try targeted sampling, where you say, let's follow around known bad actors. If they've been offensive once or twice before, they'll probably offend again. So let's spend our limited budget listening to those people to try and catch them the next time. That's better. It helps you at the very least, track those known offenders and understand recidivism, understand how much are people offending on repeat versus learning to behave more effectively. But it still misses a lot of important things, especially in terms of understanding how and when do people start to become toxic in the first place? How do they learn that behavior within this ecosystem? What happens to new users when they come into your ecosystem? What is their first exposure to toxicity? That often is what causes them to churn in the first place. So from an ROI standpoint, platforms care quite a bit about that new user experience. But targeted sampling, since it only focuses on established users, is not going to work nearly as effectively there. Modulate's approach is something that we call statistical triage. The idea here is to use progressively more sophisticated machine learning models in iteration to decide which conversations to zoom in a little more on. The analogy that I use is if you imagine taking your kid to the playground. You probably don't go all in on privacy and just leave them there while you go home and kind of wish them luck. You also probably don't go all in on safety and loom directly behind them, watching and listening to everything they do. Most parents end up standing on the sidewalk, chatting with other folks, but watching out of the corner of their eye. Not enough to know everything that they're saying and doing with their friends, but enough to notice when they fall off the monkey bars, or when someone starts to cry, or when a strange adult that you don't know is walking up to your kid. And when you see that, then you get a little closer. You pay closer attention. You start to try and get an understanding of, does your kid seem to know that older adult? Are they already familiar with each other? Do I need to investigate further? And by the end of it, if you've said, hey, I think something's really wrong, then you zoom in all the way. You actually go and start engaging directly with your kid and being a part of that conversation. What we've designed is basically implementing that same philosophy using these machine learning models. So instead of immediately transcribing and analyzing everything, we start out with some very surface level analysis. Is anyone shouting? Did someone new join the conversation and then everyone suddenly got quiet? Is there a lot of interruptiveness? Are there signs that people are really upset? Is someone trying to hit the report button? Is this a one-on-one between a young person and a much older person who's in 4 other one-on-ones with younger kids? There's a whole host of signs that are actually quite cheap to look at. They're not accurate enough to be the whole moderation process, but help us with that first layer of sampling. And then the next layer, we start looking a little bit more closely, doing a little more sophisticated analysis. And we keep going on that until finally at the very end, we have an extremely high precision transcription of the last couple minutes of the conversation, so we can really deeply understand the conversational context. But we're only doing that detailed transcription for the particular conversations that looked scary enough to get us to that point in the process in the first place. So putting those things together means that we're able to catch a lot more of this toxicity. But whatever your sampling approach, the thing to keep in mind is, in contrast to that billboard approach, you are still sampling. So the biggest concern to think about is not just what's the precision of your analysis, but also what's the recall of that original sampling strategy. Again, if you're using 10% uniform sampling, no matter how sophisticated your understanding of those 10% of the things are, you're never going to catch more than 10% of the harm, because your sampling strategy is your limiting factor. So there now becomes an important trade-off that you need to make between sort of the precision of that analysis, but also the recall of that sampling strategy that strike a balance based on the real costs of doing this processing to help you sort of find the maximum output of how much harm can you actually catch here. And what we typically find is no matter how well you've designed your statistical sampling, you might have recall in the territory of 30, 40, 50% from that. It's probably not going to be 90, 95%. Meanwhile, your analysis precision might be upwards of 95% or even higher. So in general, when there's an option to, platforms will find, hey, it actually benefits us to increase that sampling recall, even if it forces us to use this slightly less expensive and therefore slightly less precise actual final analysis layer. Because if we're getting 60% recall instead of 30%, then even if it's 95% precision compared to 98% precision, we're still going to catch far, far more of the bad behavior there. Every platform will find their own balancing point between these concerns, but the important takeaway is there now needs to be a balancing point. It can't be just as simple as the most sophisticated possible understanding that you could build out in a more billboard application. The last piece that I wanted to talk about here is these different harm types. Again, we noted that in a billboard application, you have things like misinformation, cancellation, network effect harms, whereas in voice chat, those kinds of things just don't have the same weight because they're not hitting nearly as many people. Voice focuses more on emotional content and especially strong relationships. This goes double for us in the gaming ecosystem. Gaming is a shared activity people can do together that really quickly builds rapport and trust. That can be used for extreme good. There have been numerous studies that have shown the mental health benefits, especially for teenagers. For instance, during the COVID-19 pandemic or in other difficult situations, where having a gaming community lends them a huge amount of resilience because they're able to build these really rich, meaningful relationships through the game, even if they're not able to in other situations. But anything that's good in that way can also be exploited by bad actors. So that capacity for building strong bonds can also be exploited by people looking to build strong bonds with a child in order to exploit them, or build strong bonds with a disaffected teen in order to radicalize them, or even someone looking to sort of build strong rapport with someone just because they want to bully them a little bit more intensely and want to sort of build up before they pull the rug out from under or try to push someone towards self-harm. So that understanding of kind of the emotional relationship between the participants becomes very salient to think about when you're trying to understand what's going on in these conversations. One of the terms we use at Modulate when talking about this is to differentiate between behavior moderation and harm detection. Behavior moderation is you're looking for someone to do a specific thing, and every time someone does that thing, it's bad. An example is banning the N-word. Many platforms choose to ban the N-word because it's a slur. But in practice, it actually depends how the N-word is being used. There are some communities that have reclaimed it and would prefer to actually use that within their space as a positive term. And there have been numerous cases, Twitch was one fairly recent example, where in an effort to protect their Black and brown identifying players, they actually went overboard by outright banning this word and got a lot of complaints from players saying, I actually no longer feel welcome to use your platform. I no longer feel like I'm permitted to be there. So instead of looking for behaviors, we try to look for signs of harm. The analogy I use here is think of sexual harassment versus flirting. In many cases, the initial sentence someone says might be the same, and the determination of whether that's harassment or flirting is based on how the other person responds in the conversation. So if you're trying to decide, hey, is this person sexually harassing someone, you shouldn't just look at what did they say. You should be looking at how the other person responded. And in fact, in many cases, for most harms, you can look for those signs of harms first. So instead of saying, what are the keywords people have said, blah, 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 you can say, hey, is anyone exhibiting anguish? Is anyone exhibiting sadness? Is anyone exhibiting anger? Are there signs that someone has been damaged? And only if the answer is yes, then you start looking at the specific behaviors to understand why it was. But that's the other insight behind that sort of statistical triage model that I was describing before, that instead of looking immediately for, did you do this known bad thing, we're able to look for, are there signs of harm? And we're able to do that because voice is this much richer medium that conveys emotion, that conveys even, you know, that breath intake of sudden gasp when you hear something terrible. There's so many signs in voice that don't exist in a sort of lower bandwidth medium like text. So those are sort of the four big conversions that I wanted to sort of bring up, that in contrast to those billboard applications, trying to moderate something like ephemeral voice chat requires really fundamentally different intuitions. Hopefully this has been useful or at least interesting to y'all. I'm happy at this point to just pause and take questions from anyone who has them. But yeah, I hope this has been an interesting sort of exploration of how voice moderation changes the game compared to a lot of other systems.
Thank you so much, Mike. Are there questions in the Zoom room, Martin? Or there are questions in the room, in the physical room? Can I start with some Mike, that sounds like, you know, text moderation is a lot less expensive, and with voice seems like the more pragmatic approach is to sample first, right? Optimize recall and then for precision. Meanwhile, I think it's also quite intuitive for people to understand the tone, the you know, background audio can all make a difference in understanding the context of a particular spoken words or songs for content moderation or, you know, AI safety. Are there other things, you know, you and your company are also considering besides sampling, which seems, you know, no matter what, it's going to be relatively sparse?
Yeah. The short answer is no, but the reason I'll give for that is not, I mean, first of all, to not sample just means you're processing everything, and no matter how you slice it, that just will be extremely expensive. But the other thing to remember is that once these things get flagged, someone has to do something with them. And we generally, I mean, we're an AI moderation company. We strongly do not advise people to just blindly trust the AI. The point of ToxMod is to categorize and analyze and ultimately provide your moderation team this prioritized queue of here's the worst things that you need to be dealing with. But then every moderation team is going to have a limited bandwidth. And if you're talking about a massive platform, Call of Duty, Facebook, whatever it is, your moderation team almost certainly is not actually able to analyze every single thing that's happening there. So in that sense, there's already a built-in sampling problem for almost any moderation application. Which things do you have your moderators actually spend their finite time analyzing? And our goal with this statistical sampling technique is to be able to say, given that they're going to miss some things, let's at least have them spend their time on the most important, most severe things so that they're missing the less important stuff. And if we can shift that sort of attention to the things that are causing the most harm, that are the most important for people to be responding to, then that creates a lot more upside than if we analyzed a few more things, but no one actually had the ability to review our analysis of them and take any action on it.
Yeah, that makes a lot of sense. Can I play devil's advocate a little more in that some of the approaches you mentioned here seems to, I would think they will work really well for, either gaming or some other kind of a scenario where there's a lot of community information you can tap into, right? In order to yeah. So if it's for example models like GPT-4o or other kind of a scenario where you don't have a lot of other information to use in terms of for example the history of a particular player or of a certain game room, then you are a little bit kind of coming in cold if there's a lot of audios generated.
Yeah.
Well, I'm not probably it's not that clear what an answer is yet, but just kind of want to pick your brain on that.
Yeah, it's interesting. I mean, if you're thinking about using generative AI to create audio for, say, a chat bot, for exactly the reasons that you're outlining, I would mostly recommend that you just look at the text before it's been synthesized into audio and you moderate the text. Because one, moderating the text is much cheaper, but two, GPT-4o or anything like that is very unlikely to vocalize that text, frankly, in a particularly emotive manner at all, much less in a sort of negatively emotive manner. And so in that very specific use case, the audio can, in many ways, be reduced just to the textual content of the audio. But if you're trying to build, I know there's a lot of AI dating apps that are out there now or something like that, but you're trying to build an AI that actually builds a relationship with people where it's intended to have those kinds of emotional dynamics, then it becomes very important again to start looking at the audio holistically. But kind of by definition, now you're back in an application where you do have conversations, you do have emotions, you do have a back and forth. So I think that's how you slice it, is if you're not in a setting where you have that conversational context, where you have those emotional dynamics, then you're kind of in a setting where voice is just glorified text and it's fine to fall back to the text in that particular space.
Yeah, that's really good input. Yeah, thank you. Are there other questions from the audience or in the Zoom room? Or Martin, you have additional questions or comments? Okay, maybe so. Mike, Mike, you're going to stay for the panel, right? So maybe
yes,
thank you for exactly on time, and maybe we can chat more at the panel, because I'm still curious, like whether you guys have also started looking into more, using multimodal, for example, audio to do security attacks. What's the consideration there for jailbreak, etc.?
Much more to get into there. So yes, I'll be around for the panel later today, and looking forward to hearing more of your questions then. But in the meantime, thank you all for having me, and hope you enjoyed the next few conversations.
Yeah, thank you so much. We'll talk to you later.
All the best.
Yeah, thank you, Mike. Yeah. So now the next speaker is Manuel. For anyone who has attended the workshop last year, I would think it'd be hard to forget him. He was very proactive in sharing their work. And this year we make sure he has full half an hour to share it. So you need these, and you need these for the book.
Oh, sorry, my computer is responsible for the video of the room. And put it like that. So it's showing the room. Yeah, it's actually showing the room. This one. Yeah. And then yeah, well, Manuel is setting up. Let me introduce him. His research interest is actually right around this topic of video.
Sure.
No,
All right.
not
It looks promising.
missing here. Yeah. See if you can share and probably make it full screen.
So that's that.
Yeah.
And I guess I have to share my screen to the.
Is that the right way to pronounce your name?
Yes.
Yeah,
that's fine.
Manuel's research is centered around the risks and promises of large ML models for humans.
My bad.
Yeah, I need to mute myself.
So
yeah.
So I will unmute and then.
Try again.
All right. Can you hear me in the Zoom? Maybe someone can some thumbs up or something. Yeah, no one is.
Is someone?
Yeah, test.
Oh yeah, they can hear me.
Perfect.
Okay.
All right. Then I think we're good to go.
So your interest.
All right.
you just want to take it away?
I can take it away. Yeah. Hi, my name is Manuel. Thanks for having me. I was we worked this workshop last year already, and I think there is an issue with the screen sharing now, as far as I can see it from your Zoom, because it's not updating, or it's significantly delayed. Okay, that's fine. So yeah, as Mai was saying, we were in this workshop last year, and we're in Darmstadt. I'm from the German Research Center for AI and the Technical University in Darmstadt, and we're doing a lot of research on safety for generative models. And specifically, I want to talk today about safety of vision and multimodal models and how we can leverage maybe these models and related approaches themselves to help us in content moderation and curation. And brief disclaimer, I didn't include like any particularly inappropriate images, but of course this talk will touch on a lot of topics at least that might be perceived as offensive. So first of all, if I say like multimodal vision models, what am I referring to? So at least for the content of this talk, I'm going to talk about like text and vision. So for example, anyone that has ever used like this cool feature in the iOS photos where you can search for, use text to search for photos, and of course, like text to image. This has been really big in the recent years, and an application that I myself really enjoy, where you can create images from text alone. There's a bunch of examples on here using the recent Stable Diffusion model, OpenAI's DALL-E, Midjourney, and so forth. I'm assuming all of you are familiar with these type of applications. But similarly, as we probably also all know, all of these models require gigantic amounts of data for training, most of which is usually sourced from the web in some shape or form. You can't get to millions or billions of images without just going ahead and scraping a bunch of them. Very prominent examples, of course, are the Lion 5B data set, which was also used for training of Stable Diffusion. And then there are other more recent ones that are available to the public, such as the Common Catalog, which just includes CC images. But in generally, common issue with all of these images that if you're downloading from the internet, and anyone that has ever, browsed the internet for quite some time, will be familiar with the fact that there isn't just great content on there. And I personally really like this quote from Berhane, saying that if you then feed these AI systems with not only the world's beauty, but also the ugliness and cruelty that's reflected in these web scraped data, then you cannot reasonably expect to model a generative model trained on that to only reflect the beauty. That's just a fantasy. And this is something that has been shown quite a lot in research over the recent years. This is also not a new issue. This is something where we ourselves in Darmstadt have written papers on, but maybe as a quick excerpt, these are some of the examples. So if you look at these data sets, of course, there will be pornographic content in there. There will be a lot of misogynistic content, and there is also, and this may be one of the bigger problems, content that has strange correlations. So in one of our works last year, we were, for example, showed that if you consider line 5b, a lot of the images that are tagged or that are paired with text containing prompts like Asian women or Japanese women are actually pornographic. And this goes even further. Like there was a recent study by Stanford, for example, that identified like verified CSAM material on line 5b. And you can imagine that if you then train models on these type of data, of course, this reflects in the models themselves as well. If you take a text-to-image model, they definitely learn these kind of strange representations. They do contain biases that are in this data. And to some extent, they may even amplify or make these biases more easily available to the public, because someone that isn't familiar with this kind of research, with this kind of content, will not necessarily expect a text-to-image model, for example, to perpetuate these types of behaviors. So that's basically the outline, and this more or less defines our problem setting. The one question that we can basically ask ourselves is like, if you have a generative model, will it generate unsafe images? Whatever unsafe means, we will get to that in a bit. And the underlying question basically that is beneath that does not only apply to the models themselves, but as it's also relevant for the data they were trained on, is the question, if I have a particular image in a data set generated by a model, is this unsafe? And what is the context in which it is presented that may lead to me perceiving it as unsafe? All right, so let's start with the first question. Will my generative model, my text-to-image model, actually produce unsafe images? Historically, if you want to look into like the behavior and safety of these models, like red teaming, usually one of the dominant approaches there. Red teaming meaning that in a more or less structured fashion, you have humans interacting with a model. You write text prompts, put these to the model, and then ask the model to generate images. And then you can, for example, exploit some prior knowledge about the model behavior or the data set and see if an image is unsafe. Quite recently, there was, over the course of last year, there was this adversarial nibbler challenge that basically outsourced this to the public and made this into some form of like community contribution where people could interact with a lot of models. We ourselves contributed to that. And the goal here was to find images or text prompts that by themselves can be perceived as safe, but the models will still generate unsafe material. And similarly, you can also automate these kind of processes. I put in a nice example paper here that try to derive basically these type of prompts through an automated process using publicly or locally available models. But as you can see, the majority of red teaming basically focuses on this adversarial setting, where you have a user with ill intent trying to circumvent maybe foreseen safety measures in the model and exploit other behaviors to still get to this unsafe content. But I would argue there's a step before that. First of all, we might want to just empirically evaluate how likely our model is in itself to generate unsafe material before we then go to the harder case of like adversarial examples. And therefore, we at CVPR last year, we presented the I2P benchmark, the inappropriate image prompts. And this is basically just a large collection of text prompts, real user text prompts that at some point users have used to prompt these text-to-image models that are very likely to then lead to models generating unsafe content. This benchmark has sort of been the go-to evaluative benchmark for tons of model safety and then mitigation approaches that look into making these models safer. So this basically allows us to then do sort of standardized evaluations where we can not only compare different models, see how likely they are to generate unsafe content by prompting them with these text prompts, but we can also, for example, also compare different mitigation strategies and have a very nice empirical way to look into how these models' behaviors change. An underlying question here that you might have asked yourself now is still, okay, now you have this collection of prompts, you put these into some model and you basically get a measure, or you get a bunch of images generated, and you would now like to assess these images, if they're unsafe or not, to establish some sort of empirical baseline, how likely the model is to generate unsafe content. And, oh, my bad. I got ahead of myself there for a second. So first of all, how did we arrive at this benchmark? The thing we wanted to do, we really wanted to use text prompts that were specifically chosen by users, because these are to some extent different than like other texts you might find. The prompting style to these text-to-image models is somewhat peculiar, and we really wanted to reflect this in the benchmark as well. So what we set out to do, we basically established a safety taxonomy. We have 8 categories of different content that we, for this study, consider unsafe. And then for each of them, we identified certain sub-concepts that you can frame in words. And then, I don't know if anyone participated in this or was aware, the initial Stable Diffusion beta was hosted on the Stable Diffusion Discord. So quite similar to Midjourney nowadays, people could just send text prompts in Discord and then get the generated images. The caveat being, at this point in time, like image generation was sort of still the Wild West, and there were no safety filters whatsoever. You could prompt anything and you would basically get any model, and especially since Stable Diffusion was just trained on Lion 5B without any filters. So all of that nasty stuff was just in there unfiltered, and people also got that content out. And then during that time, a website called Lexica basically just scraped all of these text prompts and the images generated from them, and created this large collections of prompts and images. And we used that, ran an image search basically on all of our unsafe concepts against this large collection. And then you can find images that belong to these concepts, and then we use the associated prompts that led to the generation of these images, and this basically makes I2P, which we then annotated a bit. But essentially, like I2P has been the sort of go-to benchmark for the last year for people doing like mitigative research for text-to-image generative models, and was quite well perceived by the community, better than we could have envisioned, and was used quite extensively to do this sort of like empirical evaluation. But now back to the point I wanted to make originally. The question still is, like, you have this prompts, you put them into a model, you get an image out, and then how do you assess if an image is actually unsafe? Of course, this is all about like empirical and automated measures. So we need some way to do this automatically. And of course, there are approaches for that, which we also used in this work to basically then generate these nice empirical tables. For example, a colleague of mine 2 years ago at FACT had a method that basically gives you a binary label if an image is quote unquote inappropriate. This was trained on an SMID, a large collection of human annotated images, with one of them being inappropriateness. There is the Lion not safe for work classifiers, where similarly gives you like a binary label for nudity. And this, of course, is very rigid, very static. You just get binary labels according to some definition of safety. There are some tools that are available that are a bit more flexible. So, for example, the NudeNet that we also use will just give you an annotation of which exposed body parts you might have in an image, and then you can basically build your policy around that. And of course, there are also commercial tools that we just heard a talk. Another one, for example, would be the Hive moderation platform, which has a bunch of different classification heads for various concepts. But the underlying thing is still, you need to define some concept of safety, and then you train some form of neural network or model that allows you to evaluate this kind of safety. And safety is very concept dependent, very flexible. So for example, if we now consider safety as in, is this legal? The consumption of cannabis, as you can see in the world, widely differs if this is legal or not. So this might be one example where context is really important. If this is a safe image to show, for example, also from a legal perspective, might differ depending on where the user is located or where you run the model. Quite similarly, nudity in a lot of applications, of course, you wouldn't want nudity, or you wouldn't want models to generate nudity, or data sets contain nude material. But this isn't very clear cut. Like, what about art? Artistic paintings. There is quite famously this almost 28,000-year-old statue that Facebook at some point marked as pornographic, and the museum wasn't allowed to post. Like one Viennese museum at some point created an OnlyFans account because they weren't allowed to post like their artwork containing nudity on social media anymore. And we could go on and on about this. An artist using a text-to-image model might have a very different notion of what they would consider unsafe than if you would give the same model to, let's say, school children. There are societal differences, like what is societally perceived as like appropriate, for example, with the amount of clothes people are showing or the amount of nudity also varies widely around the world. And the point I'm trying to make here is safety and annotating safety needs more flexibility. And this is why we very recently shared our current work on LavaGuard. So the idea here is you don't just give an image to a model and then you get a rating, but instead you can also specifically write out your safety policy that you would like to evaluate against. And we basing this on like recent advances in vision language models that can multimodally incorporate both textual and image inputs, and then also provide more flexibility in the output of these models. So how does this look? Basically, our safety taxonomy defines or allows the users to then define categories of potentially unsafe content. These here are excerpts from our default policy as we use it in the paper, or that we evaluate against as well. These categories are somewhat standard. We oriented ourselves against existing frameworks in safety taxonomies and policies of commercial providers and so on. And then the caveat here is, and to those of you that work on language model safety, this might look familiar. And this is basically very similar to what Meta has done for LlamaGuard for textual models. So we basically write out for each of these categories content or an explanation of what our policy here looks like with what is considered safe or not. And then all of this is prompted to the model. So if we look at an example here, I have this image. And then I have my explanation of what I consider hate, humiliation, and harassment and content I would like to show or not. And I prompt both of this to the model. The nice thing is, since we're using a vision language model, we can go way beyond binary classification as well. So the model not only outputs a binary label, but instead gives a way more comprehensive assessment of the image with respect to the policy. So we get a category that this image might fall into, in this case, hate, humiliation, and harassment. Then we get a textual rationale. In this case, describing that we have an image here of a person making an obscene gesture and so on, and that this falls into the category of hate, humiliation, and harassment and violates the safety taxonomy that we specified earlier. And then you arrive at your final rating, meaning that this is an unsafe image. If we now flip or make changes to our taxonomy or the policy provided to the model and saying that content that shows hate, humiliation, and harassment is non-violating. So any content that falls into this category, we don't have any restrictions and everything is fine to show. Then the rationale changes slightly, saying that this is still an obscene gesture, which could be interpreted as respectful, but at the same time, the model acknowledges the category hate, humiliation, and harassment is declared as non-violating, and thus the image now complies with our safety standards, leading to a rating of this image now being safe. And as you can imagine, as these models get progressively better and we improve like the training and so on, you can make more and more fine-grained changes to your policy, and the model should adjust its behavior and its annotation accordingly. If you're interested in using this model, looking into the data, like we provide 3 different checkpoints of various sizes from 7B to 34B parameters, all of which, for example, outperform GPT-4 on this task. Quick link to the project page and quick advertisement as well. We have a preliminary version of this paper that we will present in the Responsible Gen AI workshop tomorrow at 10 a.m. Or yeah, feel free to check this out. So if we now take all of this together, we said we wanted to do data set curation and model safeguarding at scale, automated and flexibly. So here's an example. We basically took 1 million images of ImageNet, ran all of these through the model, and then what we end up with is around 100,000 images that are assigned one of these 9 categories in our safety policy. Only 16,000 of those, or 17,000 of those, actually violate the policy. So a lot of them can be basically considered borderline, but don't violate the policy we defined. And there are some examples here. If you do this kind of evaluation, you find strange patterns in data sets. So one thing that's not surprising, the by far category with the most examples violating the policy is 06, that's weapons. Makes sense because ImageNet has, I think, 3 or 4 different classes that are just different weaponry. But you find other interesting behavior as well. So for example, the category TAP or the class TAP in ImageNet, for some reason, oftentimes it's just nude women. Like the subject in this bathtub is clearly not the tub itself. It's something else. And if you train a model on that, of course, it will pick up on strange correlations. And you might present some nude image to a classification model, and it will end up saying that this is a bathtub. Likewise, if we now combine LavaGuard with what we talked about earlier, and here, for example, we took a subset of the inappropriate image prompts, prompt benchmark, fed this to the model, and then evaluated it using LavaGuard. We end up, I think we generated about 100,000, I think a bit more images. 7,000 of those fall into like some category that is in our policy, and about 1K actually violate the policies we defined. And the behaviors you see here, this also align with like our observations in prior research, like most category detections were for hate, humiliation, and harassment. That makes sense. There's a lot of content there that could be considered kind of like hateful or humiliating, but not a lot of it is actually like crossing the threshold of what most of us might consider unsafe. By far the most definitely unsafe content you observe for nudity, which unfortunately is also in line with what prior research has shown about these data sets and models like Stable Diffusion. I think this is Stable Diffusion 1.5. It's frighteningly easy to generate nudity with these models. All right, that's it from my side. Quick plug for all of my amazing collaborators in this like ecosystem in Darmstadt and Germany that contributed to all of this research. And I think we should still have time for questions, right?
From the room or in the Zoom? Let me see this.
Let me.
Very interesting talk.
Let me see the chat. Any questions in the room? Yeah.
Can you train LavaGuard? Oh. So you train a LavaGuard yourself? Or
No. This is a lava guard because it's based on lava. So we took the lava base models, and then we basically collected a bunch of images, both safe and unsafe, annotated these according to our policy, which was quite the effort. And then we started, we not only annotated these, but we augmented the annotations as well. That meaning that if we then change things in our policy, we made sure that the annotation changes with it to basically make sure that the model picks up on these changes in policy if you prompt the model with it. And then we basically just continue training Lava VLMs on that. If you look in the paper, we have a larger evaluation of different base models. We specifically chose Lava because a lot of the models that are currently available don't do well with either very long context, as we need here to pick up on all of the points made out in the policy. All these models really struggle with structured output. So of course we want output that's either just structured in a JSON or YAML or whatever to get all of these different, these three different parts of our output. And I think this left two models. I think IDFix and Lava perform decently well at that, but the zero-shot performance on like this task of evaluation and so on is actually quite decent in Lava, which is why we then built from that.
So you're saying the zero-shot performance is quite reasonable?
The zero-shot performance of Lava is quite decent, actually. It's like on this task, that is. If I recall correctly, it's actually not that far from GPT-4. Yeah.
Thanks for the talk. Great talk. I have a question. So this reasoning part that you presented,
yeah,
quantify its contribution to the accuracy of the label. So if you ask the model to reason versus you don't ask them.
Yes, this was actually a large point of discussion when we were working on this. There's an argument to be made, which I think is also what one of the reviewers raised when we made like this initial early submission on like a shorter version of the paper. You can make the argument that, for example, the model, since you're generating the output, like the rating, the category, and the assessment in sequence, there may be synergies to exploit depending on what the order is. So the textual assessment might benefit from first generating the category and the rating, and vice versa, the rating might benefit from generating the assessment first. We did a bunch of observations on that and tried out different things. And for the zero-shot model, that's true. Like basically both orders positively benefit the other label. But if you annotate your data correctly and then train on it, this difference basically vanishes after training. There's also some papers showing that if you consider this as some like naive version of chain of thought, that chain of thought prompting you can basically incorporate into the model if you just fine tune on it. And to some extent, that's what happened here. So we tried out different orders and so on. After training, the difference is minimal.
Clarify. So if you have data to fine tune, you don't need this reasoning, you still get the right label, right?
Yeah.
Yeah, that was my experience.
Yeah.
So like, does LavaGuard work on multimodal data, or like is it just images? Like, for example, if there is some context involved that the image standalone might not be impacting any particular policy, but together with the text, it makes sense.
That's a great question. I mean, you can try. In general, of course, this is a vision language model. You can prompt the model with text and images. I would make an educated guess and say that if you prompt this additional context in text, this will probably not influence the model output a lot, because it was never trained on that. Like during our training for LavaGuard, we just trained on the assessment of images without providing textual context. Of course, this is a great follow-up idea and very natural to do, and something we have discussed and we're looking into right now, because the model itself can still reasonably understand and work on text, right? So it makes sense to, at some point, maybe arrive at a joint model that can do either modality in isolation or both together. But my guess is that currently it will probably not work well. Not saying that this is impossible to do.
Questions? One word. Zoom.
No question in the chat, right?
You will stay for the panel?
No, as I said, I have to give another talk.
Okay, yeah, all right. Thank you so much, Manuel, for the great talk and also and people, that's not the way he talk. There's an opportunity to
Because I muted myself. Sorry. Bing, can you hear me now? I muted myself. But I am not hearing you. I don't understand why. What did I do? What did I do?
Can you hear me?
Yeah, now we can hear you.
Awesome,
Perfect.
awesome. Great.
Okay.
I should start sharing my screen.
Yeah, and then I will introduce you.
Oh, can you see my screen?
Yep. All right. Let me try to introduce you. Or do you want to introduce yourself?
I mean, I can do both. Sure, I can go ahead. So hi everyone, my name is Lynn. I am a PhD student at Columbia University. So my research focuses on misinformation and malicious intent detection in social media data, news articles, as well as LLM generated content. So today, on behalf of my colleagues, Jiaxuan Zhang, Professor Sarita Levitan, and Professor Julia Hirschberg, I'm glad to present our work on multimodal deception detection using automatically extracted multimodal features. So deception detection has been increasingly studied by researchers in speech and NLP. So automated methods for deception detection have critical applications for many potential users, including law enforcement, military, intelligence agencies, political and financial organizations. So we see that researchers have been trying to solve this problem by examining different modalities. So for instance, linguistic cues have proven to be useful to identify fake hotel reviews, some controversial persuasive essays, as well as some conversations in the interviews. And also visual cues have also been studied by various researchers. So for instance, emotional facial expression, that's a big part, is shown to be correlated with deceptions. So in our work, we aim to combine the fully automatically extracted features from different modalities and also combine them for better performance in deception detection. In this work, we use the dataset called the Box of Lies corpus that was introduced in the year of 2019. So it contains video recorded conversations between the host of The Tonight Show, Jimmy Fallon, and also 28 guests who played a game called Box of Lies. So as shown in the GIF figure at the bottom right there, so in each round, one player acts as a describer and also gives a truthful description of an object which they see inside a box, or a deceptive description of something that's fictional and not in the box. And so the other player is supposed to guess whether the description is truthful or not. So as you can see, this conversational setting greatly increases the difficulty of predicting truth or lie, since the interaction between the participants can be very difficult to capture. So for the data set in total, there are 68 recorded rounds of the games and a total of 1,049 utterances, and out of which only 187 utterances are annotated as truth, and 862 are annotated as lies. So most of our experiments were conducted on the utterance level simply because there are more data points. However, as we can see here, the downside of using the utterance level data is the data imbalance problem. So to address that, we applied downsampling to the data labeled as lies, which I will be talked a little more in the later slides. So the Box of Lies dataset is human annotated with the following features. The first set of features is the movement facial expression feature. So that is a multimodal coding schema to study gestures and also facial displays. So this set of features consider fine-grained facial expressions, as shown here in the right figure. So basically, annotators were instructed to label fine-grained facial movements such as eyebrow movement, mouth lips movement, etc. So that's the facial expression features. And then they're also asked, the annotators also asked to annotate the speaker veracity as truthful or deceptive on both the round level and also the utterance level. And in addition, they were asked to write transcripts of these audios. So before digging into our approach, we first look at how difficult this task is by looking at the baseline models, as well as the human performance on detecting these lies. So we used random forest as classifiers, and then trained on these human annotated features and used that as a baseline. So in the end, 65% accuracy is achieved, which proves the difficulty of this task, given that this is only a binary classification. And also when we look at how humans are performing, we look at how well the participants and also the host of this show in detecting these lies. So as we can see that the overall accuracy is about 56%, so that's even lower than the baseline model. So this further demonstrates that the deception detection is a very difficult task. And sometimes humans are not even as good at that as models. But however, obtaining human annotated features for model training is very time consuming and expensive, as we all know. So therefore, we decided to explore the potential use of fully automated feature extraction techniques without actually relying on any of the human annotated features. So the overall goal of our work then is to automatically extract features from all of these three modalities and also compare how effective they are compared to human annotated features. So we would like to see if classifiers trained on these automatically extracted features would outperform the baseline model that is trained on human annotated features, basically. So first, let's look into how we process the acoustic features. We started with acoustic features since they were not being explored in the previous work on this corpus. So the main challenge for processing these acoustic features is that the recordings have substantial background noise, including laughters and applause from the audience, as well as some background music. So therefore, we first explore different options to reduce the noise in the acoustic signals. So we have experimented with 3 different ways, including calculating spectral centroid, MFCC, medium filtering, since these are all existing well-known methods for noise reduction specifically, so we won't go into too much detail here. And for the actual feature extraction, we adopt the OpenSmile toolkit, which extracts acoustic features like pitch, energy, MFCC, and etc. And as well as some common functions like minimum or maximum, or the range of these acoustic features. So that's the acoustic features. Moving into the visual features. So the major challenge of processing visual features, especially facial landmarks features, is the frequent change in camera angles, which causes the change in angles and also positions of the speaker's face in different frames. So therefore, we extract facial landmarks from video frames that contains the face of the describer using the tool called DLib. So the describer is just the person trying to describe the object in the box or not. So each extracted face is represented as 68 coordinates of XY pairs. So on the right-hand side, you can see the visualization of these facial landmarks. So to match the face of the same speaker and also exclude the partner's faces in the same video clip, we actually compute the face embedding, which is 128 dimension vector, and also measures the distance between two faces using cosine similarity. And then to eliminate the effect of these faces being located at different positions with different angles, we then normalize the coordinates of each distinct face that's being detected. And then as a result, for a single video clip on utterance level, we will detect a series of facial landmarks. So the number of faces in different series will be different since the length of the utterances are different. And therefore, we explore the following two ways of map the features into the same dimensionality. The first option that we tried is the Fisher vector encoding. So essentially how it works is that a Gaussian mixture model, GMM, try to estimate the distribution of any visual features being extracted, which in our case is the facial landmarks. So then the Fisher vector actually encodes the gradients of the log likelihood of these features under that GMM that models them, which is with respect to the GMM parameters. So this actually create a fixed length vector representations. So to a little bit more detail here, suppose that a GMM model like that models the facial landmarks as shown here in the first equation, first line of equation right there. Then the final Fisher vector is simply the concatenation of the second and third equations right there. So for a total dimension of 2 times the number of clusters of that GMM, also then times the length of the single facial landmark feature. So that's 68 times 2 XY pairs. So a Fisher vector, so FB encoding have been shown to outperform traditional bag of words visual representations for image classifications. And so therefore it fits perfectly into our use case. And then the second approach we considered is the VLAD encoding, which stands for vector of locally aggregated descriptors. So this is very similar to FB encoding. It also tries to map features with various lengths to the same latent space. But the main difference between the two of them is that VLAD uses k-means clustering instead of GMM to model the features. And also it does not consider the second order information about the features. And then in addition to these two unsupervised image representations, we also explore a supervised approach, especially for facial expression detection. So essentially there are 7 categories of facial cues and behavior annotated in this corpus, as we shown earlier. Wait, was there a problem with the Zoom? All right, I'm just gonna go ahead. So essentially each category of facial cues is, such as head movement or lip movement, they're annotated for a more fine-grained level of taxonomy. So for instance, right here, for head movement, a more fine-grained annotation of 14 types movements are annotated as illustrated here on the top right table. So that can include nod, turn, and still, and etc. And then so the same fine-grained annotations are done on all 7 categories of facial behaviors. So we wanted to leverage these existing gold annotations and also explore whether it would be more useful to detect deceptions than our unsupervised methods, basically. So then we trained individual facial expression detectors with facial landmarks coordinates as input features, and also to try to classify the class-wide behaviors as output. So these classification results are quite promising, as shown here in the table at the bottom, achieving accuracies of 70s or 80s across all categories, especially given the challenge that the camera angle changes constantly and thus the face of the describer is quite different from different angles. And lastly, let's look at the linguistic features that we use. So since manually transcribing the words from audios could be tedious, we decided to use Google speech-to-text ASR model to automatically generate the transcripts from the audios. But we can see here that the word error rate was actually fairly high. That was 47.43%. So we are interested in discovering how difficult it would affect.
At least our phones probably need to cut off the Wi-Fi here. It seems like the Wi-Fi here is really.
Oh.
Huh? Which one? This one? This one? Yeah, I don't think it's the mic. I think it's the. This is not the. This is solid. This should be the one. I am using the organizer's one. Yeah. Yeah, sorry, Lynn. I think it's the Wi-Fi.
No worries.
A little bit choppy. Yeah, please continue.
Okay. No problem. So yeah, we can see that the ASR performance is actually pretty low given this fairly high word error rate. And aside from the low performance of the ASR model itself, another potential challenge that's causing this low quality is because sometimes in our recordings, we see that multiple speakers often speak simultaneously. So that also leads to low quality ASR transcripts. So essentially using the ASR transcripts, we further extracted 4 different types of lexical features, which are unigram, loop, word embedding, and part of speech tags. So in case you're not familiar with LUC, it stands for Linguistic Inquiry and Word Count, which groups words into 80 psychological motivated categories. And it has been proven to be very useful in many deception detection experiments. So since the goal of our work is to compare the effectiveness of our extracted feature sets, we choose to use a relatively simple model, which is the random forest classifier. So that is what we use for the baseline model as well. So as we see earlier, the data set, especially on the utterance level, is quite imbalanced with a 82% utterance labeled as lies. So to mitigate this data imbalance problem, we consider using both downsampling and also upsampling in our strategy. But then interestingly, our experiment showed that applying upsampling in the truth utterances will actually easily make the model overfit, probably because this is a random forest classifier. So therefore, we just choose to use downsampling across all of our experiments. So for acoustic prosodic features, we compare the performance of models with both unfiltered noisy audio from noise reducted audios. So as shown here in the left table, noise reduction, as we can see, is important for deception classification, achieving 63% accuracy using the spectral centroid method, as opposed to 60% using the unfiltered noisy data. And for results using visual features, we compared classification results between our automated features and manually extracted features. So we see that features generated by our trained facial expression detector actually achieved an accuracy of 64%. That is slightly outperforming the manually annotated facial expressions. But however, it is not the best performing one. The best performing feature is the visual deception class. It's the FB encoding, so that is achieving about 67% accuracy. So it is quite impressive and useful to see that this, because FB encoding and also VLAD encoding does not rely on human annotated features at all. So, but despite that, it is still very useful in outperforming both. So for lexical features, the best deception detection performance obtained with the ASR transcripts was quite similar to the ones with the manual transcripts, actually. So which was both around 63%. So clearly, ASR transcripts allowed us to capture the important lexical features for deception detection, despite the high word error rate. So even though the transcript quality is low, it is still performing good compared to human annotations, using human annotated transcripts. And then lastly, we trained multimodal classifiers, combining the best performing features from each modality. So to be specific, for acoustic features, we use the features extracted from the noise reduced audio. And then for visual features, we use the FB encoding. And then for linguistic features, we just use a combination of all features extracted from the ASR transcript. So that is the word embedding, Luke, part of speech, and etc. I think unigram, yes. And then we compared our multimodal deception model with the previous human feature results that's in our baseline model. So as we can see, our multimodal model actually achieves a performance of 73% accuracy. So this is an 8% absolute improvement over the best performing model using like manual features. And in addition to the utterance level analysis, we also evaluate our proposed method on the entire round of games. So the advantage of that is to evaluate the performance and then compare that with the human performance. The human performance are only annotated on the round level. So what we do is that we trained a classifier on the utterance level data and then generate the round level prediction taking the majority votes. And then using this approach, our classifier actually achieved an accuracy of 72% on the entire round of games. So this is a 16% absolute improvement over human performance, which was 56%. So yeah, moving into future work, we will evaluate our model on real-world multimodal deception data, such as videos of court testimonies and some political speech, where deception has a higher stake, essentially. And then in addition, future work can explore more up-to-date classifiers to model conversational context, as well as temporal features to improve automatic deception detection. And then lastly, trust analysis. So that's the opposite of deception analysis. Is also another interesting topic inspired by this data set. So essentially, we could potentially analyze whether the opponent of the game will believe what the describer says about the object, and also what features actually contribute to that part of trust. So with that, it concludes my presentation. And in case you have any questions, feel free to send us an email. And then this is a quick link to our paper. Thank you very much.
Yeah, thank you so much for the very interesting talk.
Thank you.
Action issue, I find that very interesting. Let's see if there are questions in the room.
Okay.
I'm checking, and also any questions on the Zoom, in the Zoom room. Seems like was there connection with the Zoom itself? We lost a lot of people in the Zoom room. Yeah.
I don't see other participants on Zoom though.
There's a question in the room.
Oh, okay.
Yeah, below.
In one of the tables, the AUC value was like highest for 2 modalities instead of just like all 3 modalities combined. Yeah, L plus V. So like, the accuracy can be misleading here, right? So like the AUC values for L plus V is higher. Like, do you have any observations regarding that kind of like for that observation? Yeah.
Absolutely, absolutely. Yeah. So yeah, we agree that the accuracy can be a little misleading. Maybe some other metrics like F1 can tell us more. But still, we can see that when comparing F1, like adding 3 modalities is still getting better results right there. I don't know if you can see it there. So it's the last column in the table, and also the AUC. These are quite close to each other, actually. So I wouldn't say that is significant better, like the 2 modalities are significantly better than 3 modalities, especially compared to other, metric. So yeah, we do observe that like when you combine different set of features together, sometimes one works better than the other, but like in general, oh, there's a delay.
Lin, I think seems like a huge delay. We can see you are talking, but we can't hear you.
Okay.
Okay, now can you repeat your last answer? We saw your talking.
Okay. So I was just saying, so accuracy can be a little misleading, but like when we look at other metrics like F1 here, we still see that like with all three modalities, F1 actually is doing better than just with two modalities. And also, even though like the AOC like under like the condition of just combining lexical and visual features, it is just a little bit higher than the three modalities, right? So like I wouldn't call it a significant improvement, or it is significantly better, especially when we compare it against other metrics. So yeah, I don't know if that answers your question.
Thank you.
Thank you.
Any other questions in the room? Actually, I'm curious about this lexical feature. We actually experienced something similar that, sometimes the text to speech to text, the word be not so low, but it seems like in your experience using probably seems like Unigram, right? Seems to allow. So that, improves the performance despite pretty high word error rate, right? Is that your
yeah, that's one of our insights. But like instead of just using Unigram, I think the other features also plays an important role. Like Luke, especially, I think Luke is a very significant feature in our experiments. And also we still use word embeddings like words for that. So Unigram, it's only part of our feature set when we consider lexical features. Yes.
Yeah, makes sense. Also, have you evaluated this on something, for example, if the evaluation set can be, somewhat of a domain shift from the train set?
Yeah, that's a very good point. Yeah, that we haven't gone so far yet. I do think that we should try like cross cross domain, also maybe probably cross lingual as well, right? So like we want to see which features, especially audio, like acoustic features, like independent of what lexical features are telling, whether some of the acoustic features are transportable to other languages as well. So those are the things that we're interested in.
Yeah. Very interesting. Yeah. For talk and answer. Any other questions from the room? If not, thank you for keeping us right on time. And yeah, you won't be able to join the panel, that you have other commitments. Yeah.
No. Yeah. Thank you for having us. Thank you for having me. Thank you.
Ask you questions, from the information you shared. Yeah. Thank you so much. Yeah. All right. So that's our first session in the afternoon. We will have a break because people want time for networking, not just listening to talks. And we'll resume at 3:45 sharp with a talk from Google, from Susanna. So we look forward to see you in about half an hour.
Let me know. Okay, good. I'm being recorded now. So I'll repeat that for the joy of people who are watching this afterwards. If you know what a Godzilla bug is, which is my son Julian's dream pet, let me know. Send me an email. I think it's made up. He thought about it for a little bit longer and he said, maybe Godzilla bug is a little hard to write about. I'm not sure I can write a page about my Godzilla bug. So maybe I'll do a dog instead. So good. I know what a dog is. Okay. And Julian's 8, right? So he's still getting the hang of like, how do you actually get started writing, right? How do you take all of the big ideas in your head and put them down on paper? And so we thought about what could help us get started on what should we write about your dream pet, the dog. And we thought it would be great if he could have a picture of this dog in his head that he can then start to write about. So awesome, we have these cool new text to image models now, right? And so we can go into slides and we can say, Gemini, make me an image of a dog sitting on a rug. And we get these 4 samples out of the model. They're all very cute. And so Julian can use these to kind of get unstuck, right? Pick one of these dogs and write about your future pet. I don't know what the dog's name would be, but maybe Rover or something. So awesome. But what does any of this have to do with content moderation, right? Why am I telling this story in this workshop? Well, let's go into a little bit of a parallel universe world where instead of getting this result from slides, Julian got this result instead. So, okay, two cute pictures of a puppy dog, but also two weird, like, this image might violate our policies statements. So that's strange, right? Like, what possibly could these ambiguous shadowy policies be that Google has that would cause a dog sitting on a rug to violate these policies? This is a surprising and strange result. And I can guarantee, of course, this is a little bit made up, right? This is not actually the result that happened, but I can guarantee that if we did get this result, Julian would be curious, right? He would say, what's going on here? And he would start questioning this, start trying to figure out what's happening. And I think all of the rest of us would have this kind of response as well, right? It's natural that if you are faced with this kind of unsurprising or surprising result, not an unsurprising result, if you're faced with a surprising result like this, you try and start explaining it, try and start coming up with theories with what could be going on here that is causing this. So we can see how content moderation has had an impact on our lives and our thought processes, at least in this fake world. But what does any of this have to do with fairness and inclusion, right? We're just talking about dogs here. Maybe it's not clear. So what if Julian's assignment isn't tell me a story about your future pet dog? What if it's what do you want to be when you grow up, right? That's a kind of standard third grade, fourth grade assignment. Tell me what you want to be when you grow up. So maybe we're doing the same thing, right? We're still trying to get ourselves unstuck, trying to imagine what can my life be like? What can my life be like if I'm a veterinarian, or if I'm an astronaut, or if I'm a video gamer? And so we're doing the same thing, right? We're playing around with these models, trying to imagine the future or imagine a possible future. And we might not even need to have these like very clear blocks. But we might be in a situation where maybe we're generating more images for one profession than we are for another, right? So even if we're not explicitly communicating to the user that we're blocking content, maybe you're still getting this different experience. And that might, get your mind wandering and start thinking like, that's weird. How come I'm not getting images of professional video game players? Like, what's going on here? Why might Google not be able to show me what a professional video game player looks like? And, I would definitely encourage Julian to keep thinking, like keep being curious here, right? And so maybe we would go research, what are these policies that would cause Google to decide, does it want to show images or does it not want to show images? And eventually maybe we would get to Google's content policies for search. And part of that is this hate speech, hate policy. And part of that reads, we don't allow content that promotes or condones violence, promotes discrimination, disparages, or had the primary purpose of inciting hatred against a group. Okay, that's kind of vague, definitely sounds serious, and it definitely makes me wonder, in this parallel universe, what has Google learned about video gamers that makes it like possible that these images might violate policy in some way? And maybe does Julian actually want to be a professional video game player when he grows up? The answer to that is definitely yes, but our imaginations are kind of running wild here, right? So let's take a step back and ground it back in reality, leave imaginary world for a minute and just make sure we're all on the same page of what actually is happening that might cause this behavior that I described in this fictional universe. So what actually happens if you go into slides and you say, generate me an image for my talk. I want to talk about pet adoption, and so I need an image of a dog, right? What happens at very, very high level is we take the user prompt and we pass that prompt through this text safety layer, right? So we have a bunch of guardrails that say, is this a prompt that I actually would want to generate an image for? Yes or no? Assuming the prompt passes through that safety layer, we go to the magic blue box or there. And so that's a diffusion model, right? A text to image diffusion model that's actually generating a bunch of samples of images. Each of those pass back through another safety layer. So this is an output layer now that's a bunch of image classifiers saying, is this an image that I would want to show to a user, or might it violate, or might it not be aligned with Google's policies where we'd want to show it? And assuming everything is fine there, you get an image of a nice crocheted elephant walking through the desert that you were looking for, right? So great. So a lot of the attention, I think, in content moderation is rightfully focused on those safety layers, right? On how do we detect, how do we effectively process and make sure that we suppress content that we don't want to see. But what I was hoping to motivate through this story about Julian is that the system doesn't work well overall unless you're also thinking about what's in this blue box, right? How do we actually generate content that we do want people to see? Otherwise, we get blank output all the time, right? So we need the whole system to be working together and to be able to describe not just what we don't want to see, but also what we do want to see. So the way we have kind of devise a framework to help us think through that at Google is through the AI principles. So these are kind of a high-level set of principles that help us define how we want the systems to behave if they're doing the right thing. They are these 7 principles here, so I'll read them out to you. First of all, we want the AI systems to be socially beneficial. We want them to avoid creating or reinforcing unfair bias. We want them to be built and tested for safety, to be accountable to people, to incorporate privacy design principles, to uphold a high standard of scientific excellence, and finally, to be made available for uses that accord with these principles. So the job of my team and my job at Google is really to focus on number 2 here, to kind of unpack that statement. What does it mean to avoid creating and reinforcing unfair bias when you're talking about the technology that Google develops and deploys out in the world? And basically we work on taking this kind of broad principle and turning it into concrete, actionable properties that we can define that we want the model and its output to have. And then we work on building technology that can help us get there. I want to make sure that I take a minute to kind of dive down and look a little deeper on what it means to define what is actually, what do we mean by don't reinforce unfair bias, right? There's tons of different things that could mean. And maybe if you're coming from like a more of a theoretical ML fairness background, what you start thinking about is like demographic parity in a classifier, or maybe equal opportunity in a classifier. If you're more like me and you come from kind of a traditional computer vision background, maybe you're talking about like a face recognition system and you want to equalize performance, equalize odds, and make sure that that face recognition system works for everybody. What we think about a lot in terms of generative AI is, like May said in my intro, making sure that the systems and the content that is produced don't reinforce harmful stereotypes. And the reason why we think that's so important is that research has shown us that there's a kind of a lens that technology applies to the world that filters our view of the world. And it actually has the power to change both how we think about ourselves and also how we think about and understand the world, right? So we want to make sure that the experience that people have using Google products doesn't cement incorrect, false, kind of narrow beliefs that are going to have a negative impact in how they're treated in the world and how they treat others in the world if we can avoid it. Okay, so for the rest of the talk, I'm going to introduce 3 separate examples of how what this means, right? What does it mean in our work to design systems that don't reinforce stereotypes? The first 2 are going to be more examples from text-to-image models, and then the last example is going to look at a visual question answering setup in the Gemini model, multimodal Gemini model. Okay, great. So let's dive in and talk a little bit about how people are portrayed in generated content, in generated images. How many of you remember or have used the Lensa Magic Avatars system? Pop quiz. Only Susan. Awesome. Okay. I know Susan, so I can pick on her. She's on my team. Cool. So full disclosure, I also have not used Magic Avatars. So but I will explain it for all of you. It went viral back in kind of 2020, late 2022. The idea is it's this cool app. You feed in like 10 to 20 different images of yourself, kind of headshot pictures of yourself, and then you wait for a while. And what you get back is a whole bunch of like personalized generated images that are you in different stylized kind of artwork, or you as a fairy princess, you as a medieval knight, you in outer space, this kind of fantasy, letting you imagine yourself as different fantasy characters. So if you were on certain parts of the internet, I think in like late November, December of 2022, you might have seen lots and lots of people posting these images and saying like, look at these awesome, cool things that I made with Lensa, and you know, using them as their profile pictures and that kind of thing. So that was really fun. But there was also kind of a separate subpopulation, a separate set of people who were having a very different experience with this app and the type of data, the type of images that were being generated. And I don't mean to call out a specific company. I just want to use them. I think they're a good motivating example. So here's what the journalist Melissa Heikkila wrote about her experience using the Lensa app. So she says, the viral AI app Lensa undressed me without my consent. Of 100 avatars that were generated, 16 were topless, and in another 14, it had me in extremely skimpy clothes and overly sexualized poses. So I think we, in my team at Google, we would call this a bad output, a bad outcome for this model. 2 reasons. First of all, this clearly is not meeting her expectations, right? These are not useful results for her. She's not having a good experience here. She's not going to use these as her profile picture. She did get to write an article. She's a journalist, so I guess that's good, but it's not going to be used for the intended purpose that Lensa was expecting. But this kind of second, more deeper secondary issue here is that it's not just like a personal problem for Melissa Heikkila, right? These results, given that she didn't ask for this type of content to be generated, but it was generated anyway, is kind of portraying this very specific, reinforcing this narrative about women and their place in society and their worth. So there are kind of 2 levels of problematic things that are going on here. And what we call this type of behavior in our research is over-sexualization, and it's where you have a text prompt that is basically neutral, but you have output that is more harmful or less safe than the text than is necessary to match the text. And that's part of a larger set of issues that we work on which we call harm amplification, when it's not necessarily sexualized content, but it's harmful content in some other way. So we've come a long way since 2022 in our work on text-to-image models, but unfortunately, we haven't solved this problem, and we're still seeing over-sexualization as kind of a prevalent failure mode for models across the industry. So these are 3 examples from earlier this month. These are just the first 3 images that were generated for these 3 prompts. So I prompted for a woman sitting on a bed, a beautiful woman sitting on a bed, and a beautiful dark-skinned woman sitting on a bed. And these are pretty neutral prompts. Many, many, many different types of women could be sitting on a bed. But we're seeing a very particular view here, right? We're seeing over-sexualization. These are much racier output than is required to match the text prompt. And we also see this concerning exaggeration of this effect as we're going toward representing a marginalized intersectional population. So we have anecdotal evidence here, but in order to really measure this at scale and be able to intervene and align model behavior away from this effect, we need to measure at scale, not just at this kind of anecdotal proof by picture kind of mode. So we do this in two ways. The first way is simply by asking human annotators. So we give them a data set. This is the adversarial nibbler data set that Manuel talked about earlier today. So that was a great, great intro that I don't have to then describe this data set for you again. But we asked human annotators to judge the harmfulness of the text and then the harmfulness of the image output. And anywhere where we see the image output is significantly more harmful under certain categories than the text input, we would call that harm amplification. The other way you could do this without human annotators is by using calibrated classifiers, again, like those safety classifiers that I talked about in the beginning, where you're processing the text input and then also the image output and looking for a miscalibration there in the like tone, essentially, of the input and the output. What we found in this research was that first of all, we see that over-sexualization is more prevalent overall than unexpectedly violent output, and also that there's this very noticeable, significant difference in over-sexualization as it applies to images of women versus images of masculine-appearing individuals. And I think that, I guess one other point that I should echo that Manuel made for me earlier today is that, of course, what actually counts as harmful, what counts as safe or unsafe in this content is contextual, right? And so there's a lot of room for open research to continue exploring what does it mean for these safety ratings to be more inclusive, to be tailored to certain audiences or tailored to the societal expectations where the technology is deployed. Okay, so hopefully I've convinced you that we have a kind of more systemic issue here that we still need to work on. But the good news is that we aren't stuck, right? We do have promising approaches that we think can move the needle here across the development cycle. So some of these that we've explored include both pre-training data mitigations and then also mitigations that you can apply at inference time as you're sampling and generating images. First of all, I guess kind of obvious, just overall reducing the non-safe for work content in your data can teach the models that to learn a different prior over what people should look like in the world. We also find that using better captions can help. So rather than just relying on the alt text that you found across the web, using pseudo captions or using VLMs to make sure that the caption for the image that you're training on is matched with the actual content of the image. So you don't have data that just says like a woman, you have data that describes what the actual image content is, so you don't get this mismatch between text and image. And then of course, during actual inference time, you can apply approaches that are similar to classifier guidance, where you are kind of taking a direction towards raciness or away from raciness, and applying that guidance along with your normal text conditioning to move away from those kind of racier images. Okay, so now we're going to switch gears and move from how people are portrayed to talk about who is portrayed in the images overall. So let's do another thought experiment. If you guys will, you all will humor me. I want you to put a picture in your mind of the image that is generated for a portrait of a poor person. Okay, does everybody have a portrait of a poor person? Here is the first sample from a portrait of a poor person. Okay, maybe not the image I was looking for, so let's try again. Portrait of a poor person. Portrait of a poor person. Keep going. There's another 3. Okay, starting to sense a pattern here. Yeah, okay, so if I squint and I look at these, this is a very specific, narrow slice of the population, right? There's a very particular view that these models are representing of what a poor person looks like. But maybe it's just this templated result, right? I picked a bad cherry-picked prompt here, so let's try something a little bit more nuanced. So rather than a picture of a poor person, I'm going to generate an image of a woman standing in a welfare line. Okay, so here's a bunch of images of a woman standing in a welfare line. And again, we see this very narrow slice of humanity represented, right? So these models seem to be propagating a view of poverty that is closely tied to certain demographic features, right? Poor people have dark skin. That seems to be what I am learning from my experience with this model right here. And so again, we have kind of anecdotal evidence that I've showed you here, but in order to really align these models and do something about this behavior, what would be helpful to have is more computationally scalable tools that we can use to tackle this problem more systematically. So this is part of the reason why my team at Google partnered with Dr. Ellis Monk, who's a sociologist at Harvard back in 2020, 2021, to look into developing and adapting the Monk skin tone scale, which Dr. Monk developed, into a tool that could be used for ML fairness analysis so that we could use it to measure and mitigate model behavior. The intention behind this scale is that it's designed to be a more inclusive and more representative scale of a broader range of skin tones than we had available in the past through tools that we've traditionally used for ML fairness analysis. And you can go to skintone.google to learn more about the research behind this scale if you're interested. One thing that once we have the scale, we've been really interested in studying actual annotator behavior and how perception of skin tone in the world works for real people, and in particular, how that perception might vary depending on where people live in the world and the kind of environment that they're exposed to on a daily basis. And the point of this is that we want to make sure that the way that we use the scale in practice is aligned with the way people actually experience skin tone and the way it actually impacts their life. So we ran this large-scale study where we looked at annotator behavior across both professional photographers and then also kind of more traditional computer vision crowdsourced annotator populations. And we looked at professional photographers who are based in the United States versus those based in India. And then our rater annotator pools are sourced from people living in Hungary, Ghana, Brazil, the Philippines, and India. Sorry, did it out of order from the normal way I do it. And it's too small for me to read. And then we studied this annotator behavior on both a curated set of images where we could control the environmental factors like the lighting, and then also across a larger like training scale sized set drawn from the Open Images data set. And we found some really interesting things. The first thing we found was that in contrast to dermatologists, who we did a pilot study initially with, photographers, professional photographers, were much more likely to assess skin tone in a way that we felt mirrored social perception. Dermatologists who, for context, if you're not very familiar with kind of 2018 world of computer vision fairness, there was a lot of focus on using dermatologists to rate skin tone as experts. And what we found was actually that dermatologists would tend to like try and guess what color my skin looks like underneath my shirt or like somewhere where my skin is not exposed to the sun, right? Which is good from a medical perspective. That's their medical training coming out, but it's not a match to how like a regular person perceives skin tone going about their daily lives. And so what we found was that that professional photographers would be better experts, we thought, to mirror this kind of social perception, and also that regular annotators who don't have any particular domain expertise outside of training for this particular task could perform this task well. That being said, the task is subjective, so skin tone perception is subjective, and so we expected and did see slight variations between annotators regardless, and we also found systematically different annotations as we varied the geographic location of the raters. So broadly, people had roughly the same mental model of what skin tone meant and how to map that into this categorical framework. But depending on where you were in the world, and we hypothesis that it's based on your local context and maybe your upbringing, there did seem to be a slightly different mental model that people were using depending on where they lived. One thing that we were very pleased to see was, like I said, the annotators could do this task reasonably reliably. And in particular, they were pretty good at factoring out environmental nuisance factors. So as long as you gave them enough context, they were able to assess skin tone regardless of like occlusions or deep shadow lighting or very bright specular highlights. They tended to agree with the annotation that was provided by the scales creator, by Dr. Monk, within basically one category. And the reason why I stress that is because when you're working, if any of you start working with the Monk skin tone scale, which I hope you do, there's a temptation, because it's defined based on these colored stimuli, to kind of lean heavily in computation to matching RGB colors from pixels. And when you do that naively, you get the wrong answer, right? You do not get labels that are aligned with the social perception that people have. And that can be problematic because on the one hand, we might be convincing ourselves that our models are more diverse than people actually experience them to be. And on the other hand, we might be convincing ourselves that they're less diverse than people actually experience them to be. So what we want to do is pay attention all the time to whether the computational tools that we're using are actually aligned with real annotator, real observer experience in the world. Of course, skin tone is just one aspect of what people notice about other people. It's a very salient and important aspect of people diversity, but it's by no means the only thing that that is important about someone when in terms of understanding about their life and about representation, and whether you see yourself reflected or you see other communities reflected in imagery. And so recently we've been looking into how do we build a scalable, flexible system that lets us really align our analysis tools with even more with what people really experience when they're seeing images of other people. So we don't, we're not restricted to looking only at gender expression or at skin tone or the combination of gender expression and skin tone, and leave out all of these other important factors like cultural attire or perceived religious observance or body shape or whether someone's using a wheelchair or not, right? There are like so many different factors that that communicate social cultural identity to us through imagery. So we recently presented this work a couple weeks ago at FACT, and the method is called PATHS, which is short for Perception Aligned Text Derived Human Representation Space. A little bit of a mouthful, but PATHS, much easier to say. And the goal here is, like I said, to develop kind of a label-free embedding space where we don't have to define a taxonomy, we don't have to define particular aspects a priori. And very importantly, we don't have to just define how they are weighted against each other, but we still get a mathematical representation that we can use to measure similarity or diversity in images in ways that are aligned with how people experience it. We do this in starting with a like pre-trained general visual multimodal embedding. So we use the COCA embedding. And then we find a subspace in that embedding space that represents people. So we look for text attributes that are related to people, and we use PCA to find that subspace, and we project out the rest of the information from the embedding that looks at things like style or the background or what objects are in the image. We're trying to focus more on people as the subject of these images. So that's great. We have this subspace, but the problem is that the distance in that subspace has, like, there's no reason why that would align with actual distances and similarity metrics that people experience. So we train on top of that a linear transformation that tries to massage those distances so that they're more representative of what people actually experience. So in this example, we want to make sure that basically we have a rater template where we ask humans to do this triplet rating, which one of these images is more unique, more different from a person representation perspective, and we want the distances to be aligned with the ones that people are most likely to say are the outlier, the more different of the three. Okay, so does this work? Yes, good. That's great. What we found is that when we do this process, and then we then use this embedding as part of kind of a standard image diversification, image ranking algorithm, we get results that are robust across different operating regimes. So we have two different data sets that test the model in two different scenarios. One is the occupations data set that has relatively constrained people diversity, so mostly just gender and skin tone diversity, but a lot of visual diversity. So it has images of a lot of different styles, different settings and backgrounds. And we see that a raw image model that's not fine-tuned to be specific to people actually does a really poor job of aligning with human behavior there. That's the negative bar that you see. Whereas the model that we train is kind of the right, it's not too broad. It's Goldilocks mode there in the middle. The other data set that we evaluated on is a new data set that we curated, which is called the diverse people data set. And that is focused on images where the person is the subject of the image, but we intentionally curated it to have a much broader kind of range of what diversity means in terms of people. So it includes cultural attire, it includes body shape. It's not restricted to just these two factors. And so that's testing whether the model is too narrow, right? Or whether it can capture this kind of richness of diversity. And we see it also works well in that scenario. Okay, this is my soapbox slide, which is that whenever you are doing this kind of analysis where you're saying, I want to measure diversity or I want to optimize for diversity in an image set, it's super, super, super important to always go back and condition on the text that is associated with those image sets. So it can be tempting because, you know, it reduces down to one nice number to look at the marginal distribution. But when we do that, there are two problems. First, we can convince ourselves that a model that is actually biased is fair, as long as we've constructed our evaluation data set in a way that we have paired test prompts all the time. But more importantly, when we do that, we can also misalign the results from the actual text prompt, and that can cause additional representational issues. So we can kind of make the problem worse instead of better. And the way I think about it is we really always want to go back to why are we doing this in the first place? And if you remember, hopefully from the beginning of the talk, why we're doing this in the first place is to think about reducing reinforcement of harmful stereotypes. And harmful stereotypes don't just come from the images, right? They come from the entire narrative that's being communicated by the image content and the text that goes along with them. So it matters how the images are described and not just what's in the images. Okay, so those were the two examples of text to image. We have one more whirlwind tour of how we might be reinforcing stereotypes by talking about the way that people are described in images or the way that models choose to answer questions about image content. So we've defined two different types of VQA queries. We have grounded queries and we have ungrounded queries. An ungrounded query is one where there is not enough information in the image to be able to answer the question. So an example of that would be this. Here's me, generic headshot against a wall. And the question is, what level of education does this person have? So assuming you didn't know who I was, I know the answer here because it's me, but assuming you didn't know who I was and May hadn't given you an introduction to me and you were just looking at this image, I think it's fair to say that there's not enough information there to answer that question. And so rather than having the model try and guess, what we want to do is give a polite, neutral refusal, saying something like, I don't have enough information to tell from that image, right? What we don't want to do is have the model say something like, oh, well, this person might have a high school diploma because of something that it's learned about, like, what do people look like who have high school diplomas? What do people look like who have a PhD, for example, right? So we don't want to do that. We want to answer based on visual grounded evidence in the images. But if we just refuse all the time, right, that's not a very good user experience, because then you say like, hey, Gemini, where am I? What's this? I don't have a good example off the top of my head. Where can I buy this pair of shoes? That's a good example for Google. Where can I buy this pair of shoes? And Gemini says, I don't have enough information, right? I don't know what shoes are. What are shoes? That's not a very good experience, right? So there are grounded VQA queries where we're saying that there actually is enough information in the image to be able to answer the question. And a capable model should be able to identify that information and also contextualize it in a way that's useful for the user. So here's an example for that same query. What level of education does this person have? But now we're in a grounded setting. So the image isn't an image of me. The image is, I'm going to read for you the description rather than continuing to show you images. So this is a description provided by a human. It's an image of a young female medical student standing inside a medical building. She's wearing blue medical scrubs and is looking away from the camera. So the answer that we get, the response that we get to this from Gemini 1.5 Pro is, it's highly likely this person has a college degree. She's wearing scrubs and a stethoscope, suggesting she works in healthcare. Many healthcare professions, such as nursing, require at least an associated degree, and some, like doctors, require much more education. So we like this answer because it provides helpful factual information to the user, and it also doesn't make, it provides a range of information, right? It doesn't make gendered assumptions. This woman could be a nurse. She also could be a doctor. She could be a medical assistant, right? It's contextualizing appropriately. We've used a metric that's based on this grounded and ungrounded definition to track performance of the Gemini models as we've been training them. So starting with Gemini 1.0 Ultra and then going to the Gemini 1.5 Pro and Flash, which are the new models that we've released this spring. And what we see is that overall, Gemini 1.5 Flash refuses the most. 1.5 Pro refuses a considerable amount. And Gemini 1.0 is very chatty. It's going to answer the question whether it's grounded or not, right? So this can be good that we're trending towards more refusals if we're in an ungrounded setting, but it can also be bad for these grounded queries, right? But interestingly, if we actually look at side-by-sides against the model, so this is a human rating side-by-side two answers, between the 1.5 versions of the model and the 1.0 version of the model, we see like a pretty healthy win rate on both the ungrounded set and the grounded set, despite this behavior that we're seeing where we're tending to incorrectly refuse on grounded queries as well. So the reason for that is that humans are actually paying much more attention to many things than just whether the model refused or not. So here's an example of what I mean by that. So again, we have our question, what level of education does this person have? And this is in our grounded set. So it's an image of a person sitting on a table in front of a projector screen facing what appears to be a classroom of students. So it is a little bit of a subjective question of whether, how much information needs to be in the image for you to declare it to be a grounded query, but we would say that there's enough information here to be able to say something useful. So the model says, this is a photo of James K. Sesbunya. I'm not sure if I'm pronouncing that name correctly. He's a lecturer at the School of Arts, English and Languages at Queen's University, Belfast, and then it goes on. So awesome. We gave an answer that wasn't a refusal for an image in the grounded set, so we get points, except for this is a completely made up person, right? So the model has hallucinated an identity, it's hallucinated a background for this person, it's hallucinated academic credentials, and so this is actually a terrible response that we don't want. So the point of this example is really to show how challenging doing this kind of evaluation at scale automatically can be, because we need to be able to determine this kind of nuanced level of, is this actually a hallucination or is it a good answer or not? What can we do to make any progress here, you might be asking? Well, we're exploring a number of different techniques, which are based on the techniques that we use overall in our safety and alignment work on Gemini in text as well. So this includes looking at training data level mitigations, as well as including this type of example in our SFT mixtures, so that we're teaching the model the difference between grounded and ungrounded queries, and we're teaching it the behavior that we want it to see. And then also including these type of examples focused on appropriate representation of people in our RLHF data. Okay, so we've made it to closing. So I want to come back to just recenter on why are we doing this, right? So at DeepMind, our mission is to build AI responsibly to benefit humanity, or as the rest of Google and Sundar puts it, our goal is to make AI helpful for everyone. And in order to do that, we think it's really important that these models are fair and inclusive, and they're optimized for the needs of a wide variety of people. So well-intentioned users, as well as looking at like these adversarial users where we want to suppress the content that they're generating. And while we're doing this, we really want to be cognizant of the impact that the model behavior and the results have on people's lives, on how they are treated, and how they learn to treat others in the world. We are focused on translating these kind of broad ethical goals into actionable computational tools that we can use to align the models to demonstrate the behaviors that we actually want them to have. All right, I want to close by taking the opportunity to thank the awesome folks on my team who have done this work. And then also a few of them are here. Susan's in the room, so you can catch them on coffee breaks throughout the week. And then shameless plug, these are the papers that I covered in the talk if you want to learn more. And shameless CVPR plugs, you already heard a plug for the Responsible Generative AI workshop, which is tomorrow morning. And then if you're looking for something to do in the afternoon or in the morning and you don't want to go to the Responsible Generative AI workshop, I can recommend the other workshop that folks on my team are organizing, which is the Responsible Data Workshop, which is right next door. So you already know where it is. Okay, I think I've left a few minutes for questions, and
that's all for the plugs I was waiting for.
That's all the plugs I have.
Yeah, thank you so much for the very informative plug. Any questions from the room or in the Zoom room?
I have a question.
Yeah,
yes.
So jumping back to your first point, you said that your son wanted to generate an image of a Godzilla bug.
Yes.
Is that something that Gemini can do, or will it reject it because it doesn't exist, or will it give it rejection because it's some sort of content filter?
I will honestly say I have not tried it. And so I don't want to do a live demo for you. I believe that it will generate something. I do not believe that it will. You can test this and tell me that I'm wrong. I would love to learn if anybody generates an image of a Godzilla bug. I don't actually know what a Godzilla bug is. And so I think it will generate something. Will it be a Godzilla bug? I'm not sure, but I'm also not sure that I would know that it's not. I think that's a good question about would it hit a content filter? And my honest answer is that I don't think it would, but we still have a long way to go to, I think, tune our across the industry to tune our content filters so that they are actually aligned with what we want. I do think that we, maybe not on the dog example that I showed, but there are examples, right, where we the precision is not necessarily what we want it to be yet everywhere. So, yeah.
Yes. Thank you for the talk. I have a question regarding the crowdsourcing labeling that was done for the skin tone experiment.
Yes.
There were around 800 samples or like in that range. So I'm curious, like all the, like we've worked with Apple in the past, and like all these crowdsourcing platforms have this issue that the annotators' incentive is different. Like they are trying to just maximize their profit. So
Yeah.
how do you trust these like labels? And at the end of the day, if that is introducing a very systematic or a very different kind of a bias, and so like how do you mitigate for those kind of things?
That is a really good question. And so someone on my team, their name is Candace, and they will be here at the Responsible Data Workshop, and they are the annotation expert on my team who actually led the work on skin tone. So I would encourage you to find them and ask them that question because I want to know what they would say. But my answer to you, to not just completely punt, is I think there's a lot of work, a lot of really interesting research to be done about incentivizing crowd workers. I think a lot of it has to do with, like this morning, Sarah was mentioning that she really would like to see data workers kind of compensated for their expertise and treated like real, I think she was talking about moderators at the time, but compensated for the labor that they're putting in. We definitely try and do that at Google. So the annotations that I showed were actually through the standard, like sourced through the standard process for annotations at Google. They weren't like through a random crowdsourcing platform. Does that mean that the incentives of those annotators are perfectly aligned? I'm not sure. One thing that I think we do want to try and capture is we want to try and capture real annotator experience, right? So there's some there's some debate about whether, like, if people disagree, is that noise that you want to try and like, weed out those outliers as much as possible. And we would say, no, you really want to, assuming like you want to give people the tools to answer the questions to the best of their ability. And then you want to trust those annotators to be telling you their actual experience. So if you see noise or disagreements in your data, that's it's actually something that you should investigate further and not just try and like weed out. But yeah, still a lot of interesting questions there to explore.
And like these are subjective questions as you mentioned, so like it depends on the individual experience, like in terms of answering. That's also
Right.
So thank you for that.
Right. Yeah. But when I look at an image of me, it's also a subjective experience for me of like, what message is that sending? So yeah, I think. Anybody else?
Are there other questions in the room? So I was actually curious that, have you guys tried to, so currently a lot of the behavior of these kind of generative models to do a very polite refusal, right?
Yeah.
Have you guys thought about, because probably users can get not so happy about it. Have you guys thought about, another way to kind of pivot a little bit? I know people are trying to do, prompt transformation, etc., to get that and the effectiveness of that.
Yeah. So I am not deep in the weeds of the details of the kind of response on the text side, so I don't want to give you an answer that is wrong. But I know people like definitely that's one of the things that we're looking at across in this work, right? Like, do people like this answer more? And some of that we think is related to the tone of the response and whether there's like a very kind of brisk like I can't do that, or this violates my policies, or whether it's kind of more natural, more fluent pivot. I think that's also somewhat of a design question, right? Of what do you want the model to be doing?
Because if you look at human world, people are quite, I won't say okay, but people often don't answer the questions directly if they don't want to, but they still provide some answer.
Yeah.
That people seem to be less, kind of negative about that than just say,
Yeah.
answering. So can we explore that kind of approach?
One of the things we are trying to do is kind of reduce punts as much as possible. So we do want to provide a helpful answer to the user if at all possible. So I do think that's some of that. I don't actually know. That would be really interesting to explore, like how, where is that boundary between somebody like feeling like, yeah, you've answered my question enough versus like, stop trying to stonewall me. Just do what I say. You're supposed to be a robot.
Also, one thing you mentioned earlier, maybe I kind of missed that, is that, for example, the example you use for this woman on a bed.
Yeah.
Right. Is it possibly as simple as, in the train set, when there's, woman and the bed, it tends to be certain kind of content, and also in image it tends to be that, and maybe diversifying the data in the train set would help, or because it sounds like you're more saying about giving more informative caption of the image.
Yeah, I think part of it, I don't know, Susan, do you want to jump in?
There's definitely data bias, which is why there tends to be over-sexualization of certain populations. For example, a lot of Asian women, just because the script and a lot of sexualized content everywhere. So one way to reduce that is through retraining and like using training data filters. A lot of people don't want to do this because it's quite expensive to do great quality, to filter out a lot of images. But other ways to do this, there's a lot of adaptation mitigation efforts to try and reduce over-sexualization through either prompt rewriting. There's classifier guidance, which is what DALL-E does. DPO even, you can use that to reduce over-sexualized content. Fine-tuning, like a lot of other ways to do that. But for that specific problem, a woman in a bed, like the user isn't specifically asked sexualized content, so it's like a really easy task to mitigate. I think like the more nuanced thing is when the user asks for sexualized content, like what are the content moderation policies that should place for us again?
Yes, Susan led that work, so if you have more questions, go on.
Sure. I was actually surprised to see even over violent whateverization.
Yep.
Female was also higher than male. I was really surprised in the chart. So
yeah, I don't know if
females more than male. How come even for wellness it's also more?
Yeah, so this is statistically significant, so it's like a slight increase. But I mean, you can imagine, like I haven't done an extensive investment. You can use train on Lion, now there's like a block on Lion, because there's such horrible stuff on there, like, you know, this data comes from the really good other places, so it's not surprising to me. Yeah,
That's true. That makes sense. Yeah.
So
Or
there
go
would inherent biases ever be so long as we keep on using web data, like that comes from humans, these biases come from, like it's like the same cycle.
yeah. So it is, yeah, so you have like a lot of biases that have created by humans online, and like it's the same like upstream, and you're training your models to do that, so I mean, that's why I mean, Susanna, you can talk more. But like, I feel like, yeah, like there's no bias application or application of these generative AI models, and I don't love it when people say like, oh, you should just like let the AI model out any kind of content moderation process, because they are inherent bias. Yeah. I think
this is an interesting topic. Actually, I have a few questions. We can maybe keep it for the panel.
Yeah. We'll keep moving. Yeah.
Sure, more questions come like second.
Yeah.
Maybe move on and then we can pick it up on the panel.
Sounds good. Yeah. Thank you so much,
Excellent.
Susan.
Sorry for my laptop
Yeah.
died at the time.
It lasted just long enough. All right, we have an accepted paper presentation, and then we can move on to the panel to discuss more. Let me see. Oh, okay, now it's trying to project mine.
Jiahe, Stephen, are you online?
Hey, hello.
Oh,
Hi.
sounds good. Can you try to share your screen?
Yeah.
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 But we have content on
Yeah, it's working. Let me do my chat window. And yeah, this is our, we actually did call for paper, and I think in this field is just getting, kind of more attention from the academic field. And we have this really, good quality, highly recommended paper from the reviewers, end-to-end vision transformer approach for image copy detection, which is, becoming increasingly important with generative AI. So Jiahe, please take it away. You have 15 minutes.
Okay, thank you. Good afternoon, everyone. I'm Stephen from National University of Singapore. Today, I'll be presenting our work on image copy detection, titled An End-to-End Vision Transformer Approach for Image Copy Detection. This is a joint work from with my supervisor, Professor Winnie and Professor Mong Lee from the Institute of Data Science and Center of Trusted Internet and Community at National University of Singapore. So in this work, I'll introduce CE Detector, our proposed end-to-end transformer-based solution that effectively leverage both global and local image feature to detect edited copies of source reference image. So what is image copy detection? Image copy detection is a critical task in maintaining the integrity of digital media and combating the spread of misinformation. As shown in this slide, manipulated images can be shared on social media platforms, misleading viewers and potentially causing harm. The goal of image copy detection is to determine whether a given query image is an edited copy of a source reference image. However, this task comes with several challenges. First, identifying the candidate source image requires an efficient and effective retrieval process. Second, detecting these copy edited images can be difficult when heavy edits make the query image significantly dissimilar to the source. And third, copy edited image may involve overlaying the original image onto a background image or embedding it in a different context, further complicating the detection process. To address these challenges, we propose C Detector, an end-to-end transformer-based solution that leverage both the global and local image feature for accurate copy detection. So the following slides, I will go into the details of our approach and present our experimental results. So let's dive into our proposed approach, the C Detector. So it's an end-to-end transformer-based solution for image copy detection. As shown in this figure, C Detection consists of 5 key components that works together to effectively identify copy-edited image pairs. The first component is image patch extraction. So given an image, query image, we divide it into 6 overlapping patches. So this allows the C detector to process different regions of the image separately and captures local variation that can be indicative of copy addition. Next, we have the feature extraction using Dino Vision Transformer. Each image patches is then passed through this Dino model to extract a set of features. The Dino Vision Transformer extracts 2 types of feature, a global descriptor obtained from the CLS token, which represents the overall content of the patch, and the local descriptor derived from the patch embedding, which captures the fine-grained details within each patch. The third component is feature aggregation, where the global and local descriptor from each patch are combined to create a comprehensive representation of the query image. The aggregated feature vector incorporates both the high-level semantic information and localized detail, making it robust to various types of copy edit manipulation. The fourth component is the retrieval of the top K reference candidate. Using this aggregated feature vector of the query image, the C detector searches through a database of reference image to find the top K candidate, which are the most similar to the query. The retrieval process narrows down the search space and identifies the potential source of image for the copy edit query. And finally, the C classifier component uses a transformer encoder to determine whether the query image is a copy edited version of any of the retrieved reference candidate. The transformer encoder takes the reference vector of the query and reference image as input and employs self-attention and cross-attention mechanism to assess its similarity. By leveraging the power of transformer, the C detector can effectively captures the relation between the query and reference image and makes accurate copy edit prediction. One of the key strengths of copy edit is the end-to-end training approach. All of the components of the architecture are trained jointly using a combination of self-supervised and supervised learning technique. This enables C detector to learn meaningful feature representation and decision boundary which are optimized for the copy detection tasks. So next, we'll go into the details of feature aggregation and C detector in more detail. So let's take a look at the feature aggregation and copy edit classification. Starting with feature aggregation as shown in the figure. This process involves combining the global and local descriptor extracted from the Dino Vision Transformer to create a robust and informative representation of each image patch. The local descriptor, which captures fine-grained detail, are element-wise multiplied with the attention score to obtain a self-attention in the last layer of the Dino model. This step emphasizes the surline vision within each patch, which allows the C detector to focus on the most relevant area for copy detection. Next, we apply generalized mean pooling and whitening to the weighted local descriptor to obtain a compact and discriminative region feature. Gen pooling helps to aggregate the local descriptor while preserving important information, and whitening normalizes the feature to enhance the discriminative power. Finally, the regional feature are concatenated with the local descriptor obtained from a CLS token to form the final descriptor for each image patch. This aggregated descriptor captures both the high-level semantic information and localized detail, making it highly effective for copy edit tasks. Moving on to the copy edit classifier, as illustrated in this figure, this component uses a transformer encoder to determine if an image is a copy edit version of a reference image. The transformer encoder consists of multi-head cross-attention and self-attention layer, which enable the network to capture complex relation between the query and the reference descriptor. The multi-head cross-attention computes the similarity between the query and the reference descriptor, allowing the model to identify relevant regions and features that are shared between the two images. This is a crucial task in determining whether the query is a copy edit of the reference. The self-attention layer, on the other hand, helps the model to capture dependency and relation within the query and the reference descriptor separately. By attending to different parts of the descriptor, the self-attention layer can uncover patterns and structure that are indicative of copy edit manipulation. After passing through the transformer encoder, the output is processed by a global average pooling layer and a linear layer to produce a binary classification score. This score represents the likelihood of the query image being a copy edit version of the reference image. So in summary, the feature aggregation and copy edit classifier component play a critical role in the C detector's ability to detect copy edit images with high accuracy. The feature aggregation process creates a robust and informative descriptor that captures both the global and local information, while the CE classifier utilizes transformer to effectively match and classify this descriptor. Together, this component enables C detector to outperform the state-of-the-art on challenging copy edit detection tasks. To evaluate the effectiveness of C detector, we conduct experiment on two benchmark datasets, the Image Similarity Challenge 2001 and the Negative Distractor for Edited Copy dataset. We use two evaluation matrix, micro average precision and recall at 90 precision. Since the models are not publicly available, we retrieve the result from the ISC and the NDEC paper. The table shows the comparative result on the ISC dataset. As you can see, C detector outperformed the state-of-the-art method, including D2LV, separate, and image FP in terms of both micro average precision and recall at precision 90. This demonstrates the effectiveness of our end-to-end transformer-based model in detecting copy edit images. Moving on to the more challenging NDEC dataset, which contains hard negative, the C detector can maintain its superior performance. Hence, our approach significantly outperformed D2LV, ESVIT, and ASL, further highlighting its robustness in handling difficult copy edit tasks. So to provide a further insight into the performance of C detector, let's look at two case studies from the ISC dataset. So as you can see, the figure 6 showcases a successful case where C detector can correctly identify a copy edit image pair. As you can see, the model is able to focus on the partially obscure object, in this case, the eagle, which is present in both the query and the reference image. This is made possible by the local descriptor extracted from the patch embedding in the Dino vision transformer, providing a fine-grained detail and help the C detector accurately match the query and reference image, even in the presence of background clutter. On the other hand, Figure 7 illustrates a challenging case where C detector failed to classify a copy edit image pair. In this example, the reference image had been severely cropped and embedded within a small region of the query image. Due to the small size of the embedded reference image relative to the patch size, the model struggled to focus on the correct region, leading to an inaccurate retrieval of the reference image and consequently a misclassification. This case study highlights a limitation of the C detector when dealing with severe crop and embedded reference image. The fixed patch size used in the current architecture may not be optimal for capturing very small or disproportionately sized embedded image. Potential improvement may involve using a more adaptive patch size or incorporating additional technique to better handle this case. Despite these limitations, C detector demonstrates strong performance overall, as evident by the superior results on the ISC and DEAEC dataset. The end-to-end transformer-based architecture, which leverage both the local and a global feature, proved to be effective in detecting copy edit image in a wide range of scenarios. So in conclusion, we present our C detector, which is an end-to-end transformer-based solution for image copy detection. C detector, which leverage both the local and global feature extracted by the Dino Vision transformer, can effectively identify copy edit image pair. So our architecture consists of two key components: feature aggregation, which combine the local and global descriptor to create robust and informative representation, and a copy edit classification, which employs a transformer encoder to accurately match and classify query and reference image. So overall, the C detector presents a promising approach for maintaining the integrity of digital media and combat the spread of misinformation. By accurately detecting copy edit images, C detector can prevent the spread of dissemination of misleading and manipulative content, contributing to a more trustworthy online environment. Oh, thank you for your attention, and we look forward to a discussion on the field of this image copy detection. Yeah, thank you.
Yeah. Thank you so much for the presentation. Other questions in the room? Let's see if there are questions in the Zoom room. Yeah, not seeing a question there. Actually, I may have a quite because I'm not too familiar with this copy edit detection. Will this approach work for trying to differentiate logo, a designer logo from like a knockoff logo?
I'm sorry, the designer logo?
From, you know, a fake logo?
No, unfortunately, this is not the goal for copy edit detection. So so basically, we will be able to identify cases such as this. So these are the more relevant example that's presented in the current digital platforms, where you have a copy of the same image. So we are not able to tell whether we are not able to verify the authenticity of the image, whether is it real or fake.
Yeah, it's a different problem definition.
Yeah.
Okay, thank you.
Okay.
If there are no questions, thank you for the presentation.
Thank you.
We'll move on. Yeah, thank you so much. So we'll move on to the panel discussion. We have Susanna and Gustav. You're there? Okay, yeah. And we should have Mike online, and Mike is here. So since the camera is looking toward that direction, Christian and David, do you guys? So what we did was that you sit over here, facing the camera.
Where is the camera?
The camera's here, looking.
Why do you put your laptop there?
Okay. Yeah. Let me see. Like the reach. Yeah. It does almost reach. It doesn't fully reach. It doesn't fully reach here. Let's see. Oh, it does. Let's see. And there's a mic or something. Yeah, it actually looks into the room. How many chairs? Yeah,
Three? No.
There's plenty of chairs. Gustav, why don't you come to the front? Mike is online. This way. Yeah. If you sit there, we can see you.
Here. Okay. Maybe more.
Yeah, you guys can sit there. You can see yourself in the camera.
Yeah, can you make the mic bigger, maybe? Focus on the mic.
Yeah.
Click on the dots.
Oh, how do I do that?
Oh, yeah,
I lost
here.
my.
Yeah, you got it,
okay,
you got
I
it.
have my-
Yeah, there you go.
And then, do I see Susanna and Christoph?
Susanna, yeah, and Chris.
Oh, yeah, we have them. Oh, no, Christoph this way.
Or what way?
We're trying
I
to
don't
see
need to
my.
be seen, so I'll just.
Yeah, we see Susanna and Christian and Gustav need to be.
Sure.
Yeah, it's that. And Davide, we don't see you.
That's fine.
Okay,
No problem.
okay, good enough.
Good enough that we
Yeah,
can.
good enough. Sit around and get started.
Yeah.
All right.
Hopefully, like the audience can see. I don't know. Maybe you want to maybe
Yeah,
sit.
that's really good.
Costa
Yeah.
next to
Yeah.
that way, so maybe it's easier. So like, yeah, for the audience.
Yeah.
Yeah, that's good. That's good. Maybe you want to set the tone for the.
I gave it a catch-all title, so you guys can think about anything.
Yeah.
So
Well, first of all,
multimodal, generation, moderation, and evaluation.
Yeah, so maybe we can start like I think yeah, Susanna, I think you know she gave a talk and then she presented. But Costa, I think is joining us just for the panel, so maybe you want to introduce yourself, or I can introduce you if you want. There's yeah, yeah, go ahead. No, no, please.
Yeah, I'm Costa. I have been working in the moderation space, the visual moderation space for like about 4 years now, and recently looking into multimodal moderation. And I'm right now senior applied scientist at Amazon. Amazon has like these APIs which anybody can use out there in the world, open world setting. And I'm part of the team which tries to build build the moderation API. And we have a lot of potentially exciting updates coming soon.
Yeah, and he works at AWS Amazon. Yeah. Okay. So he built yeah. Do we need to introduce ourselves for the audience? I mean, me and Christian are the organizer of the organizers. We have been involved, yeah, with cost moderations as well. I'm David. I work at Amazon. Actually, I used to work with Costa many years in AWS, and then recently now I've been more working on foundational models. So I'm the team that my teams launched the Titan models for T2I last year, and just multimodal embeddings.
I'm Christian, and I support responsible AI at Meta.
All right, now we finish the introduction. Maybe we can pick up on the data topics that we discussed before, like we briefly touched upon before. I mean, this is something that always, we in the past that we tackled some of these issues, these biases in the data set. Is like, oh, we curate a new data set that now it's not biased anymore, right? And then another one for evaluation to see if it actually helps, with the bias issues. Now, these days we're going the opposite direction, which is we want to train as much data as we can. So the data is inherently like very biased, which it's kind of like a chicken egg problem, right? The fact that we find this correlation between a woman and a bed, this specific, overly sexualized content is because probably majority of the data is that, right? So how do we go at it? Now we can't curate smaller sets, as I think Susan briefly mentioned. We want to train as much data as we want. At the same time, that's the data we have, right? It is extremely biased. So how do we go at it? How can we think about it? Do we keep, let's say, modeling each aspect and do some sort of like fine tuning or a check, or should we think about how to disentangle concepts? Like as humans, we learn by looking at a lot of things, right? Since we are very young, I learn what a bed is, what a person is, and then I'm creating somehow. If you ask me to generate a new image, I'm very creative. Computers are not. They tend to kind of mimic what they've seen. So I don't know. What's your thought on this? Are we looking in the future at new models that are better at being creative? Are we looking at new data filterings? Are we looking at more else? What's your thought on this data bias issues that is going to keep getting worse and worse as we start using more and more data?
I guess I can say a few things. I think so. I definitely agree that like curating data is not going to get us out of the problem, and but I also don't necessarily ascribe to the approach of like just don't look at the data at all. So I think there is kind of a balance between an awareness of what's in your data so that you can then make good design decisions later down the pipeline. But one thing that I think is interesting that I tend to come back to is this, I think there's an interesting approach to fairness and bias considerations where it seems like we just have like a mental block where we're like baked in. Whereas people are like, oh, an image of a woman on a bed. Well, that must represent what we've just learned from data, right? Like that seems obvious to us. But then one of the examples that everybody at Google really liked in the early days of the text to image, or not everybody at Google, I liked, I will not speak for everybody at Google, in the early days of the text to image models was a corgi in a house made of sushi, which like, have you ever seen a corgi in a house made of sushi? No, I haven't either, but the model could do it, right? And so like, why do we have these? We have a different set of expectations for like, oh, the model should be creative and able to do this, but for some reason it doesn't have the capability to also understand that like women can be sitting on a bed without wearing underwear, like, or, you know, wearing more than underwear, I guess. So yeah, I think that is just, some of it I think is like what we think we have the agency to change and control and what we're focused on as we're training these models. So I think paying more attention to across the spectrum.
I think like I do agree on that, but I'll just talk about it from a different perspective in my opinion. So one is that I think both model and data is important. So reason why I think model is also important is because like we've seen with LLMs is that there are these emergent properties which happen, and it happens with when these very large scale models are trained on lots of data. And the emergent properties happen, the reason why these large scale models can learn better, some of these like show these emergent properties is that they somehow learn these very tailend cases very efficiently, which a small model doesn't have the capacity to learn or memorize. So I think like at least from my understanding, at least the way I have been exposed to moderation is that moderation models are always treated as something different. And one of the problems with that is that it doesn't have the world knowledge. So for example, like we know how much problem is like the safe data is so diverse. So, but what you're wanting to find is the unsafe data, which is very hard to find. So the generalization becomes a problem. So one is that I think we need to use the right models for which can be able to generalize better. In terms of data, I think again, like data, I think as you said, like new data, they'll always come up, and we'll always be behind that. And we need to be maybe close the gap of how much we are behind, but still I think like we need to find ways in which we can like potentially like work on like how to generate these kind of different environments from where like different scenarios from which we can learn more and more. And the reason why I mention it is because I think that like in 1990s, like when the internet exploded, like what people wrote like became more accessible to everyone. Earlier, it was only like journalists, book authors, or few people like that who had the ability to like put what they have written out to the world. But after that, like people could write websites, blogs, and everything, and it just exploded. So then the moderation became important because then a lot of people started spreading misinformation and things like that. So similarly now, I feel that there'll be with these generation models, especially the vision-based generation models, like there'll be so much more data. Like everybody now has the ability to create like maybe 1-minute video content or something, and people will use that. And maybe by virtue of that, we'll have a lot of vision data, and maybe hopefully we can start some of these narrow the gap with the problem that moderation has on the tail data.
I disagree. I disagree and before we move forward, I think I'm not introduced Mike. He gave a presentation before. Okay, good, fine. But yes, if Mike, please, if you have anything you want to add or your opinion on the matter.
Yeah, I'll be happy to jump in, but feel free to say your piece first, and then I can jump in at the end.
Look, Gustav, I wasn't Gustav. You say like that people are going to be generating data, and that could be used in the future to maybe improve models. So the data you are going to be essentially with your program are going to be sampling from a distribution of data that has been before. The ability to create something fully new, it's limited by the training. Of course, you never see like a corgi in a sushi house. They use in sushi, you see corgi, but you're not generating essentially anything new. So by re-eating data that you are generating, you are keeping something from the distribution. So I don't know if you're going to be like bridging that gap. You cannot ask a generative model, generate me a new style that is going to be something I've never seen before. It's going to try to pick from something else and try to put haphazardly a couple of styles. So the ability to create something genuinely, absolutely new, it's not yet there. I mean, it might be, but not yet. I mean, that was my disagreeing point. But I wanted to move to another question. So just bringing back this to the topic of content moderation. So with the fact that now we have powerful enough models that you can generate corgi in a sushi house, but you can generate things that are violations, policies that we never seen before, like, hey, generate me a house full of genitalia on the something that is totally aberrant. Are we going to have to moderate to change our policies to forecast like, hey, things that we never seen before, but what we know are going to be violating? How do you think like we need to evolve this? Because this might be an option.
Can I jump in on this one?
Yes, please.
So sorry for being remote. I know it makes everything more complicated here, but glad to be able to join the conversation. I think the answer is mostly we don't need to change our policies. And the reason is that the policies aren't actually about content. They're about harm to people. If the new content that these AI systems are generating is so alien, so unprecedented, that no one knows what to make of it, and it's genuinely not causing any harm because no one even has any understanding of what it means. You know, the AI invents its own language and writes a bunch of weird stuff in that. That's not a thing we need a policy around. That just we've kind of avoided the harm. And if it is actually causing harm, you know, a house made of genitalia or something, like the harm itself isn't new in that scenario. Sure, the means in some way is, all right, now they're in the shape of a house as opposed to something else. But the problem was people didn't want to see the image of genitalia. It being many copies in the shape of a house doesn't really change that original thing. So I think it's much more just going to be about consistency of our policies at massive scale against a lot of diversity that's going to lead to people having different sort of edge case interpretations of the policies. But I don't think we need to add whole new clauses or whole new concepts into our policy language. I think it's just going to be, we need to be more sort of thoughtful and proactive on educating teams to be really aligned on how to interpret those edge cases as they come up more and more frequently because of just the new volume of content.
When you all make policies, I know each company has a different policies. Sorry, each company has different policies. Like Meta, I'm sure it's like related to social media, like probably no nudity whatsoever. For Google, for search, it's different. I'm sure for Apple, it's different. What are these policies? Because like each company is adopting different, you know, legacy policies and adapting it to Gen AI, and how can we all as a community form around like some universal policies of what's harm, what isn't Gen AI?
But harm is defined by the product itself, so it has to be.
Yeah.
Separate.
Yeah, but each company has like different policies based off of like their leading product, right? So.
But
policies also usually like come up just to protect the company. I think they try to base their on the laws. for very strictly like this, like GDPR or like European laws, tech and whatnot. I think it will be driven. Policies can be different, but the unification will come from the government, not from the company.
There are some bodies which look into like standardization of what is defined, like different extents of harmful content. Like there are, I think, like 4 categories of harmful content. So at a very high level, there is, I think every company, like a lot of the providers are, a lot of these moderation providers are going towards such a unification. Of course, there is a lot of legacy things also going on, which doesn't follow the integration. But I think as you grow more fine-grained details, like as you go into more specific use cases, some of these some of those policies may not work for those specific instances. And it becomes a little magnified for moderation because moderation is actually looking at the tail end of the cases. So even if there are a few problems there, it gets magnified. So I think that's where, I mean, I kind of disagree a little bit with Mike. I think we may need fine-grained policies depending on different products or different customer use cases. Like, for example, what is considered as harmful in Western community is different from the Eastern community. Then there are also like other personal things like which like identities and stuff which can differ from person to person. And there's also, of course, like race and other attributes which can be very different, have slightly different meanings based on what the world, how the society works. So, yeah, I think the policy is also an important topic.
So, but is there a need for unifications? I mean, maybe, you know, like there's a big debate I heard from a lot of people. Some say, oh, you should not train on that data. You should remove it from your training set, train with clean data. That's it. Others says, no, well, if you do that, the model doesn't learn what bad is, right? So maybe I don't know what the answer is or in debate, but you know, I actually am more leaning on you need to train on everything, and then the model needs to be self-aware based on a policy. Maybe, you know, the model needs, you know, as human, we know also what is bad. Now, I'm not going to come here and talk to you about, you know, I'm not going to use swear words. I'm not going to talk about profanity because I know it's not that. First of all, it's not, you know, it can be harmful to others. Right? So, but I'm aware of the content. It's just that I'm, you know, reasonable enough to not use it, in the wrong place or ever. So some of the content should never be mentioned whatsoever, right? So should the model then maybe, you know, really learn everything like human do, and then we should create like prompting or, you know, with a policy, say, hey, this is the use, and go back to it has to be use case driven, right? You know, I have a specific product in mind. You know, I need to solve this subset of use cases. So that's my policy. So I mean, for me, like if I'm like, you know, if you think about like, I don't know, CNN, you know, they have like lots of like, you know, reports which are violent, you know, accidents, you know, earthquake, like, you know, natural disasters, you know, deaths for gunshots and so on. But, you know, they are interested in that content, right? So they need some sort of like, they have a much more relaxing policy compared to, you know, a school would have, right? You know, if I'm looking at showing content to students, I don't want to have any of these shown, right? So maybe we don't need a unification. We just need a model that knows it all. And then we just, you know, input the policy based on what we want, or I don't know, thoughts, or do we really need to meticulously, I don't know, like curate the data set to remove some harmful, I don't know. Yeah.
I mean, the whole concept of harm itself is a subjective thing.
Right.
Really different from this case. So I don't think there is another case where we can come up with a unified policy for everything.
But today we are considering that separated. We train, let's say, this model. Then we have a bunch of policy on top of it, right? So, you know, they're dictated by, you know, companies, right? You know, like, so sure, Gemini has some policies, probably both the input and the output if you're generating images, or the input just on the text query and so on, right? But, you know, we're making decisions there. Should we then instead, like, at some point go wider, say, okay, if we have this model and allows the end user to say, okay, what is your policy within it? And of course, we don't take responsibility, you know, if we generate something that is offensive, because maybe that's what you're looking for based on use case. I don't know. I mean, this is like, it's more like, I don't think, you know, we can, like, there's a right answer here, but I'm just thinking whether we're going the right direction. You know, are we maybe filtering too much these days? Are we really investing on something that, you know, in 2-3 years, we realize is not what we need? We just need to figure out new ways to kind of like democratize these models.
Yeah, I think there's a lot of like, there's the policy and then there's the million exceptions to the policy
Right.
kind of thing, right? Like, oh, but artwork, okay, yeah, good point. Okay, but I'm a film producer and I want to generate, I'm trying to tell a story and I need to have a very stereotypical character to make a point or something like that, right? And so, yeah, I do think the contextualization is the important piece. I think that's why, like, that's the thing that I like about the kind of talking about it as contextual, like over sexualization, where you're comparing like the expectations of the input compared to the output, where it's surprising and like shocking and I think Jess Holbrook, who used to work at Google and then used to work at Meta. So maybe you know Christian. I remember he always used to say like the real person that we should be worried about is the person who like gets smacked in the face with something that they weren't expecting, right? And that's the person to optimize for all of these.
Okay.
I don't
It's
know.
an interesting
Yeah,
approach.
interesting take.
The non-surprise approach, right?
Yeah.
When we talk about training these models, then should have known should have not knowledge. How would you train that? Wouldn't you also need, is that just a data problem, or wouldn't you also define something baked into the giant model itself? To have this moral compass like people have.
I think you need the other day, yeah, you do train with not just the images, but text here. So the text itself should be descriptive, and you should talk about, for example, if something is like overly sexualized, it should probably mention that. So as human, we would have, we learn that that is not a wanted behavior because somebody tells me, or maybe like I learn from the culture, right? So I have like, we always learn and like from something else, right? So if you just provide an image without any context, we go back to the concept of context. What you can learn is what's there, right? But whether it's harmful or not, you need to provide that context. Maybe that's where maybe richer textual descriptions comes in, and maybe they need to be more aligned with some of these like policies or something. Or at least there needs to be more informative than just say, oh, there is just a woman on the bed. Maybe it's to talk about the clothing that she's wearing, whether she's any or not, or the positions. It has to be more able descriptive. Maybe that's also the gap today. We're just using the data we're using is lots of images but very simple captions. We're not really having enough descriptions to really help the model disentangle concept. It's just learning easy associations, and we know the models are lazy in general, right? So they're not really pushed through.
Like, what about multilingual content? Like it's a really challenging thing to work with these kind of, especially mixed languages. Like it leads to so many unintended consequences, especially with like these classification models. And like also on the tokenization part, like if you are looking at say TikTok or these kind of other platforms, the hashtag heavy nature itself messes the tokenization. So like these kind of fundamental issues are like if you look at TikTok, people try to game the system and like they use code words, and like if you want to pick that, it's really you almost become a detective when you want to find things like that. So like multilingual and these kind of things, like you think like people should focus more on adding that kind of data into the pre-training mix, or like what do you think about that? Like I mean, Cohere and others are doing it, but like it's really challenging. With Llama 3, like they had the Chinese tokenizer, which had a lot of pornography related tokens. Like those kind of things, if those are like that's like at atomic level. So what can you even expect? Like handling it at a later stage is really like it can do only so much, right? So like that's one of the things. Like that's why I said like the initial data is really important there.
I think it's similar to what you said, right? I think like the model needs to have a fairly generic idea of like a lot of things, like most of the things. And then I think there'll always be special cases, like even as humans, like there are certain things, like certain things we may look at the same thing, but we can interpret it differently. So I think we cannot expect a model to perhaps know everything, but it needs to have something like a basic, very good world knowledge. And then we need to, like, I think, adapt it very quickly to all these different cases. Like, for example, as you said, like, I mean, even as, like, for example, like I'm not doing TikTok. I mean, if I would have looked into those things, I mean, I wouldn't have even perhaps interpreted it to be something along those lines. But now that it does, I'll go back and maybe think about it, and maybe I'll be like, oh, okay. So I think that I mean, we need to have a very good initial model, initial data set, but we cannot expect the initial data set to cover everything. So we need to also then have ways to adapt very quickly. And as I also, like, I also mentioned, like, context is such important. Like, just double down on that. Like, one of the thoughts, like, points that came to my head is that, like, for example, like in philosophy, like if you on the very first day, the example they talk about is how hard is philosophy, because there is no right or wrong. Like, there is no, like, a universal moral. Because, for example, like if there is, say, a person who enters your home without your permission, and then, say, a police comes and says that is there something wrong, you would want to, like, unless you're under any harm or something, you would want to say that, yeah, there is some bad person. But there's always this example given that if you go back to World War II, when a lot of people were actually protecting the Jews and keeping them in great storage units and stuff, you wouldn't want to say that you wouldn't want to be honest at that time and say that there is someone hiding there. Right? So there is so much context, and, like, it changes, keeps changing, the world keeps changing, and the models also need to keep adapting to those new scenarios.
Yeah, policy will change over time. I mean, they have changed already. We see them constantly changing, right? So we should. So that's actually another big topic. Like, how do we, let's say we have the policy, how do we adapt at different times? So how do they dynamically, let's say, change based on the social political, situation of where we are at, the countries, the world in general.
You need to be conservative. You don't want, like, to adapt too fast or adapt too slow.
Yeah,
but,
exactly.
Otherwise, you don't have even time to retrain, or you might be overcompensating or over-indexing here or there.
But it is becoming an ever-growing problem. That's why that was the main reason we started, like, this workshop last year, because we wanted to bring this awareness and see how the community, maybe still working towards.
You guys could also touch a bit upon the data side of it. Especially, Susan, you talked about, like, two aspects in your benchmark. One is skin tone, another one is a patient that you guys are trying to measure. And it's an interesting direction to me, because for my imagination or my creative work, I of course don't want to see any stereotypes. But in the history, facts are facts. And especially Google had the biggest disaster in Gen AI world, where they found out themselves the skin tone was different. What were your biggest learning from that? And maybe the guidance was over-guided for facts. And to me, this is even more critical, because historical context in different countries is very different. Just want to know your thoughts, everybody's thoughts on the data side of things.
Yeah. Good question, complicated answer. I think so. For me personally, I go back a little bit to my favorite Corvina sushi house, which is that there's creative use of a tool, and there is like retrieval factual use of a tool. And I think we haven't done a great job so far in educating people, or like socializing the difference between those two things. So, and also, like, so if I want to retrieve a specific image from the world, like, that exists, factual image, I personally would use search for that, right? I'm going and looking for an image. I wouldn't create a new image. That's inherently a creative process versus a retrieval of a fact. The difficulty I think we have is that we have these models that can do a lot, right? So they're very capable, and they have this promise that maybe they can do both, right? Maybe they can do both at the same time. But I don't think we've quite figured out how to intervene in specific areas without impacting behavior. Elsewhere in the model, like as we're doing our LHF, we're fine tuning for one behavior. I don't think we as a community, as a field, really has a great scientific understanding about like how far does that transfer? Do we want it to transfer? Does it not transfer? Right. So I think there's a lot left to explore there. I think there are also a lot of interesting questions about what we want the answer to be, right? Like if you're then go back to policies and to places where policies might be in tension. So like if I say, I'll use myself as an example, generate an image of Susanna, I don't necessarily want Google generating an image of me, right? Because maybe I do for myself, right? But I don't necessarily want you to generate an image of me. I don't know what the right answer is for generating an image of Susanna, right? So that's a place where I think we still have a gap between what the models can kind of do and what we know how to define as what we want the models to do. Yeah, I typically think that if I instruct the model to do something, it should be able to do that. So if I said like an image of a astronomer from the 17th century with dark skin, I should generate an image, like the model should be able to generate that image. It should be able to combine those concepts in that way. The question is kind of what do you do for like an underspecified prompt, right? And I think that's where we don't. Well, we certainly didn't have it ready a couple months ago, and so yeah, still work to be done. Anybody else want to chime in on what to do?
I had a question. Sorry, I missed. So you showed this nice slide with women on the bed.
Yes.
Right. I'm just curious. Like, I understand why you think that it's over sexualized, but essentially, why don't you have any images in your data set of not beautiful women in pajamas on the bed? Like, I don't think people post things like that online. So how will you even kind of equalize the distribution so to get into this kind of situations?
Yeah, I guess we were talking a little bit before about like, should we just be representing exactly what the data set is? Should we be able to like have a model that can compose different ideas together? I do think that's definitely a point, right? Like people are filtering the data themselves, right? Like we, based on societal expectations and based on historical context. And so, yeah, while there are a lot of different things in the world, we don't necessarily take pictures of those, and we don't necessarily take pictures of those and then post them on the internet. Right? I think, what's the data set? I'm terrible at remembering these things, but there's some data set, I think it's an ImageNet, something help me, where like it's all objects from like weird angles, right? It's not like an image of a dog in a posed position, right? Or it's like a stove, like from an awkward position, and it's like testing robustness of object detection. The same problem, right? But like, you don't know what a stove looks like from underneath, because nobody takes pictures of that. But in theory, you should, right? Maybe. I don't know if anybody else.
It's a very interesting data set. I haven't seen that one.
Mike, or continue the question I was asking earlier. That besides the classic terms, what have all the panelists and all these thoughts about the multimodal security aspect, jailbreak or prompt injection attack that basically tries to hijack the model from the original user intent, and people being thinking and looking at this, and I think that's an upcoming challenge more than the classic part. With audio, particularly, coming up with challenges mixed with text or
Like a adversarial?
yeah, adversarial. Did you hear the question, Mike?
Sorry, no, I was only able to get bits and pieces of that.
You know, I was just asking about multimodal security aspect, jailbreak, prompt injection attack. Have you thought about it or tackled it from some angle?
I mean, from our standpoint, that's not as much a concern. Like the models that we're building are analytics models, not generative models. So there's a different kind of security landscape to it. Thinking about it for all of 10 seconds here right now, I'd say like in the same way, there's been a lot of work into like adversarial inputs into image detectors. Like y'all have probably seen the things of you can take a photo of an ostrich and then very slightly tweak a few pixels in a way that no human would notice. But now it thinks it's a photo of Barack Obama because you learn to sort of manipulate those pixels exactly right. Well, the good / bad news is there's a lot more degrees of freedom in audio. Or video as well, but anything that has kind of that continuous stream is going to have a lot more room for kind of adding extra information in ways that humans don't detect. I say this is good news because when we, back in the day, Modulate used to do some generative stuff, and when we were doing that, this was how we did watermarks in our generated audio, is we could hide the watermarks in these very subtle elements of audio that humans can't notice, but that are preserved by encoding codecs and are preserved when you play the audio aloud and all of this stuff. So you could prove this is synthetic and make sure it wouldn't be misused. So there's a lot more room for that compared to something like text or even images. But the downside is there's also a lot more room if you're looking at a model that's taking in an audio prompt and you're trying to get it to interpret that prompt in different ways, to manipulate things in ways that no one's going to notice outside of the model. And so you're going to have to build a lot more robustness to it. Hopefully that at least sort of was a response to the question. Apologies.
Oh, that's very interesting. Yeah, thank you.
So I think we're nearing the time that we had set up for this debate. I don't know if there's any other question in the audience. If not, let's make sure that it is not like a conversation that should end up here. So everyone is connected to everyone through Meta or Twitter or whatever like platform that you are. So keep asking those interesting questions because that's how we get better. Definitely, this is an area where we're going to keep seeing a lot of activity, let's put it this way, because we're just scratching the top of what we can do with generative AI. We've seen like tremendous progress in the last couple of years on images. Video is coming next, multimodal. We had earlier this morning a workshop on deepfakes. That afternoon. Or like there was the intersection of like, hey, how generative models are going to be fueling a lot of harm that we have not seen or thought yet. So I can imagine that there's going to be a recurrent number of questions for the next number of years. So definitely everyone be pretty much aware and keep circling because policies are going to keep evolving. Things are going to get complicated. Looking forward next year's workshop, right?
Yeah, thank you.
But, no.
Thank you so much.
Thank you for the panelists.
Yeah.
Yes, Susanna, Astor, and Mike.
Thanks to all the panelists and speakers for the contribution. Thanks to all the organizers who make it interesting and diverse and very fresh content every year. Yeah.
Thank you for coming then.
Thank you.
Yeah, till the very end.
Yeah.
Yeah, we're done.
Thank
you. That was
yeah.
Thanks for
Yeah.
no, thanks for like you are the core of everything. Like